Bharat, you may start.
Yes. Hello everyone. Good morning. I am Varat Kulkarni, and I consider this my distinct pleasure to welcome you all to the BAHA SA India 2025 workshop, hBAJA workshop. Over the next 2 days, we will delve into the exciting and rapidly evolving world of hydrogen mobility. We aim to provide valuable insights and foster a deeper understanding of these emerging technologies. Uh, Baha as a journey started in 2007, and after the inception of IDEA by late Dr. APJ Abdul Kalam, we started in electric mobility in the year 2015 by the category E-Baha. Then expanding our business and expanding our territories, we have introduced two new categories last year, that is hydrogen Baha and autonomous Baha. Hydrogen Baha, being a newest addition to the categories, experienced the participation of three teams last year. We conducted all three events, also the endurance run, which was a successful trial. This year, the participation has increased to 7 times. This is a testament to the increasing interest and importance of the work we are collectively advancing. To commence this workshop, it is my honor to invite Dr. Balraj, the chairman of Baha SA India Organizing Committee, who is also affiliated with one of our esteemed sponsors, BPCL. Dr. Balraj, your guidance and leadership have been pivotal in shaping our journey. We are eager to hear your thoughts. Please unmute, sir.
Oh, am I audible?
Yes, sir.
Yes,
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 sir.
yes.
So SA India has been one of the biggest, engineering college student initiative in our country, and we have with us about 5,000 professional members, 40,000 plus students, and currently 495 collegiate team. We have a lot of events conducted under the banner of SA India, the Aerathon, the Supra, the FE Cycle, the Tiffan, and the Baha, which happens to be the flagship event of SA India for a very long time. We commenced our journey in 2006, and the first chapter of Baha was conducted in the year 2007 with a very small number of college teams. Being the first year, we had just 23 teams then, and thereafter this event grew, and there was no end to this growth. At one point in time, we had almost 500 plus teams participating in the FBAHA. We then started the eBaha under the direction of late APJ Abdul Kalam in 2015, and this event, the eBaha chapter, is also growing, and currently for this year we have over 70 teams participating for the eBaha event. We also started the hBAJA event last year in 2024, which was a success. And this year too, we have a huge number of teams for the hBAJA event. hBAJA is another exploratory event that we started, and we hope to have the first event of hBAJA 2024 in the month of September. And we continue this journey as has been in the other formats of the event. Every event has grown, and it has also provided a lot of out of classroom training for all the engineering college students who have participated. A lot of engineering college students have been absorbed through the campus that we have and we conduct. And I'm proud to say that some of the Baha students are today placed at top-notch automobile companies and ancillary companies, not only in the US, but also Europe and India. So that is what is the flagship event Baha is all about. And I'm very proud to have been associated with this event since inception. And I wish all the participating students of hBAJA the very best as you embark upon this competition. Thank you very much.
Uh, Thank you, Dr. Balraj, for your valuable insights. Your experience and visionary leadership continue to inspire us and elevate the standards of our work. Next, I am privileged to welcome Dr. K.C. Vora, the esteemed advisor of BAHA SA India, who has been a constant source of wisdom and direction for our team. He has been with us since the inception. Dr. Vora, we look forward to your address.
Thank you, Bharat. And am I audible and am I visible?
Yes, sir, you are audible and visible as well.
Thank you. Thank you. So good morning to all the sponsors, the organizers, and the participants. It's a privilege to be here in this inaugural ceremony of the hBAJA workshop today and tomorrow. And yes, I remember my days 2007, we started the event in December 2007. And then last year, we decided that we will start working on H, that is hydrogen. This all happened when in 2023 January, Government of India released green hydrogen economy plan. And under this green hydrogen mission, the Prime Minister said that in 2047, we will become energy independent. That means we will not get any imported crude petroleum or electricity or anything from outside. Everything will be within the country, and we will become Atmanirbhar in terms of energy. You know, the energy needs keeps on increasing for industry, for domestic purpose, and also for vehicle purpose. And also our Prime Minister has said by 2070, we will become net zero. That means we will not produce any carbon dioxide by 2070. That's a huge commitment to the world from India. So we decided that we would also start working on hydrogen, and we will also work towards energy independence and net zero. And that's how we started hBAJA. Initially, there were 10 teams which registered, but finally, in January 2024, there were only 3 teams which participated in the hBAJA event. And the event we were able to successfully complete with 3 cars running in the endurance race. And this was a very good event with 3 teams, that is Team Sanskara from Sri Chhatrapati Sahu College of Engineering, Aurangabad, Team Tarusa Motorsports from School of Engineering, QSET, Cochin, and Team Amigos, the Sri Vishnu Institute of Technology, Bhimavaram, Andhra Pradesh. So one from West, one from extreme South, and one from Andhra Pradesh. Like that, 3 teams participated in this event, and they completed the 1-hour endurance lap with 1 CNG refilling in between. And this year, we expect that with hBAJA, that is 18% hydrogen in CNG, we would be able to complete maybe 2 laps, or 2-hour lap, or even a 4-hour lap in the endurance. So that's what we look forward, and we are very lucky. We have around 19 to 20 teams who have registered for hBAJA, and we are working very hard to ensure how do we get the hydrogen and the HCNG fuel, what type of optimization would be required on the engine, and the trials on the engine, trials on the vehicle. And then we just have 5 months, somewhere in January or February, we will be having this event. I would also like to have a privilege to declare the conveners of hBAJA SA India 2025. The convener for this event, hBAJA, is Dr. Kalimuddin, the R&D head of Greaves Cotton in Aurangabad. Dr. Kalimuddin was the joint convener last year, and this year he is nominated as a convener of hBAJA 2025. And I am very, very confident with his able leadership, he will steer this event, BAHA 2025. And I think that not only India, the entire world will look at us that we have, as an organizer and with students, we have been successful to fire engine with 18% hydrogen in CNG. Then we have joint convener, and we have also a new sponsor this time, that is Volvo. And From Volvo, we have Mr. Makarand Lad as the joint convener of the event. And Makarand is a good friend, and he has taken his training and experience not only in India but also abroad. And he's here back to India in a couple of years at Bangalore. And I'm sure the technical knowledge which Makarand has not only in the field of CNG or alternate fuel, but also in the field of hydrogen will help us to move one step further towards 100% hydrogen in future. So we are starting with 18% hydrogen this year, but I am very sure that in future it would be 30%, 50%, and if possible, 100%. It is expected that by 2026, our country would be ready to produce green hydrogen. That means hydrogen would be produced by electrolysis, but the energy required to do the electrolysis would come from solar energy and wind energy. So that's Makarand Lad from Volvo Group. And our co-convener of the event is Mr. Saurabh Suman. Saurabh Suman has been taking a lot of pain from last 1 year in hBAJA and from last 3-4 years in overall BAHA. He works in Mahindra and he has extensively worked on engines, alternate fuel, and he is the lead engineer at Mahindra and Mahindra. So I am sure with full support of Saurabh, we will be able to do this event successfully. So a lot of work is required. So Saurabh and his team would be working behind the curtain and will be making this event successful. So with these three stalwarts, Dr. Kalimuddin, Makarand Lad, and Saurabh Suman, I am at a very relieving state where I am very sure hBAJA would bring laurels to not only SAEINDIA but also to India. Thank you very much.
Thank you, Dr. Vora. As we move forward, it is time now for our the address to listen to the address of our conveners. So I would like to request Dr. Kaleem to share his thoughts.
Yeah, good morning, everybody.
Good morning, sir.
Good morning, sir.
Yeah, good morning, everybody. It's a pleasure to me to be a convener for this hBAJA event, and definitely will come to the expectations of the team that will demonstrate the best out of all BAHA competitions. And to my experience, I am with BAHA since last year. I was co-convener, and the learning what I have seen is a superb team management, product development, the process, the event, everything was superb to learn for this event. And for the participant who are the new, I feel that this is an opportunity for them to learn all the systems for the product development, because the system followed hBAJA is similar to the industries, what industries are following. So if you are serious in all this buggy preparation and for you're doing this hBAJA project, I'm pretty confident that you will perform better in your future life, especially if you're working in industry. And as far as hBAJA is there, last year we have already demonstrated 3 buggies, and the team has done an excellent job there. It was the first experience for them. The way they have made out their buggies and they have performed their endurance test and everything was remarkable. So I anticipate the same thing this year also, and rest assured from the team, from myself, Mr. Makrant, Mr. Saurabh, you will get full support from all the point of view, and for the product development activities, for the process, for the documents, and whatever the support you need, rest assured from the team that there will be full reciprocation from our side. And I anticipate that the team will perform better than last year, because now 19 teams are there, what Dr. Vora has suggested. And from the Greaves Cotton, we are going to give you a CNG engine, which will be compatible for HCNG. The detailed presentation will be coming on in second half by me. So the product is already in the field for the 3-wheeler application. Now the same engine was been applied for the hBAJA application, where it was demonstrated successfully. So all the details of the product from the Greaves Cotton will be shown to you in afternoon. As far as Greaves Engineering, we are manufacturer of small light engines, diesel engines, CNG engines, LP engines. Now we are migrating towards hydrogen, ICE plus fuel cell. Then we are exploring other alternative fuel like ethanol and other things. So we are in the energy segment for automotive application as well for genset application and marine applications. So my best wishes to all the team members, and rest assured from our team that you will get full support to demonstrate best of your performance and ability in hBAJA. Thank you very much.
Thank you, Dr. Kalimuddin. And we are all eagerly waiting for your presentation in the second half today. Next up, we have Mr. Makran Lad from Volvo Group India. Over to you, Mr. Makran. Hello. Sir, you're not audible. Please unmute. Makran sir, we can't hear you. Please unmute yourself. Hello. You are still on mute mode.
I think he is not able to unmute himself. He sent a message in chat box.
Okay. Just a minute, sir.
Magran sir is having some network connectivity issue. He's just rejoining in a minute. So kindly be patient for that. Thank you.
Yes.
Meanwhile, Magran sir starts.
Yes,
Yeah,
I
I
will.
think he has joined.
We
Just
will.
a sec.
So,
He has
Makran sir,
joined.
he is having some network issues. Until then, we will hear what Saurabh Suman has to say. He is, as Vora sir told, he's a part of Baha since 4 to 5 years now. Let us hear from him. Yes, Saurabh sir.
Bharat, let me know whether am I audible and am I visible?
Yes, sir. You're audible as well as visible.
Thank you. So it gives me an immense pleasure, first and foremost, to be a part of this huge community. And I'm really obliged to be associated with BAHA from last 5 years. So having not wasted a lot of time as my part of today's opening remarks, I would like to first wish and congratulate everyone who is here and we are witnessing the advent of its first ever HCNG BAHA in any kind of undergraduate level competition across the world. So let's be proud of that for a moment. And I also would like to thank each and every of the leaders and our alumni team under the able guidance of our AC heads and the respective conveners who have made it possible. Now coming to a part of all the teams. So coming to a part like what is phase one? So phase one basically is the starting point for each and every team. Here we want the teams to be familiarized with the technical guidelines and the limits of the design for the BAHA vehicle as per the BAHA is India rulebook. And we know that the BAHA is India rulebook for hBAJA this year will be on the way in a couple of days. Secondly, we want you guys to study various concepts and lay down complete technical specification of the proposed vehicle along with the CAD model. And finally, we want you to understand the make and buy decision as an overall. So similar to our previous editions of BAHA and similar to what we conducted as as the CNG BAHA 2024, it will be a two-phase round. The phase one will be preliminary round 2024, which will be a non-elimination round. And however, the scores obtained will be used as an overall summation of your competency. And finally, we will have an online virtual dynamic event. Then we'll conclude finally to the phase three. So with this, I would like to share with you the final phase one guidelines. Rhythm, I request you to kindly share the screen. Yeah, so to all the team members and all the people presently in the call, we would like to declare the dates which we have unofficially already declared in our previous meetings, that we'll be having our phase one commencing from 6th of September to 8th of September. So as you all know, there will be a quiz round. So quiz round will be on 6th of September from 7:30 p.m. onwards. And the presentation round will be from 8th September 10 a.m. onwards. So the detailed slotting regarding all the things of quiz presentation, all the support material, everything will be provided by our team. So please be patient and kindly follow the social media and the forum for the further communication. Thank you, Varid. Back to you.
Yes, thank you, Saurabh sir. I think we have sorted the issue with network issue with Makaran sir. We can have his address now. Makaran sir.
Makaran sir, are we audible and can you hear us? Seems to be a small glitch again.
Okay. Guys, until we wait for 2 minutes, we have an issue to sort. Next, we will be having over 6 sessions throughout our day, as we all know. The first one being zero carbon mobility. Then we have second session on hybrid powertrain, hydrogen powertrain technology. After the break, we will be having exhaust after treatment technology for H2IC engines. Then we will have hydrogen CNG, Bifuel engine and control system session from Dr. Kalimuddin and his team. Then we have hydrogen and CNG kit, injection kit, and components integration. That particular topic will be delivered by Rajiv Gaiki, Mr. Rajiv Gaiki from Advantech Fuel Systems. Also, then at the end of the day, we will have a DFME and DVP session for engine and HCNG kit. So this will be our walkthrough. I think Makaran sir has, he can unmute now, right?
Meanwhile, we are trying to figure out, Bharat, you can just give a small brief also about the further topics,
Okay.
what is going to be expected. Meanwhile, we are just
Yes,
sorting it out.
yes. So, guys, what the thing is, our first what we can say session, it will be zero carbon mobility, and as we all know, hydrogen is a clean fuel, right? It burns clean. It doesn't leave any residues. So that is, and also Vora sir said ki our PM, Mr. Narendra Modi, he has promised that by 2070 we'll be carbon neutral. So be able to use and being able to manipulate the usage of hydrogen in today's vehicles and mobility engineering, which constitutes a very large chunk of what we can say industries in India. So being able to use clean fuel in that will contribute to a larger extent, right? So that is what we are aiming for our what we can say participants and everyone to get a hands-on experience on that technology, because it will be futuristic. Like we can use the knowledge we gain right now in somewhere in the future. So that is what is expected from you guys, to get the knowledge, to acquire the knowledge, and use it in your further projects. Then we have hydrogen powertrain technology. Makran lad, he is an automotive expert, we can say, with 17 plus years of experience in this industry. So his words of wisdom will surely help all the teams to what we can say to integrate all their components, or to ideate something, or to conceptualize something. Then after that session, we will have exhaust after treatment technology. So what exactly do we mean by exhaust after treatment, right? So exhaust, as we all said, hydrogen burns clean, right? So hydrogen burning clean, it will need some of the treatment, right? We cannot just let all the exhaust effluents into the atmosphere. So for that, we will have a detailed session from Mr. Srinivasan, who is also a part of Volvo Group India, a specialized person in thermofluid dynamic analysis and integrated powertrain modeling. So he will be sharing his thoughts on that thing. Next up, the biofuel engine. As we all know, last year we have used CNG kits, CNG engines, but this year we are planning to use 18% hydrogen, right? So basically, it will be a biofuel engine where hydrogen and CNG will be coexisting. So that part of topic will be explained to us by Dr. Kalimuddin and his team. As Greaves Cotton, they are pretty much specialized in developing these type of technologies and IC engines. So they have relevant experience for that. Then we have hydrogen and CNG injection kit, components and integration. Advantech Fuel Systems, they manufacture these injection kits and components. So we will be having Mr. Rajiv Gaiki. Rajiv Gaiki, he was also one of the panelists for last year's hBAJA event. He will be sharing. He also has that exposure to what all goes on and in this industry. So we will be having a very brief session about that thing today in the second half. Then we have Dr. Vora, who will share his thoughts on DVP
Hello.
and DFMEA.
Hello. Okay,
Yes,
guys. Okay, now I'm audible.
yes.
You're audible, sir.
Thank you, Makaran sir.
Okay.
Over to you, Makaran sir.
Okay. Thank you, guys. Uh, what I would like to tell you is basically last year I was at this hBAJA event as a judge, And I saw the process, and I really admire the way it has been conducted. But apart from that, most important what I found is the student enthusiasm. There were only three teams who took part last year. And then I brought all these stories, my experience with the Volvo Group, and explained basically how important this event is, what the student undergoing various process learning as a part of this event. And then we decided that from this year we will start sponsoring it. So that's how we became the gold sponsor. And as you guys know, all the fresh students or all the right now undergoing maybe second, third year, or maybe some master students here. The Volvo Group is basically also focusing on hydrogen power technology development. So we saw the connection here that as we enter in this phase of development from India, it is also important that we need to upskill and we need to skill our future generations in this. And this is one way we are approaching, and with this approach, we are going to mentor you, all of you, in terms of hydrogen powertrain. It could be the powertrain technology, or it could be the safety aspects, it could be storage systems. Me, Dr. Kalamuddin, and also Saurabh will be here as a technical guide for all of you for your journey in this hBAJA event. And I'm sure that we will be able to do this event very successfully. And this year I'm hearing it's 19 teams are there. That shows the enthusiasm and the importance of hydrogen becoming in India. As you know that I think Dr. Vora already talked about this green hydrogen mission. But last week I was also at one of the conference in Delhi, which also emphasized on the alternative fuels importance because Prime Minister is now taking the farmers not only as Annadata, they are transferring them to the Urja Data. That means it's not only the food what they will grow, but they will also be able to sell the energy or produce the energy related crops in future. That's how the importance of alternate fuel is becoming in India. And they are connecting dots not only with the transportation industry, but the basic ecosystem of India, where the 65% of the economy or the population is dependent on the agro economy, and that's how they are connecting to that. So India has a very bright region, and I would say that we are in the best time of the our life because we are working in the transition. So right now, this decade is a transition for the whole world when it comes to the automotive industry because there are so many technologies which are being explored right now. And hydrogen powertrain is surely going to be one useful and important technology out of this. So I would say that there is a demand from the industry, and here you have the opportunity to learn and work on this. So use your opportunity to maximum possible. We are here to support you for whatever technical issues or learning or mentorship you require and we will make it successful. All the best to all of you. Thank you very much.
Thank you, Makaran sir. So let us begin, right? We are all been waiting here for what is planned. So without further ado, let's kick off the first session of the day. Now, we are honored to have with us Mr. Ashwin S. Raj from Mahindra and Mahindra. With over 12 years in alternative fuel technology, Ashwin, sorry guys, sorry, my mistake. Now, first of all, we will have Mr. S. Hariharan, the head of alumni committee for BAJA India 2025 season, to deliver a vote of thanks. Over to you, Hariharan sir. Hari sir. Okay, it seems Hari sir is having some network issues. So without further ado, let's kick off the first session of the day. We are honored to have with us Mr. Ashwin S. Raj from Mahindra and Mahindra. With over 12 years of experience in alternative fuel technology, Ashwin pairs hands-on experience with a bachelor's in mechanical engineering, a master's in automotive engineering from VIT ARAI, and an executive MBA from IIM Kozhikode. His focus on natural gas powered engines and the utilization of biogas for automotive and power generation is exemplified through his 5 patent applications, one of which has been awarded. So, Mr. Raj, he will talk about zero carbon mobility, natural gas to hydrogen. This session will provide you insights into the transition from natural gas to hydrogen in achieving zero carbon emissions in mobility. So, over to you, Mr. Raj.
Ashwin, before you start, participants are requested to kindly be carefully listening to these presentations. And if you have any doubts, any queries, anything, you can post your queries in the chat and we will take it up after each and every presentation. There's a dedicated Q&A slot for each. So with this, I would like to hand over to Ashwin. Over to you, Varadan, Ashwin.
Hello, Ashwin sir.
Hear me?
Yes, sir. We can hear you.
How about the presentation? I share it from my laptop, or you are going to
No,
scroll
sir.
to?
The screen is sharing, like being shared.
Okay.
Yes.
So I'll ask you to change the slide, right?
Okay, fine.
Good. So we can go to the next slide.
Rhythm.
Yeah.
Yes, sir.
First of all, before getting into the session today, I would like to take this opportunity to thank the SAEINDIA committee here for giving me this opportunity to present this topic today. And this is not much different from what we discussed last year, though. And also, I want to take this opportunity to congratulate each and every one of you who have joined here today, because in many forums, I have heard this many experts saying that if you want to do hydrogen development, hydrogen ICNG development, you have to start from natural gas. And that's exactly what hBAJA has done. Last year, we started with CNG, and this year we are going to HCNG, and we are trying to push forward to reach to H2. So this, I believe, will be a pioneering development in the scope of HCNG itself, because worldwide, if you see all the development effort which has happened in terms of HCNG, you see that most of those engines are heavy-duty engines. And this is a very unique case where in which it will be a very small engine which will be using HCNG. I think Kalimuddin sir can correct me if I'm wrong. Otherwise, I think this is very pioneering activity from BAJA side. And as Vora sir said during his inaugural speech, not only India, the entire world will be watching us. So we can go to the next slide. So to start with CNG, CNG is not something very new. It's actually started from 1860. And this individual here, Etienne Lenoir, ran a prototype vehicle using something closer to CNG. This vehicle is called a Hippomobile. You can go to Google and search about it and understand how it is. I just want to bring to the perspective that it's all bus today, but CNG is a bus today, but it's not actually very new. The concept is existent from 1860s. We can go to the next. What is CNG? CNG is basically constituent of methane. Okay, methane is the basic composition of CNG, I would say. It has 4 hydrogen atom and 1 carbon atom. So it is any other hydrocarbon like ethane, propane, butane, etc. It is formed basically like all other petroleum sources trapped under the layers of rock and sand in the earth. And the use of natural gas in the transportation sector began as early as 1930s. We can go. Next slide, please. So I just want to break the belief that natural gas is not safe or natural gas is risky or it's unsafe or something. Natural gas is actually safe. It's non-toxic. It's actually colorless and odorless. But where do you get that smell from? That smell of natural gas comes from a substance called mercaptan, which is added to the natural gas to give it that particular smell. Otherwise, when it gets leaked out, you will not know that the gas is leaking. So if you have some pungent smell when the gas is leaking, you understand there's a gas leak and you go and try and arrest it. That is why this substance is added to natural gas. It's lighter than air due to its low density. So what happens is that if the natural gas escapes or if there is a leak, it floats above air. So it quickly rises above the atmosphere and there is no fire risk. But if you see a gasoline, diesel or an LPG spill, these gases are denser than air and they would accumulate on the ground and it will wait for fire. So in that way also natural gas is considered to be very safe. And hydrogen is also like similar to natural gas. It's very lightweight. As soon as it escapes into atmosphere, it will dissipate much faster. Natural gas has a combustion limit between 5 to 15%. What does this mean? You need to have at least 5% natural gas to 15% natural gas in air mixture. So if I take 1 kg of air, you need around 5% of natural gas to 15% in that to burn it. Otherwise, or higher than that also it cannot catch fire. Lower than that also it cannot catch fire. Octane number of natural gas is 120, which means it has better anti-knock properties. You can slightly increase the compression ratio of the engine compared to a petrol engine. That is another good property of natural gas. We can go forward. There has been a recent uptick in the natural gas market in India. India is aiming to have around 17,500 pumps by the year 2030. It is environmental friendly compared to petrol. It has approximately 30% lower CO2 and it is cost effective also. Today, if you see the CNG prices average across India, it is somewhere around 5 to 8 rupees lower than diesel. And I would like to bring your attention to the left bottom image in this slide, which is a very recent data from JATO Dynamics. You can see that how the CNG market is picking up. You see that there is a drop in petrol market share, diesel market share, the electric vehicle and the hybrid electric market share is picking up. But the overall CAGR rate of the cumulative aggregate growth rate of CNG market has been really appreciative in the recent past. We can go forward. So I just want to share how this natural gas distribution is happening in India. We have LNG ports across our LNG terminals across 6 ports, I believe. And from there, through natural gas pipelines, it is connected across India. And today, as we speak today, almost across the country, we have natural gas availability. CNG stations are available across India. Next slide, please. So from this is purely from Mahindra portfolio though, we can have passenger vehicles, commercial vehicles and gensets operating on natural gas. But this is not the end of the story. Natural gas is pushing its boundaries further. You can see it in the next slide. Can we go to the next slide, please? So if you see, natural gas has taken its way forward into the tractors and backhoe loaders, etc. Where we currently see that there is JCB has demonstrated a dual fuel backhoe loader, and Mahindra also has demonstrated a CNG tractor. New Holland has demonstrated a CNG tractor. So natural gas is breaking the boundaries of PV, CV, and genset, and it is going beyond. I have used some jargons here. Okay, well, let's get into jargons. Before that, I want to take you to 4 key properties of fuels. Yeah, 4 key properties of fuels which will help you understand these fuels better. First is the higher calorific value of the fuel, which is higher for natural gas CNG from gasoline and diesel. Auto ignition temperature is a minimum temperature required for fuel to catch fire. So for CNG, it is 540, gasoline, it is close to 280, and diesel is close to 210. And that is exactly why diesel is a combustion ignition fuel, because it has a lower auto ignition temperature. For CNG, it has a auto ignition temperature of 540, so it needs much higher temperature to start burning by itself. The stoichiometric air fuel ratio of CNG is 17.2. For gasoline and diesel, it is close to 14.5, 14.7. The octane number for gasoline and gasoline is around 80 to 85 to 95. For CNG is around 120 to 130, and for diesel it is around 45 to 55. That is cetane number, not octane number. We'll go to next slide. So some jargons we have used so far. In my previous slide also I talked about dual fuel. So it is necessary to clear the air. We need to understand what all these jargons are, because in your future presentations or when you are being evaluated, you may come across the jargons and you may get confused. So just want to make sure that you are clear with what you what is there in your mind. NG stands for natural gas. CNG is compressed natural gas, means it is usually compressed and stored at 200 bar as per PESO standards in India. CBG is compressed biogas. Compressed biogas and compressed natural gas both have basic constituents methane or CH4. Only thing is that the source of fuel is different. For CNG, it is a petroleum source, and CBG, it is a bio source. That is the difference between CNG and CBG. LNG is liquefied natural gas. If you cool down this gas to minus 183 degrees centigrade, this gas will liquefy, and then you can store in cryogenic tanks, and that is called LNG. LNG is also basically methane only. It is only liquefied natural gas. PNG is piped natural gas. If you are from any several parts of India, you can see this gas pipeline board or this marker on the road. So gas is pumped through these pipelines across India, and this is slightly above the atmospheric pressure it is being done, and this is called piped natural gas. HCNG is hydrogen CNG, which is standard usually used is 18% of hydrogen in CNG. And LPG is liquefied petroleum gas. It is completely different. It is having primary constituents as butane and propane. It's not about methane. Okay, that you have to be very clear. We'll go to the next slide. We will see to these three jargons also. This is even more important, I would say. When you say a monofuel vehicle, a vehicle which can operate only on one kind of fuel. Usually this term is associated with CNG vehicles, and it means that a vehicle which can run only on needs CNG. So the compression ratio of the engine will be optimized for running on CNG, like it will be somewhere around 11.5 to 12. And it is useful only in areas where CNG refueling station vicinity is nearby, or you have a refueling station nearby. Otherwise, what will happen is that once you empty the fuel, then you cannot take the vehicle back to refueling station. There is a problem. You cannot bring the gas and refuel the vehicle, right? It's not like petrol or diesel. So that is one challenge of monofuel, but monofuel gives a higher efficiency compared to other two options. I'll come to bifuel next. We'll understand bifuel. Bifuel is gasoline and CNG. Now you have two tanks. One is a gasoline tank and other is a CNG tank. And since the vehicle has to operate on gasoline as well as on CNG through the selection switch, okay, there will be a selection switch. If you put to CNG, you go to CNG. If you switch to gasoline, you go to gasoline. Many of you must be having a bifuel vehicle in your home, or you must have at least traveled in an Ola Uber where these are bifuel today. Most of the vehicles in taxi segments are bifuel today. So we have to stick to the gasoline compression ratio here, because gasoline has a higher knock intensity, and for gasoline knock tolerance we have to stick to gasoline compression ratio, and this for around 9.5 to 10, I would say. And this will reduce the efficiency compared to a monofuel engine, because the engine is not converted completely to operate on CNG. Next is dual fuel. This is a completely different concept. Here you have diesel and CNG. You understand, bifuel, there is both the fuels are like spark ignited fuels. Gasoline is also spark ignited, CNG is also spark ignited. For dual fuel, diesel is compression ignited and CNG is spark ignited. So here actually you don't have a spark plug in the vehicle, but then how the CNG will catch fire? We will inject a little bit amount of diesel, which is the primary fuel, which will burn, and due to that temperature the CNG will catch fire. Okay, in ratio we are replacing some amount of diesel with CNG. Okay, that is dual fuel. Don't confuse it with bifuel. I have seen many people confusing these two terms. Dual fuel is different. It is in the CI engine where you have a primary fuel and a secondary fuel. Primary fuel is all usually diesel, and the secondary fuel is a gas-based fuel. And it can be used as an add-on retrofitment kit. You just add the CNG kit to the vehicle and optimize for diesel reduction. You can run on dual fuel mode. You have to stick to the diesel compression ratio only, because when you don't have CNG on the vehicle, you still have to run on diesel alone. So you don't have the liberty to modify the diesel combustion geometry. You have to stick to the diesel combustion geometry, and it will have reduced particulate matter emission, and it will reduce the operating expenses for the user. And there is a property of fuel flexibility, because if you don't have CNG, you can run on diesel alone. If you have CNG, you can run on a blend of both. That is what dual fuel is all about. I hope this concept is clear. If there is any clarification required in this concept, we can discuss that. We can go to the next slide. This is another key thing that you have to keep in mind when you are working with CNG, or for that reason hydrogen, the energy density of the fuel. So if you have 1 liter diesel, okay, you need 5 liter CNG at 200 bar to meet the same range or to meet the same energy density. Okay, I hope you are clear with that, because CNG exists as a gas. The gas has a lower density. The density of CNG somewhere is close to 0.6355, I believe. So you need to have 5 times the storage capacity of diesel to meet the same range, operating range, when you're working with CNG. Or if you are going to LNG, you have to liquefy to minus 160, and you need to have approximately 2 times the storage size of diesel to meet the same operating range. And if you are using CNG, how you are going to store that fuel? You have primarily these 4 types of cylinders are used. Type 1 is the traditional steel cylinder. Type 2 is steel cylinder with a composite reinforcement, which is not generally seen in usage because of cost and viability reasons. Third one is composite cylinder with a metal liner. And fourth one is composite cylinder with polymer liner. You see, as we go from type 1 to type 4, the weight of cylinder comes down and the price of cylinder goes up. That's what we see. But for CNG, traditionally we go with type 1, and recently the type 4 also is becoming more economical. The viability case is slowly improving. And for hydrogen, we usually stick to type 3, type 4. And recently you can Google and learn about type 5 cylinder and cryo compression technology for hydrogen. I recommend this for additional reading purpose, because these are 2 new emerging technologies in terms of fuel storage on board. Can we go to the next slide? So these are just few images which I downloaded and took here to show you how CNG cylinders are being packaged on vehicles, which are locations, how the alignment is done. And in India, this storage and use is governed by 2 key standards, AAS 024 and AAS 028. I recommend you download this document and study somewhere around 30 pages document. Read through, because this is your Bible or your reference for safety, anything related to safety when you are operating a dedicated bifuel or a dual fuel vehicle with CNG. Okay. Once again, I recommend every one of you, please refer to this document at least once. It will help a lot. We can go to the next slide. So this is what is it for you. This is the most important slide for you today, and I'll take some time here so that you understand it. So I don't know if I can use a pointer here. Okay, forget. We have 2 CNG tanks here. This is the CNG fuel system in a vehicle as a whole. Okay, so what all are coming in this, I'll explain. Please understand this one and ask if there is any clarification required. So you have 2 CNG tanks here at the left side. I've put 2 boxes. One is a high pressure side and one is a low pressure side. In the CNG tanks, we store this gas up to 200 bar. Then you have a tank valve. From the tank valve, the gas is coming out through high pressure stainless steel. Usually stainless steel or carbon steel, both are used. Steel pipes. From here, you have a pressure gauge which will show you how much pressure is there in the tank. There is a refilling valve. From this valve only, when you refuel, the fuel will go into the cylinders. In some cases, when you have single cylinder, the refilling valve and the pressure gauge and tank valve can be integrated also. That is also possible. From the refueling valve, we go to something called a high pressure filter. Why do you need a filter in the case of CNG? CNG is already a gas. It's not like petrol or diesel. But still, why do you need a filter? Because when you compress this gas in compressors to put at 200 bar, the compressor oil and other particles may enter into the fuel, and which can lead to some issues with your CNG injector in the vehicle. To avoid any such scenario, we use a high pressure filter. From the high pressure filter, it will go to a pressure regulator. A pressure regulator is where the pressure of the gas at 200 bar drops to the operating pressure of the injector or the fuel system which is used. It may be 5 bar, 2 bar, 3 bar. According to whatever system is available on the engine, the pressure regulator will convert the fuel from high pressure to low pressure. One thing you have to understand here is that this is a rapid pressure reduction process, and in this process there can be a cooling effect in the regulator. Due to this cooling effect, there can be ice formation and gas flow blockage. To prevent that, what we usually do is that we circulate the coolant from the engine through the regulator. This will ensure that the regulator is always warm. There is no ice formation or cooling effect happening in the regulator. From the regulator, there is a low pressure filter also, a small filter is used. From there, it goes to your throttle body, injector, or breather system, whatever you're using on the engine. And then you have the engine. So it is going directly to the intake manifold. Mostly it's an MPFI or a single point injection system. I hope you have understood this. If there is anything more clarification required, we can discuss this. We can go to the next slide. So I just want to give a crux of HCNG also, because this year it's all about HCNG. HCNG is 18% hydrogen in CNG. So up to this level, you don't need much modifications in the existing CNG infrastructure and the engine. So that is why we are trying to limit to 18%. And you get a possible reduction of carbon monoxide, total hydrocarbons, and methane emission, because actually you are replacing methane with some amount of hydrogen. There is reported marginal increase in NOx because hydrogen burns much faster. And there is a marginal improvement in efficiency also noted in different studies. One modification that might be required in the engine with respect to CNG is that some ignition timing adjustment, some calibration effort will be required to manage the higher rate of burning and to prevent if there is any knock. We can go to the next slide. So comparing CNG to hydrogen, we have started from CNG, we came to HCNG, and now we look at H2. Hydrogen has almost double the calorific value of CNG. You may see it. The self-ignition temperature is somewhere closer. This is one thing. The next thing, the combustion range is something which you have to keep in mind. CNG has a combustion range of 5 to 15% only, and hydrogen has around in air 4 to 74%, and in pure O2 4 to 94%. Because any concentration of hydrogen in air, it can burn. Okay, that is the most, I would say, key aspect with respect to hydrogen that we have to keep in mind. And CNG has a stoichiometric ratio of 17.2. Hydrogen has a stoichiometric ratio of 34. But usually we are operating hydrogen engines in the leaner side, maybe around 2.2 in that region. What are the key challenges of using hydrogen in IC engine? This, I believe, will be covered in the further topics by Makran sir. However, I just will give a brief introduction to give key challenges in using hydrogen in IC engine. One is a knock tendency. Hydrogen flame travels much faster than CNG. It's almost close to 5 times faster than CNG, and it will lead to pre-ignition and knock. There is a loss in volumetric efficiency because hydrogen gas density is very less. To meet the same amount of energy input, you need to input a lot of gas in terms of quantity, because the density is poor, and that leads to reduction in volumetric efficiency. The low end torque issue is same as it is related to volumetric efficiency, because you cannot take more air into the engine at the low end, because the air intake is limited by turbocharging capabilities, or you have to use a supercharger or something like that, and then you need to inject fuel. So low end torque is a key challenge. Hydrogen has wide flammability limit, that combustion range we already discussed about, and it can lead to backfire in engines. If there is a small opening or something like that, if the flame travels close, the last sentence you see, it has a lower flame quenching distance. The flame travels close to the surface. If the valve is marginally open, also the flame can travel back into the intake manifold. So that leads to backfire in hydrogen engines. And there's a need for a development of suitable engine oil for hydrogen, because there is a lot of water vapor or moisture in the output, and it can dilute the engine oil. So there is a need for suitable engine oil development. I think many activities are going on in that respect. and there is a chance of backfire due to flame quenching distance. I think that is more or less my slide deck, right? Thank you. I am open to any doubts which.
So thank you, Ashwin sir. If there are any questions, teams, I would like you to put it in the chat box. We will address your questions from there.
Further, you can also meanwhile check on. Can start taking the question directly. Okay, and meanwhile, you can check the YouTube live also and start asking. Yeah.
Okay.
Good.
So we have a question from Gautam Sen. Sir, can you please explain the CNG working flow chart?
Can you go to that slide where that layout diagram is there?
Yes.
Gautam, I believe you are referring to this slide if I'm not wrong. Correct, right? So, as I said, I'll repeat again. We have CNG gas stored in the tanks. Okay, we fill from here. We'll start from the refueling process. So we fill the gas at the fueling station from here. From here, the gas will go into the CNG tanks. Okay, the CNG tanks, it can be filled up to 200 bar. This is a limit determined by Petroleum Explosive and Safety Organization in India. You cannot fill above 200 bar. The tanks have a tank valve, cylinder valve, which will have an on-off valve also. It is mounted on top of the cylinder. From the tank valve, we have a high pressure steel pipe coming out. This can be carbon steel or stainless steel. Hydrogen, I'm just saying that for hydrogen, it is always good to go with stainless steel, or it's only recommended to go with stainless steel. Carbon steel is not recommended. And there is a pressure gauge usually used to indicate how much pressure is there in the cylinder. As I already said, sometimes if you have only one cylinder on the vehicle, this cylinder valve gauge and filling can be integrated into one single unit. From here, it goes to a high pressure filter. The filtered gas goes into a pressure regulator. The pressure regulator gives a standard output flow of gas at a fixed pressure rating. So it will be around different fuel systems have different pressure ratings. Some will be 5, some will be 3, some will be 2.5, some will be 2, etc. So whatever is the set pressure, the fuel comes out and it goes through a low pressure filter and it goes into the injector. From injector, it goes into the intake manifold and from there in the combustion chamber. So this is the low pressure side. Only to ensure that the regulator is always in the warm condition, because there's a rapid drop in pressure in the regulator. It can have a cooling effect. To prevent that, we circulate the coolant from the engine through the regulator. So if you see this diagram, there are these black dots are high pressure gas, dotted lines are low pressure gas, red lines are high pressure lines. So I think this is more or less clear. Any further doubt which I missed out or you want to understand?
I think we have a clear understanding of what the layout and what everything, how functions it. So next
This
question.
when you get the fuel system and the engine, you will be clear. You can refer back to what we discussed today. So it will be more or less same.
Yes. Thank you,
Hello.
sir. Yes, Rajiv sir.
Yeah. Ashwin, it's a nice presentation from your side, and you
Thank you, sir.
very well elaborate each and every system according to pressure base and everything. But I would like to add something. I'm not going to add in this slide. Uh, More and less, basically CNG system layout. I will be explain more in my next presentation.
Yes, yes.
If there is a doubt with this current CNG systems and layout, I will be explained very well. Not an issue. You very well explained already. But
Sure, sir. Thank you,
maybe
sir.
it will be a additive in the streams.
Yes, sir. Yes, sir.
Okay.
Thank you.
Yes. Next up, we have a question from Jairam. How can we test the fuel system after we assemble or build it?
There is no test as such for the fuel system. I possibly did not understand what exactly that question mean. Because there is
Okay.
nothing for which you have to test it. You have to run the engine and test it because you will be already
He's
getting a
asking for
tested engine.
leakage testing, sir.
Okay,
Ah.
so Ashwin, can I?
Yeah, sure, sir.
Yeah.
You are the best person.
Simply you have to use a soap water solution, all high pressure and low pressure lines. It will be if there is a leakage, any kind of leakages, minor, major, everything. It will be easy to identify with the naked eyes with the bubbles coming out from these leakage points. Am I right, Ashwin?
Yeah, sir. Yes,
It's
yes.
the easiest way to find out the leakage and other any queries. And even you can smell it. If there is a minor kind of leakage, you can smell. You can get a smell from the gas lines.
Yes.
Okay.
So no
Thank
Only
extraordinary
thing,
equipment required for this testing and for the particularly I am talking about the 18% of HCNG.
Okay.
yes.
Yeah.
So
For
next we
hydrogen,
have
for hydrogen things, it need a special equipment for the arresting or detecting hydrogen or hydrogen leakages.
Yes.
yes.
Thank you.
So yes, thank you, sir. Next up we have George Matthews. He's asking for the difference between bifuel and dual fuel engine again.
Can we go to that slide? Okay. Bifuel, as we discussed, we'll discuss this once again. You have two different fuels. Okay, listen to me very carefully. You have two different fuels stored in two different tanks, but both are in the same category. Both are SI engine fuels. And there's a switch which gives you an option to select which fuel you want to run with. Okay. But usually you stick to the compression ratio of the fuel which has the highest tendency to knock. So if you have a gasoline CNG bifuel, you have a gasoline engine, okay, and you have CNG stored in another tank. Using a switch, you can switch to CNG if you want, or you can switch to gasoline. But the compression ratio we used will be of gasoline only, and the efficiency will be lower than a monofuel engine, which is dedicatedly developed for CNG because you have to stick to the gasoline compression ratio. There is no other go, which will be lower than CNG compression ratio. That decreases the thermal efficiency of the engine. Now coming to dual fuel, same way, two different tanks, two different fuels. Both are from different category. One is an SA engine for fuel and other is a CA engine fuel. And the CA engine fuel is usually the primary fuel. The SA engine fuel is the secondary fuel. When the CA engine fuel burns, it will release energy, and getting that energy, the SA engine fuel will continue to burn, and that is how the combustion process happens. So this is an attempt to reduce operating expense and particulate emissions basically, and operate some flexibility in usage. This is an attempt to reduce the diesel engine with bringing natural gas into picture. Yes, sir.
Can I just put some more light on this monofuel, bifuel, and dual fuel?
Yeah. Yes, sir.
Yeah. Thank you. Thank you very much. Okay, what is meant by monofuel? Monofuel means single fuel engine. Single fuel engine is its engine only works on CNG or one segment of a fuel only. Means monofuel means CNG engine. For example, CNG engine works on particularly 11.1, 11.2 combustion ratio. So not engine should not take that much effort for the combustion and performance. For biofuel, same engine is worked on different uh, different fuel. Like a gasoline, you are using a gasoline means petrol for the combustion, and CNG for it is not a um, they are igniting themselves as a single fuel. But on the record, or for convenient for the consumers, if there is a CNG is get emptied, then it will be a pushed to the gasoline. This is happening with the commercial vehicle. Okay, so biofuel biofuel system is a different one. Now you have a out on that. My car is working on a biofuel engine, and both power means both performance are very well, but it is not in a commercial vehicle. So these cars, most probably I'm talking about the Suzuki cars, which is everyone having in a home. I may say that it's a CNG biofuel cars. So these cars are basically built on gasoline engine. Okay, understood the things. These engines are particularly made for the petrol, then it will be optimized for the CNG. So the combustion ratio of these engine is not that much uh, difficult to achieve the torque and power ratio for the gasoline and a CNG. For commercials, the commercial engines, commercial vehicle engines, these are converted from the diesel side, and compression ratio is reduced to from 17.2 to 11.2. So these are the main effect for on this biofuel engine. Now the dual fuel is a simply you have to ignite the first fuel like a diesel, and other other combustion will be taken place with the CNG. So you have a using only diesel, particularly for the combustion ignition or ignite the CNG engine. That is the main difference between the NG, biofuel, and dual fuel.
Yes, thank you so much, sir.
Thank you.
Yes, I hope teams would have gotten a
Thank you,
clear
sir.
idea about dual fuel and biofuel engines. The remaining questions we will have we will address those questions after Makran sir's session. So let us quickly get on with the next session. So we have a session on hydrogen powertrain technology led by Mr. Makran Lad from Volvo Group India. He is an automotive expert with 17 plus years of experience, currently at Volvo Group of India, specializing in alternate fuel powertrain development. He is also a published essay author, a panelist at industry conferences, and a mentor inspiring the next generation in automotive engineering. He actively promotes decarbonization initiatives and represents the voice of Volvo Group in various industry and academic conferences. So, Mr. Lat will walk us through the intricacies of hydrogen powertrains and how they are shaping the future of automotive industry. Let us welcome Mr. Lat to the stage. Over to you, sir.
I guess, can you request sir to unmute one time? Makran sir, can you try to unmute, sir? Now you can try, sir.
Hello.
Yeah, perfect, sir. Yeah, you are audible.
Yeah.
Thank you.
Yeah, but please understand, I'm using my two devices. One is laptop and one is the mobile. On mobile, I can unmute. On laptop, I cannot unmute. I don't know why. But then I need access rights for my laptop. I need to share
Yes, sir.
my.
I said you have been given the access right for both the devices. Can you try to present, sir?
Well, I can't. You can see I am sharing. I can't share the content. This is the message I'm.
Now can you, okay, now can you try, sir? Make presenter. Now can you try, sir?
No, still fine.
One second, sir. So the relevant rights has been given. 1 second. From bottom, the share option, what is coming, sir?
That's what I'm saying. I can't share content. You can't share content unless the host or presenter makes you. The
Sir,
presenter.
I'm changing your right to the host. Can you try that now? Now you should be able to do. Can you please take it? Check it one time, sir.
Think it is. No, not yet. Let me rejoin.
Yeah, just a second, sir. No issue. Yeah. Meanwhile, Bharat, can you just check him in the participant list?
Just a minute, I'll check. No, not yet. He has not joined yet. I think Makaran sir is here. Hello, sir. Can you share now?
Yeah. I think it is happening. Yeah.
Yes. You are audible as well.
Yeah. Thank you. It still shows. I think it's a bandwidth issue coming up.
Mm-hmm.
So if you don't mind, sir, meanwhile you're presenting, Bharat, you can share the first slider and maybe, sir, you can start your content. Meanwhile, once it presents, we'll give you a heads up. Or
Okay.
Yes. Can you
we are
guys?
able to see your screen, sir. We are able to see your screen. Yeah.
Okay.
Thank you.
Very good. Yeah. I hope you guys can hear to me also. Correct? Hello.
Yes, sir. You can.
Yes, sir.
Yeah. Okay. Because I'm going to the full screen. Yeah. So good morning, everyone, and sorry for all these technical glitches which happened in last 1 hour from our side. I don't know why, but anyway, sorry for that. But let's jump into the topic. So as you guys, I have been introduced nicely by the organizing committee. I'm Makran Lad from Volvo Group India Private Limited, and I have been working with Volvo Group from last 3 years on the hydrogen-related powertrain development topic. So before I jump into the topic, basically Volvo Group is a Swedish group. You may be knowing this, and we are from the Volvo Group Truck Technology in the business of heavy-duty truck segment, heavy-duty construction equipment, heavy-duty engines,
Uh,
and our engine. Hello.
excuse me, sir.
Yeah,
Can you just switch it to full screen mode? Just start the slideshow.
yeah. Just a second. There. Okay. Full screen mode.
So you might need to share the entire screen if you have shared a window right now. So if a window is shared, then the full screen is not visible.
Well, that's okay. Then just a second. I need to change that.
So you might stop sharing and you can share once again.
Yeah. Now is it visible full screen?
Yes, yes, sir. Just start the slideshow. Yes, sir. It is working now.
Okay. Thank
You
you,
may
guys.
continue. Thank you, sir.
Yeah. So as you guys know that we are part of the Volvo Group, and we are basically, it is in our DNA that we are going to work for the people, and we will be working by the people. So quality is one of the virtues. Safety aspect is one of the virtue. You may be knowing that the seat belt has been invented by Volvo Group long back, and it was patented. But then we released this patent in the virtue of the humanity, and in the virtue of basically this should not be patented. We thought it's not ethical for us to patent this important technology which saves the human lives. And absolutely, we do take care a lot about the environment. I think it will get covered in for the slides. So let's move to the next slide. So when we say that sustainability strategy, so why we are working here all, or let's say everybody in this world, not only Volvo Group. I think in the first presentation, Ashwin also clarified this presentation topic is net zero, towards net zero. So everyone is working towards net zero targets. So as a Volvo Group, when we say that our sustainability strategy or to achieve the net zero targets, we will focus on three key pillars: climate, resources, and people. So we know that the greenhouse emissions is one of the biggest threat to the planet. And this is what we are going to address to reduce the greenhouse gas emissions that will get reflected in our future products and also in our future product development process. When we say the resources, the planet's resources are finite. We know that the fossil fuels will not long last forever. And this is why we need to address to improve the efficiency of existing technology, which is primarily or predominantly based on the fossil fuels. And in future, whenever we go with the non-fossil fuels or fossil fuels both, but apart from that, we will be also focusing on the circularity aspects of the technology, irrespective of it is fossil or non-fossil in future. So circularity, repeatability, reuse are is going to be very important factor in our life for all the engineers. And the third pillar, I would say that the people, that means safety of the people. So we are not going to only work on developing product or let's say our technologies. So we are saying that our product has to be safe not only for the drivers or who is driving our product, but surrounding our product, like the traffic safety, diversity, and respecting human rights are important areas for the sustainable society. And we are determined to take this responsibility, and we have started working in this direction, I think, from last 10 year plus. Yeah. So what are our basic internal targets? Zero accidents in traffic, zero accidents at work, physical and mental well-being, diversity and inclusion, industry leading working conditions. So these are the values, we say that internally within a Volvo, that every engineer who works with Volvo Group, he has to work with this mindset. And to with this mindset, technological development, or let's say your skill sets which is required to develop the technology, that is one area of your contribution. But unless you have these things in your mind, this technological growth may not be a, let's say, ethical. And we need to say that we have to focus on these softer aspects or ethical aspects or more social aspects. So we are not going to say that we just want to earn the profit. It has to be a progressive growth along with the complete societies. With this, now I am jumping into the topic of, let's say, hydrogen powertrain technologies. But right now what you're seeing on the screen is a kind of a roadmap what we have taken internally, and many of the other OEMs or other companies might be having similar roadmaps. But let's talk about what we are saying that. So today we are somewhere here in 2024. Okay, before that, you can see that x-axis is basically timeline and y-axis is nothing but the percentage of the trucks what we are selling to the what. So we say that we are close to here. That means in 2024, we are still around 90% of our trucks which are getting sold in all over the world. India, Europe, USA, Southeast Asia, any market. These are basically a fossil fuel powered IC engine trucks. Okay. But from last 3 years, we are also saying that we are also started selling our LNG trucks. It's not 3 years, actually 2018 is the first time in Europe we started selling our LNG powertrain trucks. Then what we are saying down the line, as we move ahead with the timeline, by 2040, 2040, what is our internal target? We are saying that the IC engine technology powered vehicles will get reduced, okay, from today's almost 90% to maybe around 25 or 30% over here. It's not yet decided exactly, the time will tell, but this will get predominantly reduced to this. And but we are saying that IC engine will still continue be our part of the future product mix. We are not saying that there will not be IC engine. We are saying in our business that we are from the heavy duty truck segment. IC engine will continue even after 2040, but it will run on non-fossil fuels. Which are the non-fossil fuels? It could be LNG, it could be liquefied biogas, it could be biomethane, or it could be the hydrogen, or it could be the HVO also, hydrogenated vegetable oils. So this technology of IC engine will still be continued even after 2040 with the non-fossil fuels. Now, if we are saying that it will be around 25 to 30, what rest 70% will be? Yes, we have already launched our battery electric vehicle in a heavy duty segment in Europe. Okay, so we are saying that this proportion will increase almost to up to maybe 30 to 35% in future product mix. So we are saying that by 2040 we are aiming to have the battery electric trucks operating all over the world wherever we have the market to be a major contribution of future product mix. And in parallel, there will be equal amount of fuel cell electric trucks which will run on carbon neutral hydrogen. This is very important. Unless the hydrogen is green, there is no sense of all the activities which all over the world, whatever you're doing. It has to be, because everything is working towards the net zero. Everything or everyone is working towards the greenhouse gas emissions. All these fuel economy legislations or the emission legislation has come in the effect because of this temperature rise issues, ozone layer issues, Paris Agreement, science-based target initiatives. So all these have very single common goal to reduce the emissions, to reduce the contribution, to reduce the carbon content which is getting emitted either from the product or which is getting emitted during the manufacturing or the production of the technology. So everyone is working in that direction. And to make this happen successfully, we have to make sure that the battery electric vehicle in future has to run on carbon neutral electricity. It makes no sense if we still keep on using the thermal power plants to power our battery electric trucks. So basically, you are replacing the emissions from the tailpipe to somewhere else. Today, this is the situation. Today, we have started. If you talk about the India's contribution in the renewable energy till now is 35%. That means out of the total energy requirement of India, only 35% is coming from the renewable energy today. Okay, rest 65% still comes from the thermal power plants. That means we are using the coal-based power plants predominantly, and which we will continue to use, okay, in India. But by 2030, the government of India has set the target to have 50% energy requirement coming from the renewable energy. That means we are increasing our share of renewable energy to very high content. I don't know if you have seen this somewhere, but today 92 gigawatt, 92 gigawatt of the energy comes, 92 to 100 comes from the renewable energy sector. Rest 65% comes from the thermal power plant. By 2030, government of India says that they are going to increase this 92 gigawatt to 500 gigawatt. That is a 5 times increase in the renewable energy contribution will happen in next 6 years. And all the push of the government of the various ministries is in that direction. But by 2030, our overall energy requirement will also increase a lot because we are going fastest growing economy. We are going towards the third largest economy very fast. And to have this kind of position in the economy, it's basically the industrialization, manufacturing has to increase, export has to increase, in-house demand has to increase. And to meet all these requirements, basically you will require a lot of energy, a lot of electricity. And that's why we are focusing on the green electricity increase in India up to 50% by 2030, with the 500 gigawatt coming from the renewable sector. Rest 50% will still be from the maybe thermal power plant. But that to achieve in the context of India with such a huge population will be still a very good achievement. So this is very important that all over the world, right now I just explained about the Indian context, but rest of the world is also going towards carbon neutral electricity. If you talk about specifically the Nordic countries, that is Northern Europe countries, Norway, Sweden, Finland, they have really good source of the renewable energy. Their population size is also less, so they can afford today. Also, they are very close to more than 80% of their electricity demand comes, or electricity supply comes from the renewable energy. And that's why they can make the strategies that they will implement this battery electric powertrain or battery electric cars at a very fast speed. Whereas in India, it will take a slower pace because of our total volume in terms of the population. But message is very clear: the carbon neutral electricity everyone has to achieve. Then only this kind of technology will make sense towards net zero. Similarly, in case of fuel cell electric vehicle, it has to be a carbon neutral hydrogen or the green hydrogen. Unless the hydrogen is produced from the renewable energy, okay, for making the hydrogen, it requires the energy. And today we are already using the hydrogen for various many applications. Uh, right now we are talking about using the hydrogen for the vehicle, but from last 6-7 decades we are already utilizing hydrogen for fertilizer industry, for steel industry, for refinery industry. So hydrogen is not a new fuel. Technically speaking, it is already existing fuel or catalyst in many processes. But today in India, most of the hydrogen which is available is a gray hydrogen. Gray hydrogen means the hydrogen which is produced using the non-green energy, okay, in layman's term. So in future, if we want to increase the hydrogen, or if we want to introduce the hydrogen as a transportation fuel, we have to make sure that it has to be a green hydrogen. Then only our target of net zero carbon neutrality will get satisfied. And for doing this, the way today we are focusing on the application of hydrogen for transportation industry, in the hydrogen value chain, there are also other people who are working very extensively on making the green hydrogen a success. The hydrogen value chain starts with the hydrogen production. Okay, I believe there is a separate topic of the hydrogen or green hydrogen production. I think tomorrow someone is going to cover this. I will not go in detail of this, but my message to this audience, to all the students, is that it has to be a green hydrogen to satisfy our carbon neutrality target. Okay, so with this, what I'm saying that by 2040, we will have our product mix coming from battery electric vehicle, fuel cell electric vehicle, and also from the IC engine with the non-fossil fuels. Yeah. So next picture. Now, let me explain you about this truck energy consumption. So x-axis is basically my yearly mileage. That means what my different trucks are basically going to cover, how many kilometers they are going to run in 1 year. And whereas y-axis talks about the energy consumption or energy required in terms of kilowatt hour per 100 kilometer. Okay, I have not put the specific numbers here, but you can understand the context what I'm trying to say. So today, as I said, the Volvo Group is making a heavy duty trucks and heavy duty engines for the various application. So you can see that these are the various words which you can imagine the applications, like a refuse trucks, garbage trucks, city distribution trucks. Within a city, you need to distribute from your warehouses, like e-commerce warehouses, to the various city distribution centers. Then urban, as we move towards right, I'm talking about regional haul. Regional haul, basically you can say that Chennai to Bangalore, this can be considered as your regional haul. Urban construction, local constructions within a city, cement mixers, concrete mixers. Then as you move towards more right, it's a long haul. Okay, the truck train as of now in India is not permitted, but the trials are going on to have 2 different containers or 3 containers with the same tractor. That is called as a truck train, but in Europe and US it is allowed. But if you look about the India, this is very common, this kind of tractor and trailer, one single trailer. But here you can imagine the distance what they are going to cover. This long haul can be defined as from either from Chennai to New Delhi or Bangalore to New Delhi, which goes more than 1500 kilometers. So these are called as a long haul applications. And when I say that, in today's world, what my customer means the customers who are using the Volvo products. So customer satisfaction is one of the very important culture within a Volvo. And I'm saying that today my customer, whoever using the diesel powered truck, okay, diesel engine powered truck, tomorrow if I want to give him the hydrogen powered truck, he has to feel no difference in driving the truck and no difference in operating the truck. This is very important aspect. If you bring the technology, then the customer should get either the better experience than your existing experience. It should not degrade this. So when I'm saying that with the diesel truck, with the diesel engine truck, with the one filling of the fuel in the truck, it can cover up to 1000 kilometer today. Okay, he don't need to stop for 1000 kilometer. I am giving him enough capacity of diesel. Once he fills the diesel in the truck, it can cover up to 1000 kilometer. And mind this very well, that when I'm saying the 1000 kilometer, it is with the very heavy load, 40 ton to 65 ton loads. These are the loads we are targeting here. It's not a medium duty with a 18 or 20 ton loads. It is with the 40 to 55 ton, 65 ton load. So with such a heavy load, with the 13-liter diesel engine, with a capacity of the diesel tank, it can cover 1000 kilometers. Now, my target, whenever I introduce my hydrogen powered truck, he or she has to get exactly similar performance. And that's why we feel that in the extreme right side of this picture, long haul segment, where the target is to cover 1000 plus kilometer in one filling, hydrogen technology makes a very, very good business case, because hydrogen will give you the flexibility to carry the gas on board, and it may not require such amount of weight which is required for the battery electric vehicle. So someone of you might ask why we cannot be a battery electric truck can operate here on the right side. Technically speaking, yes, technology is available. You can make the battery electric truck also for the long haul, but you will require a very big size of the battery and the multiple amount or number of batteries, and also the space. So weight and space will get consumed in the battery. And if I'm saying that my weight is basically increasing because of the battery, that means somewhere I have to compensate. So I am targeting to carry 40-ton load, but then my battery weight is increasing. That means my carrying capacity may go down from 40-ton to up to maybe 38 or 36-ton, which is not acceptable to the customer. Okay, so I need to think of this whenever I am introducing the technology. It should not get hampered, or it should not degrade the customer experience. And that's why we think that in the very long haul segment, the battery technology may not be a good choice, but the hydrogen technology might be a good choice. And where the battery technology makes sense, in the middle segment, the blue color segment, regional haul, sorry, the battery technology makes sense in the extreme left segment, city distribution and refuse, and the electric buses, where you know the demand and the mileage you want to cover is very sure shot. For example, Chennai to Bangalore, it's a 300-kilometer distance. You know that in one full charging the electric bus, there are already buses plying on this road, electric buses. Even in the city buses, you know that they cover maybe around 200 kilometers every day. So you know what kind of battery size you may require. So you can basically anticipate this is the size, this is the for this segment, and the customer may be able to utilize this in one full charging, and he may not need to worry about the charging infrastructure on the road. So this segment makes a very good case for the battery electric vehicle. The blue color, you may find, depending on the market and depending on the infrastructure availability in the market, it can go with the battery electric, or it can also go with the fuel cell electric. So there will be some overlap in this. So I think the point what I wanted to clarify here, different segments of the truck will have different technologies, and this technology will also depend on the market where you are selling this truck. So the market is ready with the good infrastructure, there will be a faster penetration of the technology. Yeah. Now with this background, now I am going to enter in H2ICE topic, hydrogen IC engine topic, and why we are going to focus on the hydrogen IC engine. You may find some repetition of the topic with the earlier speaker Ashwin from Mahindra, but I'll try to make the context in a more better way. So why we need the hydrogen IC engine? You can imagine that hydrogen atom H2, you can imagine any fossil fuel is made up of CH as a combination, whereas in hydrogen there is no C, there is no carbon. And that's why technically you can say that all the emission which is coming out of H2ICE will be CO2 free, because there is no carbon atom in the fuel. That means no CO2. So this will help in the decarbonization journey very, very significantly. Second, zero emission vehicle. Now, there are countries who are defining the definitions of zero emission vehicles. Some countries are defined the definition of zero emission vehicle, ZEV, such that the maximum CO2 these vehicles will emit will be less than 1 gram per kilowatt hour. Now, you can ask, since you are a student, you may not be aware of from where this 1 gram per kilowatt hour comes. Basically, this comes from the emission test cycle, or maybe from your city driving cycle. Different countries have different legislation for measuring the emissions and also the fuel consumptions. And for that, we have defined the various types of duty cycles. It could be the city driving, it could be the highway driving, or it could be the combination of these two cycles. So India mostly follows European law, but India also has its own mix of cycle for heavy duty segment. And when we run these kind of cycles at the truck testing or at the engine test bench, when at that point, basically as a part of average of this cycle, that your CO2 emissions should not be greater than 1 gram per kilowatt. And that's how this per kilowatt hour. So I just try to explain the context. So if your CO2 is less than 1 gram per kilowatt hour, your vehicle can be categorized as a zero emission vehicle. Okay, if it is going to be more than that, it may not be categorized as a zero emission vehicle. And some markets are really it is very important to advertise like that, because in many of the European countries, it is the society which is basically asking for a change. Whereas in India, it is more the legislation and the government policies which is driving the change. Whereas in Europe and USA, it is the society. They are much, much more focused on the, let's say, safe environment and the clean environment for their future generation, which is, I would say, it's a good. And I'm not saying that in India, people are not concerned, but the rate at which we will penetrate with these technologies will be comparatively slow. And that's why our net zero or carbon neutrality target of the country is 2070. Right? It is approximately 45 years from now. But whereas in many of the European countries and USA countries, they are targeting the net zero carbon neutrality by 2040 or 2045. So that is the difference here, because we know that we have the huge population and our speed of penetration will require a lot of money if we want to achieve by 2040. That's why I think the government has set it at by 2070, because ultimately it all depends on the how green is your electricity, how green is your hydrogen, and we also need the infrastructure. So the infrastructure development will take a little bit time, and that's why our carbon neutrality targets are chosen as 2070. Coming back to the point of zero emission vehicle, so these countries like in Europe and USA, it is more driven by the society, and that's why it is a burden. It is a kind of a pressure on the OEMs that they will develop these products as per the demand of society, not only from the government's policies or not only from the legislation requirement, but looking at the end customer also requires it. Okay, coming to the third point, there is a also possibility to explore near zero NOx emissions. Now, why this is there, I think we will cover in next slides. And I think my colleague Shankar will also talk about the exhaust after treatment system requirement for the H2Is. He can also cover this in a little bit deep. But the fourth point I would like to emphasize, that possible adaptation from current diesel platform. Okay, now you can imagine that almost every OEM who are in the heavy duty commercial vehicle segment or the medium duty commercial vehicle segment, they are already using this diesel engine technology. This is very common in the world. This is very proven technology. We know in and out of this technology. We know the challenges and the possibilities of this technology. Even our not only the technology development, but you can also imagine our aftermarket maintenance. All these people, the workshops along the roadside, they are very well versed with the diesel engine as a technology. And if you talk about any company or organization, like for example, Volvo, we have already invested in development of this technology for so many decades. My supply chain, my parts, my tier one, tier two, tier three suppliers are already established. My production process of the engine is already established. My workshops, my production lines, I have already done a lot of investment in my production lines. And if tomorrow someone says that, okay, from next year onwards, everything has to be go 100% fuel cell electric or 100% battery electric, then I need to make infrastructure within my company, including my production house, to make this demand. And it is also a huge investment for any company, for any organization. So what I'm saying that diesel is, IC engine is not a culprit. It is the fuel which is a culprit. IC engine as a technology is not a bad technology. Technology wise, it is good. It is the fuel which makes the IC engine looks bad. So our target as an engineer is to give the holistic view of all the possible technologies and in which segment which technology makes a good sense, also in which market which technology and at what point of time makes a good sense. As an engineer, this should be our, let's say, way of thinking, rather than I would say not fall into the trap of political statements that EV is going to replace everything or like that. We are saying that all the technologies are very important. I shown you in my earlier slide, we are working with all the three technologies, and we do believe that there is a space for each technology in best depending on the segment and the market. Coming back to this point, what I'm trying to, why H2ICE is making sense, because IC engine technology, almost every OEM means original equipment manufacturer who makes the engines or the trucks today. So they already have this kind of setup available. And if they just use the engine, continue using the engine with a different fuel, my R&D cost will go down, my production cost will go down, and also my facility GTO is basically group truck organization or operations who makes the manufacturing for the Volvo group. So the investment required to replace this technology will also go down. So it makes it is a win-win situation, provided I will make the engine such that it will be categorized as a zero emission vehicle, as I explained here. And then I think I will be able to make a good statement to the all government and the society. Yes, I am using hydrogen IC engine, but it is meeting the criteria of zero emission vehicle. So why not? Fifth point, lower component cost. It's a known technology I just explained, and it will also complement our powertrain portfolio together with BEV and fuel cell. Well, now there is one more important point I can say here. When it comes to the H2ICE, you know that hydrogen power technologies can be two. One is H2ICE, and also I will cover the fuel cell topic in coming slides. So with these two, both will require hydrogen as a fuel. Okay, in both these technologies, power trucks will require hydrogen to carry. So we can say that this is a shared truck, shared tanks, and shared infrastructure development with the fuel cell. So H2ICE and fuel cell will complement each other in a very good and positive way. And the last point is very important, that H2ICE is not as sensitive to the fuel purity as fuel cell. Okay. Now let me give you some context. Fuel cell is a technology which which is made up of basically the proton exchange membrane. These membranes are basically made up of precious metal coatings on top of that, and these coatings are very sensitive to the quality of hydrogen. And if the hydrogen is not more than 99.6 or 99.7% pure, there will be a faster degradation of this catalyst and the coatings for the fuel cell, which will basically increase my maintenance cost. I need to repair and frequently replace to my customers. So this technology, hydrogen fuel cell, is very sensitive to the quality of hydrogen, which is not the case with hydrogen IC engine. I can still go ahead with the 98% purity in H2ICE in our AIS 195, which is basically a H2ICE vehicle homologation guideline and a legislation released by ARAI India that talks about the quality of hydrogen and the fuel properties of hydrogen. So when they says this, they says around 98% of the hydrogen is good, purity of hydrogen is good enough for the H2ICE vehicle. So all these are very positive points for bringing the hydrogen IC engine technology to the market. Now, I am entering into the fuel properties scenario. I think Ashwin also tried to cover in a similar way, but I will try to give a little bit more context here. So here in this table, you can see that there are 4 different fuels which has been mentioned: hydrogen gas. CH4 is nothing but the methane gas. Methane, it could be the CNG or it can be also LNG. So CNG, LNG, please don't get confused. It is all the same fuel. It's a methane. It's only some CNG, it is a gasified with a compressed gas, whereas in the LNG, it is a liquefied compressed gas. That's the only the difference, but the fuel molecule is still the same. So what goes inside the combustion chamber is nothing but the CH4 as a gas in both the CNG and LNG. Then gasoline liquid and diesel liquid. So if I compare this, the first property, density. So since hydrogen is a gas, it has the least density as compared to the liquefied fuel, which is not a good. Okay, that's why we have shown the red arrow with the downward. It not goes. It is a kind of a negative point basically for hydrogen gas, because since it is a gas, it is a less dense. I need to carry a more amount of fuel. So basically, I am targeting 1,000 kilometer in one filling. For all these, let's imagine that if I give the statement like this, irrespective of my fuel, my target is in one filling, I have to drive 1,000 kilometer. That means this fuel, hydrogen fuel, I need to bring a lot of hydrogen. So that will require a lot of space. Okay, we'll enter into that discussion later. Whereas in case of methane, it's also the similar. It's a little bit better than the hydrogen case, but then I will say this third point. Okay, before I go to the second point, I'm trying to cover the third point. What goes in positive way of hydrogen is the amount of energy it is carrying. It is carrying approximately 3 times the energy than your diesel or gasoline, or even I would say per se methane. So 119.7 megajoule per kg. So by the gravimetric mass point of view, this is carrying the highest amount of energy, which is very good for hydrogen. Then now I'm going back to the second point, stoichiometric composition. So basically 34.3, this has the highest stoichiometric contribution when it comes to the gas, whereas for the diesel and gasoline it is in the range of 14, whereas in case of methane it is a 17. Stoichiometric, I don't know if you are aware of the definition, but it is the amount of air required for the complete combustion of 1 kilogram of fuel. Okay, so here the amount of air required in case of hydrogen is approximately 2 times or 2.5 times than your diesel. That means I need to provide more air for hydrogen IC engine. That means I need to design my turbocharger. I need to redesign my turbocharger to meet the diesel-like performance. Okay, my target is to give the diesel-like performance. My reference is the diesel which is existing today. And to give the diesel-like performance, I need to have the better turbocharger technology. I need to carry more fuel, but this point 1 and point 3 these are the opposite points, which will try to mitigate or try to oppose each other. So, but still, in overall, I would say that we need to carry, or we need to have more space to carry hydrogen to give the 1,000 kilometer range as compared to the space required to carry diesel. Okay. Then flammability limit. This is very important when it comes to the hydrogen. It has the very wide flammability limit. Flammability limit will decide that in what operating range you will do the combustion. It is also called as a lambda. That means you can actually do the very lean combustion. And the benefit of, okay, maybe you are still too early or too early to understand this if you are not covered the combustion concept as a part of your curriculum, or the IC engine combustion, the emission formation topics. But just to give you the guideline, the more the lean combustion, you will produce the less NOx. Okay, the NOx reduction will goes down as your lambda goes more and more lean. As you go more rich, then the NOx reduction will go up, just to give you the context. So it is very good for the hydrogen that it has a very wide flammability limit, and we can do the very lean combustion in the case of hydrogen, which will ultimately help me to reduce my NOx emission. Now, laminar flame speed. So you can see that among these four fuels, 1.85 meter per second, this is very highest flame speed. So laminar flame speed is nothing but as you start the combustion, how fast this combustion will take place. So hydrogen will give you the very fast combustion. That means the duration of combustion might be very less or very little bit lesser than the diesel, which in a positive way, it is a good. That means it is also covering the very fast in my combustion chamber. It reaches all part of the combustion chamber, and where the hydrogen and air mixture is suitable, it will combust this. That means it will give me the less chance for the incomplete combustion, and it will also give me good positive way in terms of the emission. Now, the last 3 points are comparatively negative points for the hydrogen, and it also brings the challenges to the hydrogen. So, minimum ignition energy required here is the least among all the four fuels, 0.017 millijoule. Okay, that means what I am saying here, that with the very small source of heat, my hydrogen is still combustion. Imagine you're working in the engine is always a hot. Okay, there are so many hot spots present along the engine, liner, intake port, cylinder head. These are all hot parts once the engine start operating, and this can act as a source of heat. And I am saying that hydrogen has the least amount of ignition energy required. So that means I am making my engine at very risky with the hydrogen as a fuel, because there is always a hotspot is there. So hydrogen can combust anytime if it gets heat. Okay, which is not a preferred way, because I need to combust hydrogen only at my point of ignition. Wherever I want, I should design it. Anytime before or later is not a suitable for the engine, and that's why this property basically goes in negative way for the hydrogen fuel. Auto ignition temperature. Okay, this is in Kelvin. You can see that diesel auto ignition temperature is around 523 Kelvin. Gasoline is little higher, and CH4 methane is also very high. It is 813, but hydrogen is the highest. Now you can imagine that uh, hydrogen has an auto ignition temperature of 858, which is approximately 300 Kelvin, 350 Kelvin higher than the diesel. Now, you know that our diesel engine is a compression ignition based technology. We do not have spark plug in a diesel engine, because fuel property is such that as I compress at the end of compression stroke in the diesel engine, my air pressure and temperature reaches to such a value that it can auto ignite. That means at the end of compression stroke, in case of diesel engine, my temperature inside the cylinder reaches more than 523 degrees Celsius. That's why diesel can auto ignite. Okay. But if I want to now use and diesel has a compression ratio between 14 to 18, in some cases maybe 20. So if I want to use the exactly same technology without making any engine modification, and I want to ignite hydrogen there, imagine what is a big challenge. At the end of compression stroke, I am just reaching to maybe 530 or 540 degree Kelvin. But the hydrogen auto ignition temperature is 858 Kelvin. That means I cannot auto ignite the hydrogen using the existing diesel engine technology. Same goes with the gasoline engine. As compared to gasoline, it is also around 250 degree higher, Kelvin higher. So I need to make the modification in my ignition source. So that means hydrogen engine will require an additional ignition source, and that's how it brings the ignition technology as a key technology when it comes to the hydrogen as a fuel. And then quenching distance, this is let's say very less, 0.64 as compared to the methane and gasoline. And this is very important because it can basically go in the quenching area of your combustion ball, and it can basically get deignited, or the fuel flame can get quenched very easily because the distance required is very less as compared. So with this basic definitions and basic fuel properties and how it differs from the different fuels, I'm going to enter in the next slide. Okay, this is also basically the same, but now here I have made the comments for your understanding. I think I already explained these comments to you already. So I will go to the next slide. Now, here I'm trying to showcase the impact of density and the impact of this density when it comes to the fuel carrying capacity or the volume required to carry the fuel. And this has been given the analogy in terms of the 1 liter of the bottle. Okay, and this bottle is, let's say, filled with gasoline. Then the second statement talks about filled with the diesel, and how much of the, let's say, it will weigh in terms of the energy, in terms of the density. So diesel density is different, gasoline density is different, then CNG density is different. So the weight of the bottle, okay, if I fill it completely with the different fuel, in case of the hydrogen, it will weigh only 82 milligrams, you see, whereas with the diesel it will weigh up to 820 grams. So look at the difference. It's approximately 10,000 times difference. So it is basically 820,000 milligram for diesel, whereas it's only 82 milligram for hydrogen. So that means I need to have a very big space, approximately maybe 10,000 times bigger space, to get me the similar kind of energy, to carry the same kind of energy with the hydrogen. And that's why the hydrogen requires a different kind of storage systems. It could be the gaseous hydrogen at maybe 350 bar or the 700 bar pressure, which makes sense. Or if you liquefy the hydrogen, then it will make a more sense. We'll come to it later. But this is just to give the context, the space requirement with the different types of fuels. Okay. Now, here I'm trying to give some more basics about the ignition properties of the fuel. And I think I already explained about the minimum ignition energy required and the auto ignition temperature. And this basically talks about the very same. So here, when I said that in case of diesel engine, the typical compression ratio is 17 to 21. And whereas for hydrogen, if I don't want to use any external heat source or any external ignition energy source, my compression ratio requirement goes up to 40. Imagine, that means I need to have either wider let's say, or more diameter per cylinder, or maybe more stroke per cylinder, so that I can compress it up to 40 compression bar. Okay, so compression ratio is 40, whereas in diesel is 20. So approximately 2 times or 2 to 5 times compression ratio is required in case of hydrogen, if I do not want to go with the external or a different ignition energy source. That's the message from this. And here I'm talking about, let's say, injecting the hydrogen inside the cylinder without having. Now with this, I'm going to the, let's say, premixed and the diffusion combustion. This is very interesting slide for all young engineers to learn. Now, before I go in deep of this, maybe what I would like to cover is PFI, LPDI, and HPDI. Okay, these are the three different types of injections which can be possible in any kind of injection or any kind of IC engine systems. PFI, port fuel injection. Port fuel injection, that means you are not going to inject the fuel inside the cylinder directly, but you will, okay, imagine this is your cylinder basically, and this is your intake port, and this is your exhaust port. And whereas this is basically the violet color is nothing but your spark plug. What I'm saying here, in case of port fuel injection, I will inject the hydrogen in my either intake port, okay, that is outside of the cylinder. Now LPDI, I'm coming to the second picture, low pressure direct injection. Here I am saying that I will inject hydrogen inside the cylinder directly, okay, not in the intake port. But in case of LPDI, the fuel pressure could be up to 50 bar, 50. Whereas in case of port fuel injection, the fuel pressure is around 10 to 15 bar. Okay. And now I'm coming to the right side. Okay. HPDI. Now, high pressure direct injection. That's the full form of HPDI. Here I am saying I am injecting the hydrogen also inside the cylinder directly, but with a much higher pressure. So what pressure here I am talking? 250 to 300 bar. Okay. And then hydrogen plus diesel, I will explain you in the very short time what here I'm talking. Here also I'm injecting the hydrogen at 250 to 300 bar. Now, each of these technologies, fuel injection wheel technologies, will call for a different type of ignition requirement. Okay, since here my fuel injection pressure is 10 bar and I'm injecting outside of the cylinder, that means I will require here a spark plug because I'm not going to change the compression ratio of the engine. Maybe I will make since now I have decided I am going to go with the port fuel injection technology. That means this combustion process of hydrogen will be very similar like a gasoline type of engine. And when I'm saying that my combustion process is similar with the gasoline type of engine, that means in case of gasoline engine, the compression ratio is 10 to 12 bar. So my ultimate aim is to go with maybe 10 to 12 compression ratio with port fuel injection engine, so that I will also utilize the spark plug to ignite the hydrogen. Same goes with the LPDI technology. Here I am injecting at the less than 50 bar. I am using the spark plug, and that's why I can go with the gasoline like compression ratio of 10 to 12 bar. But whereas as I come to the right side, I am injecting, okay, I am injecting here with 250 bar. And if I say that I will also use the spark plug here, then I can also basically reduce my compression ratio to certain extent. But the extreme right picture, you can see here that there is a difference in all these pictures. In the extreme right picture, you will not see the spark plug. Okay. Here what I am saying that I am injecting the hydrogen also inside the cylinder at 250 bar approximately. But I am not going to use the spark plug for ignition. Just now I explained, if I don't want to use additional ignition source, I may need to increase the compression ratio of my diesel engine to up to 40. But I am saying that I also do not want to change the compression ratio of my existing diesel engine. So how I can achieve this? So here I will have little bit of diesel as an igniter. I am saying that I will not use spark plug, but I will use little bit of diesel just to initiate the combustion. And that's how it will be categorized as the dual fuel engine of type 1A. Okay, because diesel is not my main fuel. Here I am going to use diesel only maybe less than 3% of the total fuel required in a complete engine cycle or one engine cycle, out of 100% of the fuel required, only 3% will come from diesel, rest 97% will be still the hydrogen. And why I'm using diesel here? Because I do not want to use the spark plug technology, but there has to be some source of ignition should come from. And that's why the source will come from the diesel without changing the compression ratio of the existing diesel engine. Okay, now this is one difference of the technology. On left side, PFI and LPDI, these are basically called as the pre-mixed combustion technologies, because this will go towards the gasoline-like combustion, where I am going to inject the fuel before my spark timing. That means I am injecting the fuel during my intake stroke. Okay, you know that in 4-stroke engine there are 4 strokes. Intake stroke, okay, it starts maybe with the exhaust stroke, the way it is represented. Exhaust stroke, then intake stroke, compression stroke, and then your burning, or let's say firing stroke. So once the exhaust is happened, my intake stroke starts, and during the intake stroke I will inject the fuel inside the cylinder or maybe inside the port fuel in case of PFI technology. So that means I am allowing the fuel to have enough time to mix with the incoming air, because my power stroke is going to happen maybe after 180 degree, approximately 180 degree. Okay, it's a 720 degree cycle. So if you divide it into the 4, it's a 180 degree approximately for one stroke. So once I start injecting during the intake stroke, I have 180 degree approximately of the time left before I do my spark, and then the fuel will ignite. Okay, that means I am giving the fuel enough time to mix with the air, and that's why it is called as a pre-mix combustion. Okay, and that's why I do not need to inject the fuel at a very high pressure here, because there will be enough time available for the fuel to get mixed with the air inside the combustion chamber. Whereas on my right side, okay, the fuel I need to inject at high pressure, because I am injecting the fuel just before my ignition event, few degrees before my ignition event. I am not injecting in this case at during the intake stroke, but I would say maybe at the end of intake stroke. That means I have very little amount of time available for the fuel to get mixed with the air, and that's why I need to inject at very high pressure, because high pressure will allow the good atomization of the fuel, and the smaller the particles of the fuel it gets atomized, it is easy to mix with the air. It goes same in the diesel engines, also has similar. In case of diesel engine, 100% diesel engine, the fuel injection pressure today is 2000 bar. There is some engines which are already working with the 2500 bar. Okay, and that's the level of high pressure we are using in our 100% diesel engines today. And there is only one reason to have such a high pressure, because to give the better atomization, the smallest the particles of the diesel, it comes inside the combustion chamber, it is easy to mix with the air, it gives the good combustion and less emission with this. And that's why it is called as a diffusion control combustion. This is not called as the premix combustion, because I am injecting the fuel at the end of ignition intake stroke, very just before my ignition timing, and that's how the combustion. Okay, there are more let's say explanations about the premix and diffusion, but just to understand for today, I think this is good enough. And here also I think this is in a nice way it is explained here. Basically BDC is nothing but your bottom dead center, whereas TDC is your top dead center. Okay, and this is the your intake stroke of air, and you're starting to inject the hydrogen, okay, during your intake stroke, and then you give the enough time for mixing, and then you have the spark timing over here, and then the combustion will happen. So but here you can see here there is a difference. When I'm putting the hydrogen green block, I'm putting the hydrogen green block just at TDC or maybe little before TDC, also makes sense, and I'm giving the air, there is no hydrogen will come during your intake stroke or till the end of intake stroke. So that's the difference between your premix and the diffusion control combustion when it comes to the hydrogen injection timing. Okay, let me go ahead. And it has various positives and negatives also explained here. Basically, well, positives about the premix is that it is a low cost because the pressure required here is a comparatively low, less than 50 bar. Then we do not and it also gives, okay, there's one good thing is that since I am giving here the more and more amount of time for mixing of fuel with air, it generally gives the lower NOx emission, okay, as compared to the diffusion control combustion, even though I'm injecting at very high pressure. But the reality is that the NOx emissions will be the least in case of PFI engine technology, little bit higher in case of LPDI technology, and the highest in case of high pressure direct injection technology. But said this, we will also have the emission after treatment system present in the engine, and that's why we are saying that even with the hydrogen IC engine, we will not be able to eliminate completely the after treatment system. We still need to use the after treatment system because of these challenges. It may not have the challenge regarding the CO2, but for all the other emission elements like a NOx kind of thing and various categories of the NOx, we still require the emission after treatment system. Okay. Now here I'm trying to explain you in terms of the CO2. So just see that before I enter into this discussion, x-axis is called as basically brake specific CO2 grams per kilowatt. Now, as a layman, you might not heard this term BSCO2 or BSFC. BSFC you might have heard, that is brake specific fuel consumption. That is amount of fuel required to achieve certain amount of power or per unit amount of power, basically. Okay, and similarly we can also bring this terminology also to the emission. That means amount of emission formed per unit of the power. That's how I am right now quoting the brake specific CO2, that is a grams per kilowatt hour. Now your x-axis is your NOx. Okay, here NOx I am presenting in terms of ppm. What I'm saying now, I'll start the explanation from the extreme right side. Okay, extreme right side says that this is a typical diesel engine combustion where the lambda, okay, is close to 1.5. It varies between 1.3 to 1.5. This is not a stoichiometric ratio. When it is a stoichiometric ratio, the lambda will be 1. You can say that stoichiometric of ratio of diesel is 14.7. So when I maintain the 14.7 amount kg of air for complete combustion of 1 kg of fuel, I would say that my lambda I'm maintaining as a 1. But when I am saying the lambda is 1.5, that means I am doing the little bit lean combustion. Okay, that means I am putting more amount of air as required for my stoichiometric ratio. So here I am saying approximately 50% more air. That's a typical diesel combustion. Now, this typical diesel combustion gives NOx and also the soot, basically, and also the CO2, because it's a diesel having carbon particle, and that's why I will utilize the EAT system of the diesel. Okay, but when I say that, now I'm moving toward the left side, okay, with the different hydrogen IC engine technologies of injection. So on this particular bottom curve, I am saying that this is the LPDI engine technology, low pressure direct injection, where I can maintain the lambda up to 1.8 to 2.2. Okay, I can go with this much of lean lambda. And since my lambda is very lean, you can see that here 2.2. In some experiments, they are already done with the 2.5 or 2.7 of lambda. Okay, so this is, and I think I explained you that higher the lambda, that means higher your lean combustion, the more lower will be your NOx. That means you can see that my NOx curve is going down with the LPDI engine technology, because my lambda here I am maintaining is up to 2.2, whereas in case of diesel it is just up to 1.5, and that's why my NOx concentration goes to this level. Okay. Whereas in case of HPDI engine technology, high pressure direct injection, I can maintain lambda only up to 1.5 to 1.8. It is a diffusion control technology, whereas this is a premix combustion technology. And that's why, since I cannot do more lean here, my NOx will be comparatively higher as compared to the low pressure direct injection technology. And that's why I am saying that in case of PFI or LPDI, my NOx will be very less, because I can maintain up to 2.5 or in some cases up to 2. This is explained here, that ultra lean concept with lambda 2.5. I can reach, you can see this lambda, this NOx level can go up to, in the bottom box of in blue color, less than 50 ppm with the ultra lean concept when I mentioned the 2.5 lambda. And if it is a lambda is up to 2.5, I will reach up to maybe around 200 ppm of NOx. With the HPDI, I will go up to around 400 plus ppm of NOx. Whereas in case of a typical diesel, it varies between maybe 700 to 300 depending on operating. So what I am trying to say here, if this dotted line is considered, so I can reduce my NOx with the hydrogen IC engine as compared to the diesel based on the fuel injection technology. What I am also saying that means the amount of or the size of after treatment system required for the hydrogen IC engine has a good potential to reduce the size of the after treatment and ultimately also to reduce the cost of the after treatment system. I am not saying that I will completely eliminate my hydrogen after treatment for H2Is, but I have a good potential to reduce the size and ultimately the cost of after treatment system. I hope this is clear from this. Now I will go to the next slide. This is very intense slide, but I'll try to make it in a simple way. This is not for a Volvo engine slide, but this is just for a reference. We have taken this from one of the conference paper. And this x-axis is nothing but your lambda or air fuel ratio, and y-axis is nothing but your mean effective pressure engine operating zone. So what I'm saying is that as you go between as you go towards the right side, it becomes more and more lean. Okay, more and more lean. And as you go on the left side, it will become more and more rich. Okay, so in one of the BMW engine 7 series hydrogen engine, which is they released in 2007, this is a 14 or 15 years back I'm talking, when they operated their small size diesel engine with the lambda 1, they operated in this region, and that's why they might have incorporated some knocking tendency with the higher amount of the even for the NOx. And but if you look at this picture, okay, this curve basically, this curve shows your knocking region. This curve on the right side, this is your misfiring region. So this window, which is shown in the green color, is your best window to operate to avoid the knocking and misfiring challenges which comes with the hydrogen IC engine. And if you look at this blue line, as you go towards more right side, your engine efficiency also gets better and better. So it is very important when you operate your engine in this particular zone, you will have the least chances of knocking, least chances of the misfiring, and you will also have the higher thermodynamic efficiency. And then another advantage is the red color curve is a NOx curve. So in this zone of the lambda, your NOx is also going to be very less. So you have almost very positive aspect if you operate in this zone. But believe me, it's very good to say on the slide that you can operate here But to design an engine like this and to design the control system for the engine to have this kind of operating zone, it's very challenging. It is not impossible, but that's what we are as engineers are doing, the R&D and then engine development, combustion technology development, and then ultimately then the testing and calibration phase comes. So I think I explained this slide where you should able to target your operating zone of the engine. This is the ultra lean concept. I explained it, but I think I will little bit move ahead a little faster here. Yeah. Now this is the slide about the air requirement. Okay, as I was saying that hydrogen gas has a very high stoichiometric ratio. That means amount of air required is approximately 2.5 times. Now here is the comparison of this hydrogen with the diesel as a base. Okay, so diesel engine is my basic or reference when I did this comparison. And in diesel engine, I am saying that I will operate at the lambda of 1.5. Okay. So here the stoichiometric ratio of the diesel is 14.7, whereas in case of a hydrogen, it is 34.3. And this gives me the requirement with the ultra lean concept. Okay, I need to have 2.3 times of air. If I go with the minimum lambda of 1.5, okay, this comparison was only with the lambda 1, but now with the lambda 1.5, I need to go with the 1.7 of the amount of time, the air requirement. And then if I go also consider the volumetric efficiency, this energy content and the lower heating value and then net increase in the air requirement. So I am trying to say here that with the three different engine technologies or fuel injection technologies of the hydrogen, and with the base or reference as a diesel engine, the amount of air required is changing. So with the ultra lean concept of the LPDI, I need at least 1.4 times of the air as compared to my diesel engine. With the low pressure direct injection, where I am operating the engine with lambda 2, I need at least 1.1 times of the air. Whereas in case of HPDI, I might have possible to reduce the amount of turbocharging. So this is the message from this particular picture. And these are really rough calculation. These are just the guidelines for one of our experiment what we have done. But for each engine or each OEM will have to calculate their own based on their project. It's a little bit different. But this is the way I think you need to calculate the amount of air requirement or the requirement of the turbocharger technology when it comes to the hydrogen IC engine. If your base engine is a diesel engine, how it gets changes. Yeah. Okay, I think this is a very good picture to get understanding of the three different injection technologies which I just explained. But this picture is we have taken from one of the USA website, government website. They had a really nice session or the webinar a few months back, and they explain in detail, and they have also listed down the positives and negatives of each type of injection system in case of H2Is. I think I explained you already, but yeah, cost wise, if you talk about the cost, the port fuel injection is the cheapest technology. It is cheaper and it is also very easy to modify your existing diesel engine using the port fuel injection. Okay, whereas the direct injection technology, whether it is a low pressure or high pressure, there is a more modifications are required in this. Okay, now one basic change you need to consider when it comes to diesel engine to hydrogen engine, if it is a port fuel and if it is a direct low pressure direct injection, you need a spark plug there. Existing diesel engine, you do not have the spark plug. That means you need to bring the provision for the spark plug. That means you need to modify your cylinder head, okay, to change the design to have the space and the space availability for the spark plug. The location of the spark plug will also play a very key role when it comes to the efficiency and the challenges and the hotspots regarding the H2Is. So this calls for a little bit more challenges when it comes to the ignition energy source and also the location of this ignition source inside your combustion chamber. Whereas extreme right side, you do not require a spark plug. Here I am talking about HPDI, okay, with pilot fuel as a diesel, because this particular technology, what I am right now explaining, this is specific to the Volvo, because here we are putting one single injector which will inject diesel as a pilot fuel, and it will also inject the hydrogen as a main fuel. That means I do not require two different injectors to inject two different fuels. Okay. I am saying that since I am replacing the spark plug, or not replacing, I am not utilizing the spark plug, but I am providing the ignition source from the diesel as a fuel pilot. That means my modification required in the existing engine cylinder head are the minimum, because I already have the space for the diesel injector in my existing engine, and I just need to replace this with the new injector which will be able to inject diesel as a pilot fuel and also the hydrogen. So this is a very patented technology from the company called Westport Fuel Injection System. This is a Canadian company, and Volvo has done recently the joint venture with this company, and this technology is already introduced in the Volvo's LNG engines. Okay, Volvo has introduced the LNG engine technology in 2018 with this kind of fuel injection technology, that instead of hydrogen, you will see the methane injecting here, and then diesel is igniting as it's coming as a pilot fuel. But now we are saying that we will use as our first preferred choice for the Volvo group the similar technology for the hydrogen. That means I will use the existing diesel engine, I will use the existing injector, okay, without doing much modification. I can still inject the hydrogen and I will ignite this hydrogen using diesel as a pilot fuel. Said this, we are also working on port fuel injection and low pressure direct injection technology as a part of our development. But we are saying that this is extreme right side, this is our preferred technology, because you need to see now how the organization thinks. I already have a product which is working on this technology. I just need to change with the fuel, and then I need to change the combustion behavior of this fuel. That means with the minimum modification, with the minimum development effort, I can bring this technology to the reality for H2Is. Whereas for this left side two technologies, I need to put more efforts, because in Volvo's history, we hardly have any gasoline engine or any spark plug engine. That means this is a comparatively a new development for us. We need to learn a lot about the spark plug technology and also about the combustion in this direction. So the way organization thinks or the decision making in the organization happens, there are many aspects. It's not only the technology, but also how fast you can introduce this technology to the market. What is the cost? Is your supplier readiness is there? What is the TRL level? That is the technology readiness level you are having. So apart from this Volvo's preferred choice, we are also saying that this is giving me the highest efficiency, the best efficiency, power density, and transient response. Okay, with this technology, I'm saying I can be able to achieve more than 50% thermodynamic efficiency. Whereas with the port fuel injection, which is a comparatively easy technology, but I cannot achieve more than 42% of thermodynamic efficiency. With the middle technology, I can only achieve up to 45% thermodynamic efficiency. Said this, it has the benefit, but it is also will be the most expensive technology as compared to these two, but the benefits are also very high. When most expensive, I'm just comparing these three technologies. Okay, port fuel injection, easy, cheapest, least efficient. That means you will have the more fuel consumption. That means to cover a 1000 kilometer distance, you will require more fuel in port fuel injection IC engine. Whereas to cover the same load and same distance, I will require the comparatively less fuel when it comes to the covering 1000 kilometer distance. And now you can see in this decade or also in the next decade, when the infrastructure of hydrogen will not be enough. It is just going to start. The cost of hydrogen will be also very high in this and next decade. Till the time the hydrogen becomes a full-fledged and the regular fuel, the cost of hydrogen is going to be very high. In such a time, for Volvo Group, it makes a very big sense to introduce the highest fuel efficient engine, because this will require a lower amount of fuel as compared to other two. Okay, so this is how the organization thinks and works. So these are still another benefits of the three different technologies. Green is beneficial, red is not beneficial, or the change. Okay, with this, now I am going to cover a little bit about the fuel cell electric vehicle. I know time is running short, but let's move to the fuel cell electric vehicle topic. So fuel cell is basically a technology. I will say that I talk in the context of the vehicle here. Okay. So how the hydrogen vehicle or fuel cell vehicle might look like. So this is basically, we call it a tractor. Okay. Tractor means this does, and on the back of this tractor there is a container. Okay. So the tractor pulls the trolley or the trailer. On the trailer you can put the container or any kind of load. So this tractor, on this side, these are your hydrogen tanks. Then you will have the battery package. Then you will have the electric proportional, and then you also have the additional hydrogen tanks. And here, this space, okay, this particular space, I am saying that where your current technology of the IC engine is there, this space where I'm putting the existing IC engine, I will replace this IC engine with the fuel cell engine. Okay. Now, fuel cell today is a comparatively expensive technology as compared to IC engine, and it also has a comparatively wider requirements when it comes to the technology wise. Fuel cell is nothing but your battery electric truck, where you are basically saying that to operate the truck, I will not require, for example, just to imagine, for any battery electric truck, you require 10 batteries, okay, 10 batteries to carry, just an example. What I am saying, in case of fuel cell truck, I don't require 10 batteries. I am saying that with 2 batteries, I will be enough, but I will be continuously charging these batteries using the fuel cell as an engine. So I am replacing the IC engine with the fuel cell. And what I'm saying, that fuel cell will run on the hydrogen as a fuel, and this fuel cell will provide the energy or the current basically to the batteries directly, or it can also provide the power to the my axle directly. So that means I am saying the requirement of the battery, okay, is going to reduce drastically for the very long haul application and very heavy duty truck with the fuel cell as a technology. But what are the challenges when it comes to the fuel cell as a technology? Fuel cell itself is a challenging. Okay, the power capability of the fuel cell. Now imagine, in case of Volvo's context, our engines, let's say 13-liter engine, has the range of, in terms of the power, from 420 HP to up to 540 HP. It's a very big amount of power we are talking here. Whereas to replace this power with the fuel cell, today the fuel cell technology of such a high power is not mature. With a one single fuel cell, currently maybe 200 kilowatt of the fuel cell is the highest fuel cell is available in the market. So technically what I'm saying, if I want to replace my 500 HP engine, I will require maybe two sets of fuel cell to power the same vehicle to meet my power requirement. That means I am saying that my next development target is to develop the fuel cell with approximately 400 kilowatt of the capacity. Today it is not available, but the efforts are being driven in that direction. It will take time, but till that time I can surely use two fuel cells in one vehicle, no problem. But then it brings the challenges of how to control these two fuel cells power output synchronizingly. Okay, how to make the adjustment and the positioning of these two fuel cells together. Apart from that, there is another challenge of the fuel cell. Now, I am saying that whenever customer buys my product, they buy this product with a minimum lifetime requirement of 1 million kilometer. That means 10 lakh kilometers or maybe 10 years of the operation. And if I bring it down, reverse engineering, the need for my fuel cell, okay, to operate for 10 lakh vehicle kilometers, if you talk in terms of hours, it goes up to maybe 30,000 to 35,000 hours of operation or lifetime of the operation. Whereas the fuel cell in today's technologies has not reached to that level of operation. So if I introduce today fuel cell in the market, maybe I can cover only up to maybe 15,000 of hours of operation. That means approximately half the life requirement. That means only up to 5 lakh kilometers. After 5 lakh kilometers, then I may need to replace certain components of fuel cell or maybe the complete fuel cell. That means that is the additional cost of maintenance is there today. If I introduce this technology today in the market, I will not be able to fulfill the customer requirement or the legislation requirement of 10 lakh kilometers. So this is one challenge with the fuel cell. We know that fuel cell is more efficient than the H2Is. Okay. Generally, H2Is or any IC engine efficiency is less than around the 50% at its best. Whereas the fuel cell efficiency at its best is close to 60 to 65%. Okay. Then fuel cell operates in its best possible efficiency in the temperature zone of 65 degree to 70 degrees Celsius. Whereas for any IC engine, we maintain the temperature zone of 90 to 95 degree coolant or oil. So that means the fuel cell operates, okay, the good positive side about fuel cell is it operates at higher efficiency, but only in the highest efficiency zone or highest operating zone of the engine. If you compare on 1-to-1, that means for part load or mid load operation, the fuel cell may not be efficient as of on today. Okay. Then second challenge with the fuel cell, I need to maintain the fuel cell at 65 to 70 degree to give or to achieve the highest efficiency of the fuel cell. That means I need to extract more amount of heat from the fuel cell as compared to IC engine. IC engine, I am maintaining the temperature of 90 degree, but here I need to maintain the temperature of 65 degree. So that's the change in the delta in temperature maintenance will call for a additional thermal management of the fuel cell system or fuel cell vehicle. I need to design maybe the bigger size of the radiator. I need to design maybe the multiple fans to cool this radiator or to cool the coolant in fuel cell. So this is another challenge with the fuel cell. I'm just comparing the H2Is versus fuel cell. Okay. Then I still require a battery system in the fuel cell vehicle. Then when I say that I require a battery system, fuel cell is basically electric vehicle. That means I also need to think about the electric motor and e-axle development of the fuel cell. Then proportional cooling I just mentioned. And this point is basically very, very important, brake and brake recovery. Now, I don't know how many of you are aware of the exhaust brake. Okay, exhaust brake in case of the existing diesel engine is a technology basically to, I'll go to with the basics. To apply to brakes to the vehicle, you need to provide the brake power. And this brake power could come from a different source. It could come from your brake resistors, one thing. Secondly, it can be also pneumatically or air operated brakes, where it can get, or hydraulic brakes, it can get operated using the exhaust coming out of your engine. So certain amount of exhaust is passed through your brake system to operate the hydraulics of the brake. It is called as the engine brake. Okay, it depends. We can control this using the wall timing of the exhaust. Okay, and there is additional passage given to the exhaust. Now, when I'm saying that in my fuel cell vehicle, there is no engine at all. Okay, that means there is not going to be exhaust brake, which is available today in current existing diesel engine vehicles. That means I still require the same amount of brake power or maybe a little bit more amount of brake power because my weight is little bit going to increase because I'm carrying more amount of hydrogen as a fuel cell vehicle. Also, I'm carrying the 5 different cylinders of hydrogen in my vehicle. That means, in general, my weight will of the vehicle might be a little bit higher than my existing diesel engine vehicle. And also, I'm carrying that 40-ton load. Imagine with the 40-ton load, the more the load, the more amount of brake energy will require to stop the vehicle. That means the vehicle is getting heavier. On one side, I'm saying I need to control my vehicle, I need to brake my vehicle with a little bit higher weight as compared to diesel. Secondly, I'm saying I do not have the diesel brake power which is available in the diesel engine. That means the amount of brake and brake recovery is very high in case of FCEV vehicle. And this is the one area I need to develop my new technologies of the brake register to meet the diesel engine kind of a brake power requirement. And ultimately, I need to develop the control mission, power and energy requirements. I need to maintain the good control system. I need to develop the control system with the different scenarios. I need to bring the synchronization between fuel cell power versus the brake versus the battery power at the straight road, at the slope, and with the 40-ton, I need to have a different operating control technologies. When to operate only with the fuel cell, when to operate with the fuel cell plus battery. This kind of control system as a vehicle control system, I need to develop with fuel cell electric vehicle. And ultimately, this all gets reflected in the cost. Okay, so that's why I'm saying that these are the challenges with the fuel cell which we need to develop. We are developing this and we are trying to overcome this. But with these challenges, I can develop a technology in a couple of years, but this technology will be still expensive as compared to my IC engine technology. So if you compare the H2ICE versus fuel cell technology, the fuel cell technology is going to be more expensive. But now, ultimately, it will be get reflected in your TCO. TCO, that is a total cost of ownership. So if you want to sell any of your product to the end customer, customer will put, I'm talking in the context of the vehicle here, customer will think in terms of total cost of ownership. And what involves in total cost of ownership? One is the product cost when they buy this product. Okay. Second is operating cost. That means your fuel cost. If it is a truck, you will keep the driver, then your driving cost. Then if you are running on the road, you need to pay all the toll and taxes and all this. So all this comes as your operating cost. And then you will also have the maintenance cost. Maintain that truck. Okay, after every few intervals, you need to do the maintenance. And which technology gives the higher maintenance cost, which technology gives the lower maintenance cost. And in the end, in the operating truck also comes as a factor of cost of the fuel. So if you bring all these factors together, your target is to bring this to the bottommost of this curve so that your total cost of ownership with the fuel cell truck will be the least. And today it is very challenging. It is somewhere here, and in few years we target to bring it down to make it more commercially viable. Commercially viable is one thing, and technologically viable is a different thing. So today I may say that in next couple of years, I will be ready with the product which can be technologically viable to the customer. But ultimately, it's the cost which will decide which technology customer is going to prefer. Unless the schemes from the government will come to give the certain exemption for the hydrogen powered vehicle in the initial period, like there are schemes for the electric vehicle today, like FEM scheme is there, where you get the good amount of subsidy from the government. If you're owning maybe the two-wheeler or four-wheeler, electric two-wheeler or four-wheeler, you will get the concession, or let's say waived off the registration charges. So these kind of schemes can motivate the customers to go towards these new powertrain technologies. But in initial period of the introduction of fuel cell technology, it will be expensive, and unless the schemes from the government comes, the policies from the government comes, there
Hello.
will be expensive.
Excuse me, sir.
Yeah.
We have a lot of questions coming on from the viewer sides.
Yeah.
So not stopping now. We can have those questions now, and then we can continue.
Okay.
with the
I will
rest.
stop here for the discussion. No
Yeah.
problem. we can start the question session.
Yeah,
But anyway,
so
this was a kind of my second last slide. After that, there was only one slide about the storage system. But I have
Okay.
explained you the H2Is and the fuel cell difference basically. Yeah, we can start the question session.
Yeah, so first things first, thank you so much, Makaran sir. It appears like it has been made clear by yourself that your experience talks. We can clearly understand about your experience and everything, your understanding of concepts, your explaining of concepts, your practical explanations, everything is on point. I think the students, they have quite a bit of idea about the powertrain technologies. So let's proceed for the questions. Okay, so first we have question. What is the benefit of using HCNG as a automotive fuel in aspect of fuel efficiency and power output?
Well, to answer this question, I would say that if you want to introduce, let's say, diesel engine is there, then your now CNG engine is there, which is an LNG engine is also there. The next fuel, what government is targeting, may be the hydrogen. Now, today we are saying that hydrogen is technically available in India, but it is not a green hydrogen. Okay, it is a gray hydrogen or a blue hydrogen, but still it has a potential. Okay, we have enough hydrogen, we can still introduce hydrogen in the fuel. And you know that there is no carbon atom in the hydrogen fuel. That's why this is a very important fuel for the transportation industry. So today we are saying that although it is not a green hydrogen, although it is a gray hydrogen, but if I start mixing this in a CNG, I can still reduce my carbon footprint by combusting only 100% CNG versus 18% mixed hydrogen in the CNG. Okay. So what I'm saying is that with the 18% hydrogen mixed in the CNG, I'm not going to deteriorate my performance of the 100% CNG vehicle. My target is to maintain the same performance. Government is also going to tell this actually. You need to maintain the same performance when it comes to the power output of your 100% CNG. But with 18% replacement of hydrogen with the CNG, you are giving the chance to reduce certain amount of CO2 to be reduced from 100% of CNG vehicle. Okay, because hydrogen do not have the carbon atom. Although it is not a green hydrogen today, but this is how we are going to start in India.
Okay. Thank you, sir. The next question we have, what is the most important aspect we need to focus for switching from CNG to hydrogen CNG, that is HCNG?
Okay, when you move from, okay, the most important aspect, I think in the afternoon, Dr. Kalamuddin will cover, but I can also answer this. When you move from CNG to HCNG, one thing is your injection system, okay, which we need to cover. Second is where you are going to inject. Most of the Indian OEMs and engine manufacturers are working on port fuel injection technology, and that's what I think Greaves is also going to introduce, port fuel technology with the Advantech as a fuel supplier or injection system supplier. And one thing is injection technology you need to focus. Then second is mixing process, fuel and air mixing. So at what location in your intake port you will have this injector? Okay, so at what angle? Okay, but since you will get the engine from the supplier directly, but so that student may not need to worry a lot about this. But whoever is developing this kind of engine, they need to look at the position of the injector. Okay, they need to look at the mixing process of the fuel and air and how efficiently it gets mixed. So the grease team must have considered this already. Okay.
Yes, yes.
Okay.
Yeah.
So next up,
So just to clarify, I'll just clarify.
Yes, sir.
To Vora here. So we have pre-mixed fuel, that is CNG and hydrogen will be pre-mixed in the competition, and you will be getting the pre-mixed fuel. And it is already fuel injected in the Greaves engine. So in the Greaves engine, there is the port injection where the HCNG would be injected. And then when the intake valve opens, it will go inside and it will mix. and optimization is being done. So with CNG, the engine is optimized and the tuning and the calibration is done. With HCNG, they will re-optimize, recalibrate, and give those engine to us. So we will be dispatching the engine maybe after a month to all of you. The procedure for getting the engine also will be informed to everyone.
Okay. Thank
Yeah.
you, sir. Thank you,
Continue
Dr.
with the
Mohan.
next question. Yeah.
Yes.
Just to in the same context, yes. What I
Yes.
explained
Yes.
is about injecting hydrogen differently than with air.
Yeah.
But
Yes.
in case of HCNG, government is planning. It's a pre-mixed. You don't need to
Yeah.
worry anything. The way today you are injecting CNG, exactly in same way the HCNG will also come. Okay.
Yes.
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 Thank you, sir. Sir, Makaran sir, can you it would be okay if you stop sharing your screen now?
Yeah, sure.
Yeah. The next question we have, how to do leakage testing without using CNG or HCNG, like directly?
Which leakage? You mean hydrogen leakage? Actually, you're talking.
Yes.
Well, I think since it is a HCNG, I think all the rules for the CNG cylinders will apply here. Okay, so the PESO has already identified what kind of rules we need to follow when it comes to the gaseous fuel storage, respective where you are storing on vehicle. So we need to follow all those guidelines. And when it comes to the leakage, there are some specific sensors. Okay, we need to utilize. If we talk about the Volvo's context, we are going to utilize the leakage sensor. There are also specified the tapes which has come up in the market, which will basically also change its color if there is a leakage of hydrogen happens. So we can utilize this kind of technologies. We need to talk with various suppliers here who are basically in the sensors manufacturing. It could be the ITAS or it could be the any other one who are supporting and developing this kind of sensor. But leakage detection sensor is very important when it becomes the commercially making the technology available to the market. So safety is very, very important. We are starting with HCNG today, but down the line we will go with the increasing percent of
Completely hydrogen.
hydrogen.
Yes.
And then safety is very, very important. So safety, when it comes to safety, leakage detection is one thing, flame detection is another technology. If because hydrogen is a colorless flame, so even if it is burning behind you, you may not be able to see it. So how to detect this? So in case of the engine test bench or powertrain test bench, we are introducing the infrared sensors inside this. Okay, maybe in some vehicles it will also come up, but these are the future technologies. But safety in general is very, very important.
Yes, sir. Next up, we have what modifications do we need to carry out for CNG engine to convert it into an HCNG engine?
Well, I think those topics might get covered in the brief session today.
Okay.
But I can extend. But you can ask me another question because I know
Okay. So why don't we see a lot of HCNG vehicles on road against CNG and H2 vehicles?
Well, I think it's a government policy. So HCNG is there just start. They decided this policy, and once now they start implementing, it will come up. But before it come up, all the OEMs who want to take benefit of this policy, they need to recalibrate their existing CNG engine. Okay, and same thing what Greaves is doing today. Almost all OEMs are also working in India to recalibrate their CNG engine with 18% HCNG, hydrogen mixed CNG.
Okay. Next we have how hydrogen plus diesel are mixed together for HPDI technology.
Okay, that's a good question. Which is
so sir, before we take up this question was by Rajesh Kamutkar, sir, Advantage Fuel System. That and we can have a small conversation on this.
Yeah,
no, not clear. Yeah, not clear. What did you say, Saurabh?
So this question was posted by Rajesh sir, who is from Advantage Fuel System, and so maybe
so
we can have a small conversation on this.
Can you repeat the question?
Can you repeat?
How hydrogen and diesel are mixed together for HPDI technology?
Yeah, okay. So that's what I'm saying. In case of HPDI, there are two options. Okay, HPDI is a high pressure direct injection. So we are saying that we have.
Raju, you want to say anything?
Yeah, Lord sir, can you just open that slide which is having a diesel plus hydrogen in hydrogen that block diagram.
Okay, okay.
And it will be very beneficial to understand more efficiently. Thank you.
Okay. Yeah, just a second. Are you guys able to see the screen?
Yes, sir, we can see it.
Yes, yes.
Okay, I think this is the picture you might be talking.
Yes.
Yeah, so I am going to focus
Yes.
only on the extreme right picture. So here I am saying that this is my injector, okay? And this is one single injector. It is a concentric injector. The injector has been designed in such a way that the inner portion of the injector will carry the diesel as a fuel, whereas the outer portion or the outer concentric will carry the hydrogen as a fuel. I will inject, okay? This is an injector technology. Okay, so one single injector having the possibility of injecting two different fuels in the two different routes. Okay, it's not the same route, two different
Yes.
fuel routes. Okay, now what I'm saying here, the timing of the injection becomes important. At the end of compression stroke, I will inject the diesel as a pilot fuel up to 3% of my 100% fuel required for that compression engine stroke. Okay, since it is a diesel engine technology, I am not changing the compression ratio. Diesel will auto ignite based because it is the same compression ratio. And then at the end of this diesel fuel ignition, I will start injecting the hydrogen.
Okay.
Okay. And that's how the hydrogen will start burning using the flame already started by the diesel fuel.
Okay. Yes, sir. Next up, we have what impact? Sorry.
Sorry. Makran sir.
Yeah.
Almost this technology is almost look like a dual fuel system.
It is, yeah. Okay, yeah. I wanted to bring this to the context. Okay, now, okay. Can you see this screen?
Yes, yes, sir.
Yes.
Sure.
Yeah. So let's focus on this particular table. Okay, don't focus on anything else because. So here, what I'm saying that this is a type 1A of dual fuel engine, you can say. There are different types of dual fuel engines the government specifies, where based on the gas energy replacement ratio. Yes, GER. So I am saying that with this technology, I am replacing 90% of the combustion energy with the gas energy from the liquid to gas. Okay. And that's why this falls under type 1A of dual fuel engine, where if someone asks you, can I run this engine technically on only diesel as a mode? Technically, yes, but the authority will not allow me to do this because I am passing this engine as a type 1A dual fuel engine.
Yes. Can we have next question, sir?
Yeah.
Yeah. So what impact does HCNG have on engine's thermal efficiency?
What in HCNG on the thermal? I think we will have the very similar thermal efficiencies like a CNG engine. I would say that because it is a mixed premix combustion we are going to have. So I would say that if your CNG engine is having 40 to 42% of thermodynamic efficiency, you will also have the similar efficiency.
Okay.
It is only the injection technology. As we move ahead, as I explained, it is a LPDI, HPDI. As we go in that direction, then your thermodynamic efficiency will start changing and increasing. Basically.
Okay. One more question.
But I think Kalamuddin sir and maybe also the Advantech team can explain more about their observation in the existing experiment, what they are going to do.
Okay. Yes. One of the questions was, can you share this presentation for our benefit?
Yes, we are trying to see. I think most of the information which is non-confidential, and yes, we can share this presentation, but we need to just little bit modify it.
Yes. Okay. Next up, we have what are the challenges in optimizing the air-fuel ratio for HCNG engines?
HCNG engines. Okay, I don't see there are a big challenge. Okay, it is still going to operate in the very similar lambda like what CNG is going to operate. Okay, very similar lambda. There might be a little bit change, but it is not going to operate like an extremely lean lambda the way I have explained, because I'm just injecting only 18% replacement of the CNG with the hydrogen. It's not 100% hydrogen. Unless you go on 100% hydrogen, then you start thinking about more lean lab.
Okay. Next, residual charge in spark plug may lead to misfire in combustion chamber for hydrogen. How can you avoid that situation?
Yes, this is very, very important question when it comes to the H2Is with the spark plug technology. That means the spark plug is also considered as a hotspot, okay, for the hydrogen IC engine. And as I explained, the hotspot gives the auto ignition energy required. Okay, the ignition energy required for hydrogen is very less, 0.017 millijoule, and the same single hotspot can act as a ignition source. So residual charge in spark plug is considered as a hotspot, and that's why the spark plug cooling, we need to develop the new spark plugs for the 100% hydrogen IC engine. And the companies who are providing the spark plug or who are manufacturing the spark plug, they have got this new challenge like a Bosch, Tenneco. These are the spark plug manufacturers. So they are now working on the how to cool this spark plug. Do we need to go with a different material for the spark plug which can be easily cooled, or do we need to provide the cooling passages in surrounding the spark plug to cool it down? Okay, this is one aspect. Second aspect, within a completely ignition energy source, they are also working as an advanced ignition energy development or advanced spark plug technology development, like a Corona type of spark plug. Or there is also laser combustion spark plug technology, which are at the moment not marketable. It's advanced engineering, but I think there are many people who are working on, many companies are working on this kind of advanced ignition energy from the spark plug as a development. But yes, this is a one challenge. I don't know whoever pointed out. This is a very right and very important question.
Okay, that was the last question from today's discussion, sir. I don't think there could be any better explanation from for these questions. Thank you so much for your time, and thank you, sir.
Yeah, I think it was an excellent presentation.
Yes.
Not only presentation to the team from hBAJA point of view, also from research point of view. All this knowledge, I'm sure, teams, when you join industry or when you are in final year of engineering or final year of masters, you would think on these areas. You can take it as a project, and I am sure that Makarand would continue with BAHA for a long time, and we will be able to get students who will be able to research in this area. I like one sentence of Makarand very much. He said, it is IC engine is not the culprit. It is the fuel which one employs, right? So IC engine has been regarded as one of the very, very important research in the field of automotive engineering. And in my opinion, that would continue to be used in IC engine. The fuels may change, the type of fuel and the way they are injected into the engine may change, but the engine would continue. So thank you very much, Makarand, for this wonderful lecture.
Thank you, sir. Thank you, everyone.
Thank you, everyone.
For opportunity.
So there is a slight bit of update in the schedule, guys. We will have our next session from 12:45 to 1:30. Then 1:30 to 1:45 we will have the Q&A session for that session, and 1:45 we will break. So next up we have Shankar Srinivasan. Okay, we will have our session on exhaust after treatment technology. Also, we are privileged to have Mr. Shankar Srinivasan from Volvo Group India. He is a versatile engineering professional with extensive experience in business and project management, specializing in thermofluid dynamic analysis, integrated powertrain modeling, and deep learning assisted simulation methodologies. He's also skilled in CAE for powertrain subsystems and components with a strong focus on strength and durability. This session will delve into the technologies used to treat exhaust gases in hydrogen IC engines. Over to you, Mr. Srinivasan.
Yeah, I'll just put one comment before he starts to the team. Team, when we are supplying the engine to you, we are going to supply without catalytic converter, because we expect that some of you or many of you would participate in Go Green event, where you have to develop your own after treatment device. And hence this presentation will be very useful to you to get some ideas how can you win in the Go Green event. Yeah, please continue, sir.
Yes, Shankar sir, can you unmute yourself?
Yeah. Hello, am I audible?
Yeah. Yes, sir, you're audible.
Okay, thanks for the
Welcome, sir.
introduction, and yeah, very happy to be part of this presenting today on the exhaust after treatment system. So I will start sharing my screen. My voice is clear, right?
Yes, sir. Your voice is perfect.
Very good, very good. Let me share. Okay, I think you can see my screen, right?
Yes, sir. It is visible.
Okay, so very good afternoon to everyone again. What we are going to do in this session, the evolution of after treatment system for hydrogen ICE engine. And I will start with what I'm planning to cover. So Makarand emphasized the need to have after treatment system, even though hydrogen is essentially a non-carbon fuel. So what I will do is I will start with in the interest of everyone, some of you might be aware of the after treatment system technology for the diesel. However, I would like to start with what kind of architecture that we have when we talk about modern diesel powertrains and the kind of sensors and a little bit on the catalyst material and regeneration aspect. This is kind of up to this. I would call as part one. I will try to also, to save time, a little bit expedite my presentation in part one. Then I will move on to hydrogen specific details, what kind of exhaust that we expect from hydrogen ICE, what are the specific requirements, challenges that we face, how do we evolve an after treatment system for hydrogen exhaust. As you all are aware now, the focus more moving towards near zero emissions as hydrogen as a fuel is also competing with BEVs, battery electric vehicles, also to in the space for near zero emissions. So not just from the point of view of upcoming legislation like Euro 7, also or EPA 27, also in the context of moving towards zero emission, also we require an after treatment system. So and this is briefly how I have planned today. Again, after treatment system itself is a very complex topic. So the idea for this session, my intention is at least to give you an overview of all the challenges and the complexities involved in an after treatment system. So I would like to start with the basic layout. Typically, what we see in a modern diesel powertrain meeting Euro 6. We have 4 different stages here, starting with the diesel oxidation catalyst. This is, as the name indicates, mainly to oxidize certain species like the carbon monoxide and the unburnt hydrocarbon that is coming from the diesel emission. Also, it oxidizes the nitric oxide part of what we typically call NOx. NOx consists of NO, that is nitric oxide, and then NO2, which is nitrogen dioxide. And apart from that, there is another harmful constituent called nitrous oxide or the laughing gas. We call it as N2O. So the diesel oxidation catalyst also oxidizes NO to NO2. Why this is important? NO for 2 reasons mainly. NO2 also acts as a fuel to burn some particles in the next stage. And this also helps to kind of build a very favorable NO2 to NOx ratio. That is the ratio of nitrogen dioxide component of the NOx with respect to the overall overall NOx content. So there's a narrow window, or what we call it as a favorable ratio, where I have the maximum efficiency coming from this stage, which is a selective catalytic reduction. So these are the reasons why we employ an oxidation catalyst. Then we have a particulate filter, which is mainly to trap the soot particles. And then we have this exhaust gas stream flowing into the next stage, which is mainly the selective catalytic reduction. And upstream of this, we have something called a doser or an injector, which is injecting, you would have seen commercially, AdBlue solution. So which is nothing but an aqueous ammonia solution, which is 32.5% urea and 67.5% water. So this undergoes hydrolysis at temperatures above 200 and then generates steam and ammonia. This ammonia gas is used as the reductant in this stage. It reacts in the presence of oxygen and NO2, as I said, to convert nitrogen oxides or the NOx into nitrogen. Nitrogen is a harmless gas, as we all know. And then we also have ammonia slip catalyst, which is to oxidize the residual ammonia or the unutilized ammonia. This is important because with Euro 7 regulations onwards, we also have energy specific ammonia emissions, unlike the Euro 6. So this is in brief about layout that we have. This is typically how this is all packaged in a modern heavy duty diesel powertrain. So just to give you an idea, as we have discussed, the small unit here in the brown color is the DOC and the green one is the particulate filter. You can also see here relatively the size of each of these devices to understand how the size varies relatively. And this is a service lid. When the particulate filter gets clogged and requires regeneration at the workshop, this can be removed and then taken out. And then this is a mixer pipe, as I discussed, and this is one of the configurations typically employed in heavy duty, wherein after this mixer pipe, the exhaust gas gets split into two legs. This is for efficient packaging. We have two legs of selective catalytic reduction and slip catalyst, and then it comes out. Then moving ahead, this is to understand what kind of sensors that we employ. So this is represented in a pictorial or a linear way. The exhaust gases come and then pass through these four stages. We have temperature sensors upstream and downstream of DOC to understand how much of heat energy is released, because oxidizing hydrocarbon is also exothermic. Then we have particulate filter, where we measure the pressure drop. That is called delta pressure sensor. This is important to understand and trigger some of the regeneration events, and also to decide when the filter is due for service based on how the pressure drop builds. As we trap more and more soot here, the pressure drop keeps building, and at one stage we need to forcefully regenerate and then burn the soot particles. That's how it works. Then this is the very important stage where we have the NOx reduction happening. So we have this T3 sensor upstream, and then the NOx sensors upstream and downstream. So there is a complex algorithm to decide how much of AdBlue or the urea solution to be injected based on the mass flow rates, the NOx concentration, and the temperature. A carefully controlled amount of urea is injected, and then we also constantly monitor the NOx conversion efficiency to understand and kind of have a feedback mechanism for the efficient working of the system. Now I will move ahead. This is to give you an understanding of how much of this conversion happens. More or less, this is give me a moment. This is so to say a very basic for a basic system. As you see in the DOC, your carbon monoxide and hydrocarbon, this red and blue streams, are getting oxidized almost by 90%. They are converted more than 90% of them are oxidized. Then the particulate filter generally works more than 99% efficiency. It traps almost all of the soot particles. And then we have the very important NOx, which typically gets converted in the selective catalytic region into nitrogen and water, and then the slip catalyst for ammonia. So for a basic system, this is mentioned 90% conversion, but today's modern systems, we have, once the catalyst reaches the light of temperature of about 220 degrees, we have conversion reaching 98%, 99% also. And most of the time, whenever the topic of after treatment is discussed, the main focus revolves around the NOx. So I wanted to also tell you, you might be wondering why is it there are many constituents. That's because nowadays the technology has advanced and the combustion is, as Makarand explained, we are trying to reach more and more closer to ideal combustion and improve the efficiency, which means we have very good combustion, and the unburned hydrocarbon and CO is very low, that is coming out from the engine. However, the interesting part to note here is, as you go towards a very cleaner combustion and improve fuel efficiency, you are also increasing NOx. The cleaner combustion means you are actually burning the fuel completely, and then it also results in a higher NOx. That's one reason. And also the NOx variation, the engine out NOx, depending on the what load and speed you operate, varies drastically, which we call it in technical terms the transient emissions. So this poses a major challenge for the after treatment system. You need to have a system which is very robust, which can handle very high transients, especially moving towards the real drive emission window getting extended in Euro 7. And then, as I said in the beginning, going towards the near zero emissions, we need to handle the very high transient peaks happening, even though it might happen during very harsh acceleration or when you have a very high load kind of hill climbing and things like that. But still, the after treatment system has to take care of such transient points as well. So just keep in mind this particular point, why we are discussing more and more about NOx conversion as we go along. So very briefly, I will not go too much deep into this, but this is mainly for you to understand that a particulate filter does require a regeneration depending on how the soot builds up. There are different ways of regeneration, mainly two ways. Time being, I will not concentrate on the service center regeneration. So what could happen is, depending on the drive cycle, there could be certain nature of driving where you get exhaust at a higher temperature and the soot particles can burn even while you are driving the truck or your car in a normal way. That is what we call as passive regeneration. But depending on the type of operation, mostly highway operation and things like that, you may not have enough opportunities to passively regenerate. And then based on the soot buildup, there could be a point where we need to forcefully go for certain combustion control measures to rise the exhaust temperature and enhance the regeneration, which is called active regeneration, which happens also during normal driving up to a certain point. And beyond a point, there will be a message wherein you need to take your truck to a standstill, and then the truck is operated, the engine is run at a very high, at the maximum speed, in order to generate higher temperatures, sometimes with additional hydrocarbon injection upstream of the EAT system, what we call it as hydrocarbon dosing, and then the particulate filter gets regenerated. So this is very briefly, as I said, talking about the NOx conversion. As of today, the technology is evolving, but as of today, there are two major candidates as a catalyst, which is vanadium and copper as a catalyst supported on a zeolite matrix. So I will only focus on the key difference. Just for you to remember, vanadium as a catalyst generally it doesn't produce too much of N2O. Most of the NOx gets converted to nitrogen, what we call it as a selective catalytic reduction. Production of N2O is known as non-selective reactions, which are not favorable. So that is the advantage what Vanadium has. On the other hand, if you are talking about copper or iron supported on zeolite, you have a lower temperature light off. It can handle at a lower temperature. And another key difference is that when you have a zeolite, you have a very good ammonia storage. So I will explain a little bit on this. When you inject urea, ammonia gets generated after hydrolysis and thermolysis. This ammonia is utilized in two ways. One is directly it enters into the reaction and helps in NOx conversion, and a significant portion of this ammonia is also stored or absorbed in the catalyst and then released as and when we have a very transient operation and we need to have this kind of a sudden ammonia requirement. So that is where we have an advantage in zeolite, where we have the capability to store more ammonia. So whereas on the other hand, in vanadium, we need to depend more on the urea injection because the dynamic storage capacity is on the lower side. So in short, for you to remember, we are moving more and more towards vanadium as we go towards Euro 7 and stringent emission norms. The main reason for that is that N2O is also becoming a regulated species, so that we need to be very careful about this. It's not just conversion of nitrogen oxides, but we also need to have higher selectivity towards nitrogen and produce very less N2O. N2O is a greenhouse gas which is getting regulated from Euro 7 onwards. So these are also topics very important when we talk in terms of hydrogen context, because hydrogen, as we know, it's a carbon-free fuel and the main focus is on the NOx. So as I said in the beginning, now I will move to the part 2, where I mainly talk about the hydrogen specific exhaust. So what are the sources exhausting as well as from itself? So as we see here, the apart from electrolysis, we get very high purity, which is a requirement for fuel cell. However, from the IC engine point of view, majorly steam reforming, methane steam reforming or coal gasification can be used, and the purity, as you see here, it's 95% or less than 90%, which means it has other constituents as well, including CH4, which can also result in some amount of carbon monoxide emissions and methane emissions. So one is coming from the hydrogen purity, and then we also have the engine oil, which partly gets burnt inside the combustion chamber, that can result in your particulate matter. And another source of particulate is urea particles, because we use urea for NOx reduction, as I've been discussing. And you might be aware of PN10 emissions, which is mandatory from Euro 7 onwards, which means we start counting particles of diameter 10 nanometer and above, unlike PN23. So urea particles also fall in that category, and we have to be very mindful of how we tackle this when we are using urea for NOx reduction. Then there could be other pollutants, as I said, nitrogen dioxide. So if we employ an oxidation catalyst, and especially for hydrogen, because we do not have soot or carbon monoxide, so the reaction pathway will be favored towards oxidation of NO to NO2. So we have to be mindful of reaching unfavorable NO2 to NOx ratio, or NO2 itself as a pollutant, or this NO2 can also result in non-selective reaction at the SCR and things like that. So methane, we talked about it. There can be methane gets combusted within the combustion chamber, but still there could be methane emissions, and ammonia also can be coming from the urea injection. So reduction with hydrogen could be a possibility. So the question that often comes, and a lot of research going on, why not use hydrogen itself as a reductant instead of using ammonia? There are pros and cons. Hydrogen anyhow is available as a fuel, so it's easy to design a system where we use hydrogen rather than having a dedicated AdBlue storage tank and then dedicated injector and things like that. However, this is very important since you guys are focusing more on research, especially from the context of hydrogen after treatment. So just focus on this graph to understand more about using hydrogen as a reductant. So what happens is on the right side, you have the hydrogen reaction path share, which means hydrogen gets easily combusted within the after treatment system, gets oxidized. So we do not have whatever hydrogen I dose as a reductant, I do not have the full of hydrogen available for my NOx conversion. So this is from a technical paper which is tested on a palladium catalyst. So if you see here, the maximum conversion, NOx conversion is about 50%, unlike what we talked about, 95, more than 95% with the traditional or classical urea-based system. So this is one major drawback using hydrogen. With platinum, we are getting better conversions, but not as much as a classical system. And another interesting aspect, as I was saying, even when I have maximum NOx conversion, just focus around this point, my reaction path share on the right hand side, only about 10% of hydrogen is actually used for NOx conversion, which is the pink and blue put together. Pink is the nitrogen formation reaction. The blue is N2O formation. The rest of the 90% is almost utilized just as a hydrogen combustion reaction. So this is one major drawback. However, technology is evolving, new type of catalysts are coming up. You guys could research more into it. Hydrogen, using hydrogen as a reductant, especially with platinum, has a very good advantage that the light off temperature is lower, which means, as we all know, when the engine is cold, the emissions are higher, and we are also generally talking about cold start emission as a major challenge. Though with respect to nitrogen, it's a little better with respect to NOx. So these are pros and cons, just to give you a perspective. Then continuing our discussion on the exhaust species, the residual hydrogen itself, which is a major factor. Hydrogen is not a greenhouse gas, but what is important for you guys to understand is that hydrogen interferes with the methane cycle in the atmosphere. So scientists have defined what is called as a global warming potential for hydrogen gas also. So it's about 11, which means 1 kg of hydrogen can be as harmful as 11 kgs of CO2. The GWP CO2 equivalent is about 11. So, which means hydrogen also has to be regulated, probably in future, not now. Not just from the flammability point of view, but also as a gas having a greenhouse, having a global warming potential. So if you see, engine out hydrogen is typically 2000 to 5000 ppm, whereas tailpipe out, if you have a very good after treatment system, is as low as 0.1%. Most of them gets utilized. We have a lower combustion limit of 4%. Then engine out water is pretty much higher, almost double. If you see for diesel, it's less than 10%, whereas hydrogen can go up to 20%. So what are the side effects? It can interfere with ammonia storage when we are talking about the after treatment perspective. And then the long-term device durability, because water can also result in premature or faster aging of the catalyst. Engine out oxygen is generally 10%, which is also much higher compared to diesel. This can also result in long-term durability. This higher oxygen is also responsible for those challenges I just talked about, having an oxidation catalyst and higher oxygen, which means I am oxidizing most of my NO to NO2. And this will have a non-favorable ratio when I come to selective catalytic reduction, apart from other drawbacks. So these are challenges you have to keep in mind. Generally, because the especially the common tendency is that hydrogen ICE, which means very less NOx emissions, and the after treatment system can be very simpler, or we don't need after treatment system. But then hydrogen introduces its own challenges. So that's the key point, what I am opening up for you. So again, continuing challenges, most of this, I think I already discussed. The oxidation catalyst can oxidize NO, and then unfavorable NO to NOx ratio I talked about. Just a moment, let me check how I am doing with time. It's 1:15. I have up to 1:30, right?
Yes, yes, sir. We have 1:30, and then we will have 15 minutes Q&A session.
Okay, that means I have another 15 minutes. Okay, I think
Yes, yes,
I
sir.
can speed up a little bit, and then yeah, I can cover. So unfavorable NO to NOx ratio we talked about. Lower exhaust temperature can lead to longer light of times. As we know, hydrogen operates pretty much linear region. Makarand has explained it in detail. So linear operating regions, exhaust gas temperatures are lower compared to diesel, which means the hydrogen for that phase, and it can lead to different inhibition properties. So in after treatment terminology, we use this word inhibition, which means that there are certain reactions, chemical reactions, and the relative composition of these constituents can alter the pathway. Some reactions can be favored, and some reactions can become, the rate can go down, which we call it as how this inhibits or expedites certain reactions. Higher water content can lead to faster aging, and another drawback also I mentioned, it can interfere with the ammonia storage on the catalyst. Then smaller devices, many times we are tempted to reduce the size of the after treatment devices. But what we need to keep in mind, it can also result in higher space velocities, which means the constituents have lesser residual time in the catalyst, and which means generally in after treatment system, to go a little bit technical here, we assume that the species diffuse into the catalyst active surface rather instantaneously, and the reactions are generally limited by kinetics. When I say kinetic limited, which means the concentration of the constituents and the temperature, they are controlling the rate of reaction, not the diffusion. But what happens when you have smaller devices, the diffusion is not, so to say, as sudden as we generally assume. And in such case, what can happen is your inlet conditions can change faster than the diffusion, and the diffusion can itself set limits for your reactions. Then very different reaction kind dynamics we talked about. I will quickly move to the next one. Okay, this slide I will not cover much. This is in general about the cold start measures for controlling the NOx from the hydrogen engine. Combustion side, Makarand already covered in detail. So only from the after treatment perspective, I would like to focus on this region. There are different technologies for you to take a deep dive and explore. One is electrically heated catalyst. So as I said, it might take in hydrogen exhaust longer time to heat up. Then there are research going on by employing electrically heated catalyst, especially in the cold start first few minutes of the engine exhaust. Then hydrogen late post injection. So this is one thing. So this is also as a technology you can explore, having a hydrogen post injection during the exhaust stroke or upstream of the EAT system to have some kind of hydrogen based conversion also, in addition to classic ammonia based. Then moving on, we have the after treatment. What should be my after treatment configuration with respect to LPDA and hBAJA? So LPDA, hBAJA now you guys must be knowing very well from Makarand's presentation. So I'll just touch upon what influence it will have from the after treatment perspective. So when we are talking about low pressure direct injection, the ignition is from the spark plug. We do not have any diesel pilot injection. So which means also the temperatures and pressure rise is much lower compared to hBAJA and lower NOx levels. So what I have the possibility to keep the particulate filter in the end, because I do not have to generate generate NO2 to burn the soot. The particulate filter can take a longer time for the soot buildup. There is very low soot in case of LPDA engine. So I do not have to lose my thermal energy by placing it upstream of SCR, which is typically the case. But so I have the possibility to keep it downstream. Then the oxidation catalyst can be dispensed with because I have no soot, or so to say very low soot, very low hydrocarbon only coming from the engine oil. There is no other carbon based constituent in this engine. Then standard SCR reactions are sufficient. Okay, in selective catalytic reduction stage, just to keep things simple, just remember there are two types of reactions. One, we call it as a faster reactions, which is aided by the presence of NO2. Since in LPDA engine, I have relatively lower NOx to handle, I can depend only on the standard reactions, which is oxygen based. So I can actually I have the possibility to remove oxidation catalyst. So these are the ways how the after treatment can be simplified when it comes to LPDA. But the story is different when we talk about HPDA. One thing, we have higher NOx concentrations, so we need to have larger SCR. Then we also have diesel pilot, which means we do have soot emissions and CO emissions to take care, and then we need to have a DOC and PF, as in an LNG or diesel. So from the commercial point of view, OEMs are also more and more discussing about having a common variant between a HPDA hydrogen engine and LNG and diesel, which makes a lot of sense from the commercial point of view. Then aging and oxidation catalyst performance in low CO and soot, which I already discussed, those challenges have to be investigated. So this is again the DOC oxidases, residual hydrogen and significant amount of NO. We discussed about this. Then having OC and PF, that is oxidation catalyst, particulate filter, thermal mass lowers the temperature. And these are some of the challenges we need to solve when we talk about after treatment for hydrogen. Then we have water and ammonia adsorption talked about. I will move ahead. No problem. Okay, this is more or less, now I am close to 125. My last slide, which talks about building the reaction, not last slide actually, couple of slides, building a predictive reaction scheme for the hydrogen specific exhaust. So we have been talking about challenges when it comes to hydrogen. It has a different kind of composition and then different kind of reaction pathways. So how do we do? So what we do is there are certain new reactions which are specific, like hydrogen oxidation and then H2SCR reaction, wherein the NOx reduction happens with hydrogen as a reductant, then water condensation, all these things. Modification of inhibition factors, something I talked about. So how are we going to calibrate the reaction scheme, add new reaction scheme? What we do is typically the SGB test meaning synthetic gas bench. It is called synthetic gas bench because I have a possibility to synthetically prepare a composition of the exhaust gas similar to what I get from engine exhaust. The advantage of doing this is I can have controlled variation of one particular concentration of one particular constituent and study its influence on the reactions. So this kind of facilities are mostly with catalyst OEM, catalyst suppliers, and more and more OEMs are also showing interest. Some of the OEMs also have built these facilities, and you have the possibility to have a slower temperature ramp from 100 to 400 or 500 degrees with 3 to 5 degrees centigrade per minute. Nowadays, it is also possible in SGBs to go as low as 2 degrees. The advantage here is I can very closely study the light off temperatures. unlike in a transient cycle where the exhaust temperatures can rise very fast as 100 degrees per minute or so. In SGP, what we usually do is we take a small catalyst sample of 10 cc or so, which is surrounded by glass wool, and then heated with an electric heating element so as to have same temperature as the exhaust gas, and then that is how it is repeated with different compositions. So what is the challenge here when we talk about calibrating the kinetics with the SGB? The challenge is to have a single set of kinetics with good correlation for different inlet gas compositions, different operating conditions, so to say. So just for you guys to understand what a synthetic gas bench looks like. So this is basically the reactor, what we call it as a quartz reactor, wherein there's a facility to mount the catalyst sample with insulation and the heating element, and this is the synthetic gas mixer, and there is a possibility to add steam and hydrocarbon in order to control the lambda of the exhaust, and you have a heated line. And this test bench also comes with the facility if you want to use the engine exhaust. There is a you can switch between actual engine exhaust and the synthetic exhaust. So these kind of trials are possible. People want to know more about this, they can watch this video in this link. Maybe I will put it in the chat box later for you to explore more into understanding what is the synthetic gas bench and how it helps and how the tests are conducted, things like that. So a little bit into the simulation. So in Volvo, we like in any other OEM, we use extensively the simulation capabilities. So just to take you through the steps involved, as I said, building a predictive reaction scheme is the first step. We use extensively the synthetic gas bench data, and we also model the water absorption in zeolite especially, which is an exothermic reaction which alters the temperature profile of the exhaust. Then ammonia storage profile estimation, because this is different when water interferes the storage dynamics. Then we set the ammonia target buffer ratio. So the catalyst has certain level of storage capacity, but does not mean that we dose so much ammonia to store full ammonia on the catalyst. We also have a complex algorithm to decide what should be my target storage. Then if I'm using hydrogen as a reductant, then I also need to develop the dosing algorithm. Then system level investigations to assess the predictive performance of different configurations. We briefly discussed about the kind of simplification that is possible, especially for an LPDI engine. Then finally, the model calibration needs to be done based on the actual engine test bed measurements. Even though we do to a large extent based on the synthetic gas bench data, we also need to finally fine tune a little bit based on the actual drive cycles. So that's just to give you a glimpse of what we do in simulation, which is generally upfront in the product development cycle. And it's very important from the OEM point of view because it saves a lot of development time, efforts, and cost. So more or less, that's what I wanted to cover. How are we doing time? 1:28. So yeah, maybe Varad, we can look at questions or
Yes,
have
sir.
a discussion if yeah, there are.
Thank you, sir. Thank you for that comprehensive session. It is fascinating to see how exhaust after treatment is evolving with hydrogen technology. Now moving on to the questions, we have first question. How do we take care of steam coming from H2IC exhaust as it may affect NOx conversion efficiency?
How do we take care of?
Steam coming out of hydrogen IC engine exhaust.
Okay. Very good question, actually. As I said, steam or the water content in H2ICE is much higher compared to diesel. So it interferes in many ways. One, majorly, it interferes with ammonia getting absorbed into the catalyst. So we need to recalibrate the ammonia storage profile and accordingly alter the dosing algorithm. First thing. Second thing, it also results in faster aging. So there is no conclusive evidence as of now if you search, you will see some research papers discussing about the effect of water on the aging. Then also what is important, as I said, we have also seen in our own research in Volvo, not just it impacts the storage dynamics, but it also influences the selectivity. It kind of favors production of more N2O. So this is just a first-hand information what we have seen. You can again see a lot of research going on in this direction. But short answer to your question, the reaction scheme has to be very carefully calibrated for the kind of water concentrations that we see in the exhaust.
Okay. Okay, sir. Thank you. Next up, we have in case of sub-zero treatment, in case of sub-zero temperature, sorry, in case of sub-zero temperature, how do we tackle the issues of hydrogen IC engine exhaust?
So generally, cold start, sub-zero temperatures, there are different ways. First thing, if we are talking about sub-zero temperatures, it takes some time for the combustion temperature to reach the levels, and in the very initial stages, we might expect a lower NOx, which is good for us. Secondly, there are ways people are thinking about. I presume your question is more from the cold start emissions, especially if you have an aggressive drive cycle. Then the catalyst not reaching the light off temperature, but then the combustion has reached the temperature where we produce NOx. This is what I presume your question is about. Then the main technology that is being discussed today is having a heated catalyst or heaters in the exhaust path that would heat the exhaust gas stream itself. So this is also being debated for EPA 27, which is the regulation in United States forthcoming in the year 2027, which mandates very low NOx emissions, even for diesel. So catalyst heating is the short answer for you. One of the major contending topics, today being discussed for cold start emissions.
Okay. The last question we have, what is the typical temperature at the exhaust manifold for a hydrogen IC engine?
Okay. Very good question. We have seen, I would say, at the temperature at the upstream of yachts on sub-zero temperatures as the ambient and the engine having a completely cold start. In the initial few minutes, upstream of my selective catalyst reduction, there are temperatures as low as 50-60 degrees, but very soon it catches up to 200 to 250 degrees easily, which is the light off temperature for a typical urea based system. So if you see, that is where the interest on using hydrogen as a reductant is gaining more and more importance, especially discussing from the hydrogen point of view and having lower temperatures. If you see overall the operating map of a hydrogen engine, in most of the operating regions, the temperatures are lower by 50 degrees or so compared to a typical diesel exhaust. Yeah, that's how I would put it. Very much depends on the speed and load. That's why I'm saying, as I have explained, when it comes to hydrogen, a lot of these topics, cold start emissions and what would be the best reductant, hydrogen or ammonia, can we have a combination? These things are being debated and a lot of literature being published. So yeah, as I said, I'm just trying to give you a overview of the challenges and how the system requirements change when we talk from the hydrogen perspective, so that you can explore more.
Yes, thank you so much, sir. That was all for the questions. Thank you for.
Thank you. My pleasure to be part of this. Yeah, thanks. Have a great day ahead. All of you.
Yes. Next up, guys, I assume everyone is like hungry right now. So let us have our lunches and be back at 2:45 p.m. for the afternoon sessions, where we will still have 3 sessions to cover. The first one being HCNG Bifuel Engine and Control Systems by Dr. Syed and his team. Then we have HCNG Injection Kit Component and Integration by Gaiki sir. And then at the end of the day, we will have DFME and DVP session for engine and HCNG kit from Dr. Vora. So let us tune in at 2:45 p.m.
Before leaving, hello.
Yes, sir. Yes, sir.
Before you, actually, I have a question for Shankar sir.
Yes, sir.
Regarding this market, after treatment things. What significant changes we have to do with along with this current change system? What uh, what effect of a hydrogen will be shown on this current exhaust system? Means right now we are using three-way catalyst. Any other changes we need to do that when we are using engine? That was my question.
Hello, can you hear me?
Yeah, I can hear you. Yeah,
So I
with
guess
existing system, with existing CNG system, we are now moving ahead for the HCNG. Regarding that,
okay,
we are using three-way catalyst right now.
okay,
Now we are going to use this HCNG thing, HCNG fuel. What significant change we have to do when we are adopting this HCNG fuel for this engine, and what will be a exhaust gases, and what will be a reaction of hydrogen on this three-way catalyst?
okay. So using, in my understanding, you are using a three-way catalyst, so it's more or less you are talking about stoichiometric combustion of the natural gas. So that's when generally people try to use adapt three-way catalyst. So mainly what happens is as you adopt a three-way catalyst, even for a natural gas engine. I'm saying pure natural gas, not HCNG. Even for that, the optimum conversion point gets shifted towards leaner region than the lambda equal to 1. So what I would expect here, when you have hydrogen, this is going to again have an impact on the point of optimum conversion getting shifted. This is what we have seen when we adopt a three-way catalytic converter for even for a natural gas engine. You would have gone through the same thing, I guess. So with hydrogen in the with HCNG, talking about HCNG, so this is going to have, I guess, a similar impact when it comes to the redox state of the exhaust, and we will have to recalibrate so that we make the catalyst or the catalytic converter efficient at the kind of lambda values that we are getting, because having hydrogen in the hydrogen as a mix in the fuel, so to say, the HCNG is going to alter the lambda value. Essentially, I'm talking about the redox state of the exhaust, not about the air fuel ratio of the engine. I'm talking about the redox state of the exhaust. So that's going to change. To what extent this 18% will bring in, that is something we will have to simulate or test it. That is something difficult to say as a thumb rule or something like that.
So on that thing, see, right now I'm concentrating on with CNG or natural gas engine.
Sorry, your voice is
okay.
Concentrating on. Can you come again?
Just a minute. On the similar your on the based on your answer, I have asked one more question. See, right now we are adjusting our lambda, means air fuel ratio is equal to 1. With using CNG, we have to shift our lambda to 1.2. Maybe 0.1, 0.2 here or there, means X or
right.
yeah. So right already my exhaust temperature is about 600 for particular this engine. I'm talking about a
Okay.
GL for 400 engine or single cylinder engine. My exhaust temperature is about 600, about 600 degrees centigrade. And now
Which engine is this you're talking about?
I'm talking about the current engine which is we are using for this event, GL 400 cruise engine. Okay, so it will be around a 600 degrees centigrade. Now I'm shifting my lambda. Now I'm shifting my lambda 1 to 1.2. Definitely my exhaust temperature will be increased, definitely increased by 50 degree or I don't know exactly because we don't have that much data on that. So what of this three-way catalyst on that base? What exactly we are adapting CNG? We have to change this three-way catalyst and any other compositions for this inside the cat.
Varat, can you repeat the question? Rajesh voice was breaking.
Shankar, let me explain this to you. So basically, they are using the CNG engine right now with Lambda 1.
Okay.
It's CNG, it may Lambda will change maybe up to 1.0 or something. And with this HCNG coming up, so they are asking any change in the three-way catalyst they need to do because of the introduction of hydrogen in CNG.
Yeah, so that's what I was trying to see. I was trying to say. So the conversion efficiency might get affected because three-way catalytic converters are extremely sensitive to lambda. So even a slight variation from 1.2 addition of hydrogen might slightly change, and then the catalyst may not operate at the best efficiency what it has already been tuned. But to answer what changes are required, how much it would impact, we cannot say unless we do a simulation or test it. Because this is hydrogen addition is also a newer thing, and yeah.
Okay, we can discuss on that once we are in a calibration mode with HCNG. Might be your input will be one of the best input in that case. What we can do with this existing three-way catalyst.
Yeah, sure.
Thank you. Thank you much.
Yes, I guess we're done with the questions, right? Okay, so just to add one thing, the session will still be online only. Don't leave the meeting. You can have your break while in the meeting, okay? Post lunch, we will be having Dr. Kalimuddin's session on HCNG bifuel engine and control system. Please tune in at 2:45 p.m. We will start. Hello. Hello. Am I audible?
Yes, Varad, yes.
Yes. So let us begin with our second half of the day. So welcome back, everyone. I hope all of us had a good lunch. So kicking off our afternoon sessions, we have a topic on HCNG biofuel engine and control systems. And we are delighted to have our convener, Dr. Kalimuddin Sayed, Mr. Suresh Sajjan, and Mr. Girish Khairnar from Greaves Cotton to lead this session. Dr. Kalimuddin is the general manager at Greaves Technology Center, Greaves Cotton Limited, with overall 25 years of R&D experience. He holds a PhD in mechanical engineering and has published 18 technical papers in leading international journals. Dr. Sayed specializes in emission optimization and advanced engine innovation for BS6 norms. Let us dive into this session. Over to you, Dr.
Varad, I guess Kalimuddin sir just dropped out of the call. So let's just wait
Okay.
for a bit.
Okay, we will wait for some time. Okay, I suppose Kalimuddin sir is having some network issue. He will be joining in a bit. Until then, you can all just settle down.
So Varad, I think so. Kalimuddin sir is here. So
Okay. Welcome, Dr. Kalimuddin sir.
Yeah, thanks, Ruturaj.
So let us
So,
begin
shall
with
we
our
start the
session, sir.
session?
Yes, sir.
Yeah, okay.
Over to you.
Yeah. Good afternoon, everybody. Regret for actually I'm facing some internet issue because of heavy rains in here. So no problem. But I think now it's available internet connections. So we'll go slide by slide. So my presentation would be on the engine controls, what we are going to give engine for this hBAJA application point of view. And if you can go to the second slide, I'll just share the contents. What is the content of my presentation?
Before that, Kalimuddin sir, can you just
Yeah.
switch on your video if the network allows?
No, not opening. Yeah, problem is there.
Okay, no issues.
Yeah. Now it's opening.
Yeah, we can see you. Okay, fine.
Okay.
Let's continue, sir.
Yeah. It's going now. I don't know whether you can able to see me.
Yes, we can see you, sir.
Yeah. So mostly this presentation, if you go to second slide, that will be comfortable for you. I cannot move the slides, or whether I'm having access to move the slides.
No, sir. We will change the slides.
Fine.
Yes.
Okay. So I'll just close my video so that will be comfortable to explain you all.
Yes. Okay, sir. Fine.
Yeah. So good afternoon, everybody, and good afternoon to the new team. Just go through the contents. So what is there in the presentation? Presentation will have few slides on HCNG, the futuristic fuel for IC engines. Then I'll be explaining engine specification, engine performance, engine nomenclatures, engine sensor layouts, sensors and actuators, engine lubrication systems. All over the systems of these engines will be explained to you. Then the layout for the packaging, and then the tightening torques and the service schedule, what is needed. Then some photos I'm having of the last year buggies. So that will give you some insight of the this product, how you are going to package on your new buggy, which is upcoming in the month of January. So can you go to next slide then? Yeah. So just I think morning session was it is a good marathon session for technicality for all the hydrogen and HCNG and other alternate fuel and carbon prints that were explained, where zero carbon was explained by Makrant in detail. So I'll not go in much detail, but just to refresh it, why we have opted for hydrogen CNG natural gas engines for your H buggy. So the main advantage of hydrogen enriched composite natural engine is that the rapid increase in emission and greenhouse gases, where strict in environmental legislation and major motivating factors for this application for hydrogen into HCNG. And it can be easily applicable for available internal combustion engine which has been used, whether it is small engine or a bigger engine. Secondly, hydrogen resources are in vast. it can be considered one of the most promising fuel for automotive sector. And hydrogen has been regarded as a future secondary fuel for power system due to carbon-free operation. This was explained in detail by Makarant in morning session. I will not touch upon it much. Then the third point is that the hydrogen is in natural gases, the burning velocity of the mixture, the shortening of combustion duration, increasing the cylinder gas temperatures, and increasing effective thermal efficiencies are all the merits for this hydrogen HCNG engines. Then HC engine increases the hydrogen carbon ratio of the fuel, which drastically reduces the carbon based emissions such as CO, CO2, and HC. So the advantage is that whatever the after treatments we are using on the engine, so their precious metal loading can be lowered down, and it will become more economical and viable solution for automotive application. To increase the flame speed HCNG, the ignition timing needs to be retarded. This results in the reduction of the NOx emissions. So this optimization and other things, Greaves is looking into consideration, wherein we are having, we can say, technical tie-up with ARA. They are also guiding us to optimize this engine. So, and they are also supplying us HCNG fuel and facilities we are having and engines we are having. So that can be done at our end. Next point, it is important to note that 18% blend of hydrogen by volume with the CNG, the phenomenon of hydrogen intermittent doesn't occur. So the hydrogen intermittent is the most predominant problem of the hydrogen as an application. So if we are using 18% blends, so the hydrogen intermittent we could not able to see on the engine components like cylinder head, barrel, piston, cylinder, then other components of the engines. So no major changes is anticipated on the engine side and the engine component. Then with the HCNG, you'll find the improve in efficiencies and with lower fuel consumption and hydrogen emissions. So these are the few merits for the HCNG, and government is also, I think if we go to next slide, I've also shared some technical things related to HCNG. Bharat, can you help me out? The farmer.
Yes, sir.
Hello.
Hello. Yes, sir.
Can you take me to the next slide, please?
Okay, just a minute, sir. Yes, advantages, right?
Hello. Ruturaj, can you help me out to take to the next slide then?
Yes, sir. Actually, right now we are on advantages of HCNG, or do you want the earlier slide, the properties slide? Hello. So you're there?
Rutraj, Bharat, can you call him up one time? Yeah, go to next slide. Yes, to Rhythm, can you go to next slide? Yeah, thank you. Kalvin sir, can you hear us?
Hello.
We could hear you, sir. Can you go ahead?
No, my screen is not moving now.
Sir, maybe you can turn off your
Okay.
video. Yeah.
I want slide number. Actually, I couldn't see properly, and yes, my slides is not moving now. Problem where? Hello.
I think it is
मैं नहीं
something
देख
to
पा
do
रहा हूँ
with the
सर, स्लाइड नहीं
network.
देख पा रहा हूँ. Slide number 5. I want to go on slide number 5.
Okay. Rhythm, can you just make that change?
Yeah, correct.
I'm stuck. I don't know whether I have to go out and again connect.
Yes, I think so, sir.
And
Because
sir,
I'm
We can
facing
see the
problem, I think.
presentation.
you may
Well,
turn
again, I
off
have to
your.
leave and again have to join, or you can refresh it. I think
Sir, you may turn off your
I'll
video.
again
Sir.
rejoin.
Okay, okay, sir.
Meanwhile, I request all the team members to ask your team to join. As I can see, still post lunch, it's not yet the full house. Okay, I can see that Dr. Kalimuddin has joined, and I'll just give him the access. Kalimuddin sir, can you hear us?
Yeah. Actually, there was a problem I faced through internet.
Okay, no problem, sir. Rhythm, can you share the screen and go to slide number 5? Rhythm? Yeah, slide number 5. Yes, can you go to slide number 5, please? Yeah. Right. Sir, is this
Yeah,
okay?
actually, yeah. You can keep this slide. Apology for actually getting disconnected. Reason is that my internet, I'm facing some issues on internet. Okay. So here actually, I think Makrant has explained in detail. The only thing I want to explain here is that if you compare CNG to HCNG, here the advantage what we'll be getting is the flame velocity and the flame burning velocity. You can see it's totally double as compared to CNG. So wherein we will have advantage to use a cooler spark plug and a lower ignition coil, and of course the combustion out emission will be certainly lower because of a lower carbon contents and addition of hydrogen to almost 18%. So that two factors is playing major role for using of HCNG as an application as compared to CNG. And I think this was already explained to you in detail by Makran, so I'll skip off this and go to the next slide. And just for your information, that the equivalence ratio, best equivalence ratio is been considered as 0.6. Okay, and at CNG, we can able to achieve a theoretical nearby to theoretical, that is ranging from 0.5 to 5.6. So that is a better fuel as compared to CNG. That is giving a edge on CNG to use HCNG as an application. Can you go to next slide now? Yeah. A few advantages I have just noted down here. It is usable with the existing CNG infrastructure. That is the biggest advantage we had. And requires only a small hydrogen storage and a column for a fixing of hydrogen, mixing of hydrogen with natural gas. Then safety properties are similar to CNG, so not a botheration much. But of course, when we are moving ahead for HCNG, we'll definitely recommend to use flame detector in our application. So that I am in discussion with Dr. Vora also. So some small assignment as a project, as an innovation will be given to Baha team who can able to use that flame detector on this application. Then it is safer to handle, being less volume, percentage by volume. The extent of lean misfire limit of CNG is one of the advantage, because we'll get a low NOx emissions with it. Then minor modifications are required in the engine due to moderate concentration of hydrogen in the fuel mixture, and excellent anti-knock characteristics of CNG are not undermined here. Okay. The phenomena of hydrogen intermittent does not, I already spelled out. Then hydrogen addition to natural gas can decrease engine unburned hydrocarbon. That also I spelled out. Then it improves the engine efficiency and lower fuel consumption. That also we explained. That was also explained earlier. So these are the advantage. And of course, government is also taking a decision to blend CNG with 20% hydrogen. So that is the regulation requirement in future. So that will give us to explore more. So to see the application, how HCNG behaves on automobile side, or the students what they are trying on hBAJA. So this will give a small edge for us to take it way forward to use HCNG in future application, and to what extent we can able to blend it, whether 30%, 40%, that will also give us some edge. Go to next slide then. Hello. Yeah. Few challenges for HCNG. Then HCNG storage and simple supply infrastructure is still not in developed stage, where it is under development only. Then efforts to be focused on responding to fuel system performance, material compatibility, because hydrogen having a tendency of embrittlement, we have to review all the material performances what we are going to use in our IC engines. Then emission testing with more ranges of hydrogen in HCNG blends, that is still open point. What is the means till the experiments and the literature says till 20% HCNG is okay to be used with mixing with CNG. So whether we can able to explore further with 30%, 40%, that is still open point. Then continuous availability of HCNG need to be assured before embarking on its major use in IC engines. The next point is continued engine performance, emissions, and durability testing in variety of engine type, size need to be developed to increase consumer and manufacturer confidence. These are the open points. In the future time, I think it is going to be closed, or some data will be there where we can able to take a confident engineering decision now. Then development of less expensive quality test. This is also challenging, because HCNG is hydrogen. So what safety features is required? What are the detections to be needed? That has to be explored. So that is under development. So these are the challenges, but in future coming years, I think that challenges will be overcome. Can you please go, Parma, to next slide? Yeah. Now this is for the team. Now I think this literatures and other thing informative. First half was explained in detail by Makrant and the other team members. But now this is important from here, because we are going to offer you from Greaves Cotton this G400 WG engine, and you have to understand the total product out of it, so that you can package it properly and perform it on the your buggy, as well as some endurance. What factors you have to take it, what systems has to be packaged properly, considering due safeties, and it should able to withstand the endurance cycle what has been defined by the committee members. So this everything has to be taken care. So watch carefully this presentation of the engine what we are going to present you, so that you can able to applicate it on your buggy in proper way. So this engine is having a 400 cubic capacity, more precisely 396 cubic capacity, with a bore of 86 to 68 millimeters. And its rating is almost 7.25 kilowatt, which corresponds to almost 10 HP, around 3600 RPM. And maximum torque corresponds to 23 Newton meter, which comes around 2000 RPM. Its weight is almost 46 kg. And oil capacity, it is having in a spin-on filter. We'll go in detail when we'll go to the next slides. Oil capacity is 1.6 liters. And if suppose you delay the filter, what has been there in the spin-on filter, that consumes almost 200 ml. So if you subtract it, so it comes to be 1.4 liters. Then lubrication is the forced feed, and filter is a spin-on, where you can able to, it is removable, serviceable, and you have to just replace it with a new one. Then cooling system, it is a waterized, pressurized circulate cooling. It's a small engine and having a small radiator. So this engine is a vertical engine, easily mounted on the engine fits, and can be packaged very easily on a buggy. So that is the advantage of this engine to be used for the CNG application. And of course, you have to select a powertrain or the variable gearbox ratio or whatever the gearboxes you are going to use. That will come in the rule books, so you have to adhere to the rule books for matching your gearbox for this engine application. Can you go to next slide, Pamar? Yeah. Regarding other specification, water pump is a centrifugal type of water pump is being used. Thermostat is wax type, which starts opening at 72 degree and it gets fully open when water temperature reaches 80 degrees centigrade. Then engine oil, we are recommending 15W50 API grade oil. So this is our Greaves engine oil that can be used for this application, or similar grade oil can also be used for this engine application. Engine is with starter motor, having a flywheel mounting alternator for the charging system. Its low idle speed is 1200 RPM and its high idle speed is 4000 RPM. So considering both things, you have to decide your suspension so that it should not vibrate much or should not be disabled at a low idle RPM. These are the few internal specification wherein tappet setting is 0.15 millimeter is been recommended. So during running in and everything, if suppose engine performance or pickups goes down, then you have to set this tappet and move on. Then the coolant what we are recommending is in the ratio of 70 to 30 of ethylene glycol to water. So 70 will be a soft, 17 to 70% will be soft water and 30% will be ethylene glycol. So this is the broad recommendation for the oil water application for this engine. Aman, next slide, please. Yeah. Coming to the engine performance curve, I think already I spelled out. It's a 7.25 kilowatt engine. So these are the natural curve you can able to see. You have to see the torque, especially. It is a flat core torque, so that will give you an advantage for drivability at lower RPM. So that is the better part for this engine. Where in CNG you had a better torque, and we are anticipating some with HCNG the performance will be in similar manner. But at this stage, we don't have a performance with HCNG. So whatever the performance we are showing you, that is the CNG engine. So we are in the process of procuring HCNG and optimizing this engine for HCNG. And of course, after optimization, the performance will be definitely shared to you. But most probably, we are anticipating the torque curve and power and BSFC will be in similar line or something better than this. Next slide, please. This is the photo for this engine what has been going to be offered to you. It's a model photo actually. It's having a length of 330 millimeter, width of 358 millimeters, and height of 485 millimeter. Then a flywheel pulley to gearbox mounting around 300 mm is there. So that distance you have to maintain for your gearbox, especially point of view. And distance between feet is 266 mm. So your mounting AVM, anti-mounting vibration and everything has to be precise so that the engine stability should be maintained on the buggy. Go to next slide. Yeah. This is the engine nomenclature. So just I will explain you, means this engine is having lot of sensors, actuators, and you can see the photograph. So engine will come like this only. It is a total complete engine package with exhaust system. Only intake system is not there. That will come as a loose. So if you see to the engine nomenclature, engine is equipped with HT cable, injector, OMS, oil mill separators, then carburetor, spark plug is also mounted on the engine, ignition coil, starter motor, starter plate is also there, then flywheel, then oil pan at the bottom, then water pulley, pulsar coil is fixed on the engine. It cannot be seen from outside, but it's inside the engine. Then crankcase assembly is the body of this engine. then a water pump pulley, then catalytic converter assembly, cylinder head, oxygen sensors, oil level dipstick is also there where you can able to monitor the oil level, and oil filling cap on the rocker cover, that is a top plastic cap, and the rocker cover where you can able to service for your tappet application. So this is a pictorial view of this engine, what we are going to offer for your buggy application. Go to next slide. This is another view wherein the sensors of these engines were being shown. So engine is equipped with coolant temperature sensor, then T-map sensors, then CNG filters, ignition coil, oil pressure switch. So all the sensors, we'll go in detail. What is the role of the sensors and actuators can be explained to you in following slides. So in detail, these sensors will be mounted on the engine, and during mounting of this engine on your buggy, you have to take care of this sensors because these are usually plastic molded sensors, and delicacies should be there of braking and other things should be avoided when you are shifting this engine on the buggy. So an ample clearance should be there towards the sensor. At least 30 gap should be across. Overall clearance should be there from the sensors and the actuators for this engine application point of view. Go to next slide. These are again the slides related to sensors only. So oxygen sensors is also there on the exhaust manifold fitted. Pulsar coil already spelled out. These are the actually transparent view where FMEA will be there, where magnetic bobbins will be fixed in a stator. Detailed photo is also there in the next following slides. Then throttle position sensor is also there on say a carburetor, wherein it monitors the throttle position when you are accelerating your vehicle buggy or a three-wheeler application. So that accelerator cable is linked to this throttle position sensor. It will define the throttle position, and based on that, a whole map will be controlled for the lambda monitoring for the engine during running in of the vehicle. Please move forward. Yeah. These are the few sensors and actuators which are already mounted on the engine. First is T-map sensor. So T-map sensor is used to measure temperature and pressure at the intake manifold, and it governs what is the NTP conditions, what are the input pressure conditions, the temperature condition. Based on that, corrections will be there, and that corrections will be applied in our maps, calibration maps, and based on the corrections, the lambda will be maintained nearby to unity. Second is oxygen sensor that will monitor the oxygen level in the exhaust and give the input to the ECU. And that ECU will ensure that lambda or oxygen should be within unity or nearby to unity. Mostly when the vehicle runs on the road, the lambda value will range from 0.98 to 1.02. So range is very narrow. So we have to calibrate it in such a narrow band so that emission should give a better emissions and mileage. That is the main objective for this calibration point of view. Third is the ignition coil. It is also mounted on the engine. And sorry, this is a idle control valve. It is wrongly mentioned as ignition coil. Ignition coil is down. Right corner figure is idle control valve. It is fitted on the bracket, and mostly it helps to give more quantity of air during idling, and it makes the low idling stable more. So the oscillation effect it reduce and maintain the air fuel ratio properly to have a stable low idle RPM, and of course low idle emissions also. A bottom left photo is ignition coil. This is also mounted on a bracket on the engine. Objective is it's just a small transformer. It contains a low voltage to high voltage to provide high voltage to a spark plug. Then comes the injector. It is a CNG injector. It drives by the ECU to inject CNG into intake manifold. So injector is mounted on the manifold, not on the cylinder head. Then comes CNG filters. So the rail pressure, temperature sensor, working pressure 0.5 bar. So filter maintains this pressure of 0.5 to 0.5 bar to give to the rail pressures and temperatures. So this main part of the filter is two things. It maintains the pressure, it maintains the impurities of the CNGs also. Go to next slide. These are the carburetor to the left, where it is mentioned that throttle position sensor. So carburetor with throttle position sensor used to sense the throttle opening as well as demand by the driver. So that I have already explained to you. Then temperature sensor will monitor the coolant temperature, and that will give you the input to the ECU and for the corrections whenever it is needed. And the third photo is the ECU. So that ECU will come as a loose. You have to fit on your buggy in such a proper way that no thermal effect should happen on it, no vibration, no excess vibration should be there on this ECU. Go to next slide, Parma. This is a sectional view of the engine, wherein it will give detailed lubrication, how lubrication is happening in the engine application. So if you see to the photo, right photo, where section view is there. So engine you will be sucked from the oil pan through the suction bulb. Then it will go to the lubricating oil pump. Then it will go to spin-on filter. It will filter it. Then from filter it will go to the main bearing, camshaft. Then if suppose pressure is very high, pressure relief valve is also there. It will just release the pressure. Then mist lubrication will happen to the piston, lubrication arm, that is rocker levers. Then it followed by that will go to breather. So breather will separate it, where we had a separator OMS is fitted, where it will separate the steamed oil, say vapors of oil, and the cool oil will be drained again back to the oil pan, and the fumes will go out to the intake manifolds. So there are few parts like oil drain plug, then oil seals and vapors. Some photos are there, you can go through in detail. This presentation will be shared to the team, so that will help you when you are mounting this engine for the point of view, and where how to fill the oil and what should be the oil level and how the filtration happens. So you can able to understand from this figure. Go to next slide. This is the cooling engine cooling circuit. So this engine is a water cooled engine. So there is a water pump fitted on the engine. You can see serial number 2. So water will be pumped, cooled water will be pumped to from the say to the water pump, and it will to be circulated to the say engine, where hot water will go, and it will go to the radiator, and from the radiator it will get cooled down, and again cool water will be sucked to the pump. So type of a suction pump where cool water will come inside and hot water will go out because of heat dissipation of the engine. There is a degassing tank. The degassing tank and the pressure cap has to be somewhat at least 40 mm above the height of the engine. This has to be taken care when you are mounting on the buggy. That degassing tank and the pressure cap, you can see it has to be almost 40 mm above the top portion of this engine. That point has to be monitored. And of course fan, this is a remote mounted fan, so radiator, so it is having a remote mounted fan will be operated through electric circuit. That is current will be drawn from the battery, and battery will be charged through FMEA of the engine. So you can mount a radiator in any position, but you see that air drag should be there and serviceable. But other that cool line and hot line should be in such a manner that should not be too lengthy. Circulation of water should be proper in the circuit. That has to be ensured while packaging the water cooling circuit of this engine on your buggy. Of course, we are going to guide you during this practical workshops also, how it should be there. You can go next slide. This is the specification of a radiator, wherein we recommend 65,000 kilojoules per calorie radiator. It's a small radiator, and it will be provided to you by SM Auto. It can be purchased directly, or I think vehicle manufacturer can, or Atul Auto, who is going to support you for this, you can get from directly from there. It's a very small radiator, can be fitted easily on the buggy. I'm having certain photos of the buggy. In the last, you can just see. And this is one of the concept what students had used, but my recommendation is that use your innovations and ideas where you can able to place better for the radiator point of view. Go to next slide. These are some of the layouts what we had been using on three-wheeler application. So you can see that radiator has been remote mounted and it is fitted in parallel. So this is one of the application of the three-wheeler. So this is only to show you that how the radiator is mounted and how the top filling cap is above the engine. You can see it is almost 57 in our application, but minimum you can keep as a 40 and maximum you can keep to your comfort zone where you can able to fill the water in the tank easily and the water should circulate in the circuit. This should be the main important factor for packaging of this water circuitry on the engine and on your buggy. Go to the next slide. This is the other side of the view where thermostat is fitted on inside the engine adapter. You can able to see on the cylinder head side. So there is some thermostat. Then there will be nipple type of opening. From there you have to take an hose and connect it to the other side of the radiator. Then water pump is also there, and then coolant bypass hose is also there. So these hoses and these connections will come along with this engine fitted. In case if it is not fitted, it will come as a loose, but mostly this hoses we from the plant will fit it and give it to that, so the customer or the person who is assembling should not have a confused mind which hose will fit to where. So most of the hoses what has been there and shown in the photograph will be fitted on the engine. It will come as a complete kit for you. So only thing is that you have to match the PTO. We can see the PTO where the 6 studs were mounted on the crankshaft in between and thick 6 stud. So on the 6 stud, you have to mount on your gearbox. That is only required, and the mounting of this engine will be required on the buggy so that your AVM should be properly placed and the engine should be stable during running in. And of course, exhaust system will be a loose part, but I think for this Baja project, hBAJA project, we do. It is not recommended that you use this catalytic converter. Students are requested to design their own after treatment for this application point of view, so that it will be comfort for their packaging, and there are certain competitions of after treatments also. So you can use your own catalytic converter and demonstrate emissions and come in competition for this environment and other emission related. Go to next slide, Arnav. This is engine, this OMS, that is oil mist separators. You can see. Yeah. So yeah, actually it is something animated. So there is gas formation in the engine, the crankcase gas. From that gas, it will go to the rocker cover to the topmost position of the engine. From there, it will go. These gases with water vapor will be carried to the oil mist separator, where the heavier water vapor will drop down to the crankcase, and gas will be taken again into the intake manifold for the circulation. That will be a dry gas, but no oxygen will be there. Very less amount of oxygen, but it will be used for the, because as per norms and legislation, you have to have a closed breather system of the engine where you could not emit anything related to the vapors or from the gases from the crankcase and other things. And ventilation should be closed coupled ventilation for this engine. So this has been protected on the engine, but of course this is one of the pictorial photo. A team is requested to package this OMS in such a manner that the circuitry will be completely closed and oil separation should take place. Otherwise, if oil separation, if the mounting is being shifted from here and there, then there may be chances of positive pressure in the crankcase and the oil will be thrown by the engine. So most of the students will get confused why engine is throwing oil. Reason is that the oil mist separator is not placed properly. The lines are get blocked, and that is the reason you get a positive pressure in the crankcase and engine starts throwing oil from the breather. So that has to be taken care while packaging of this engine on your buggy. Go to next slide. Yeah. This is a FMEA charging system, that is a flywheel mounting armature. You can see the pictorial view of this engine. Earlier also I explained you. There is a bobbin coil, almost 18 bobbin coils fitted inside the flywheel, and stator, whatever the bobbins are there, that is a magneto in the flywheel. Because of the rotation of this magnet, there will be current, AC generation will be there, and that AC generation will be converted to DC with the help of this RR unit or regulator unit. You can see it is used to convert FMEA AC output to the DC voltage, and the current what you will get is almost 35 amps at 4000 rpm. But usually we won't recommend to run on 4000 rpm, so our rated rpm is say 3600 rpm. So there you will get around 33 amps current. That is more than sufficient for your buggy charge balance requirement. And of course, this charging system is being utilized for starting of this engine, plus battery charging, and for other applications what is being used on the vehicle or on your buggy side. So this has been protected, so need not worry for this charging system. And it will come along with this engine, RR unit, everything will come along with this engine. So nothing will come as a spare. Only some terminals you have to connect it with the wiring harness of the RR unit to the wiring harness of your FMA. Go to next slide, Palmer. This is related to exhaust system. I've already spelled out. There is oxygen sensor fitted on the exhaust manifold, then catalytic converter. So it will come as a loose, but this will be optional for your application. But to my knowledge and my experience, this catalytic converter students doesn't use. They will develop their own exhaust system to compete for that environment competition which has been done at hBAJA event. So it will be optional. If students want to use, they can use this. And if you want to explore your own design, you can explore your own design and demonstrate it. So this is only a layout, can be just to show you how this exhaust system is there packaged on this engine. Go to next slide. Yeah, this is an important features that student has to take care. Engine is having a water pump, and it is driven by the pulley on the flywheel, on the pulley casted on the flywheel of this engine. So this is it will come fitted on the engine, but sometime it will come as a loose also based on the requirement for the transit and logistic. So you can see it is a multi-groove pulley, and it is uh, it is mostly recommended pulley for the automobile application. So only thing is that alignment is very proper. Alignment has to be maintained properly, and tension has to be maintained properly. So we are recommending in hertz what should be the tension. There is a special gauge for it to mention this whatever the recommended hertz for this fitment and the tension to be maintained in it. It's around 150 hertz. So if any support is needed for these activities, Greece is going to support you, or we will recommend the tool what we are using. You can able to purchase it. Is not a big costly tool for that. So other thing, it has to be the coplanar of the flywheel to water pump pulley should be within 1.2 mm. That has to be maintained, and that has to be seen when you're mounting this engine whether it is coming properly or not. But since this is been supplied by Greece, we are ensuring it. But sometime you will remove the pump for your fitment of the engine on the pulley on the buggy. So there may be chances of misalignment or loose fitment. So you have to take care in case this happens. This is the only objective for showing this figure to you. Next slide. Then comes the CNG fuel injection layout. So for the HCNG application, only hydrogen cylinder will be used. So I think this what we are using is CNG cylinder. For hydrogen, it may be carbon fiber cylinder, or it may be similar cylinder, bit compatible for HCNG, because HCNG pressures will be slightly higher than CNG. What we are using is almost 180 to 200 bar or 190 bar. So it may, and we are anticipating that HCNG will come with around within 250 to 300 bars, what we are discussing. So based on that, the cylinder suitability will be given to you in the rule book, and same you have to use it. So this is the generic layout of what is being used on the vehicle. So similar layout you have to use on your buggy. So the layout says that CNG tank, from CNG tank to CNG tank valve assembly is there. It is fitted on the tank. It is having a special tool where Atul Auto team will support you or Advantech team will support you how to tighten this valve. It is a very special tool. You have to be very careful for tightening this and ensure there should not be any leakage. From this tank, it will go to high pressure line. From high pressure line, it will go to the CNG regulator, where this almost 200 bar pressure will come down to 2 bar. From 2 bar, it will go to atmospheric pressure. Okay, from that CNG regulation, it will go to the low pressure line, where it will be around less than 2 bar pressure. Then comes to CNG filter to filter out impurities from the CNG. Then it will go to the injector, which is fitted on the intake manifold. So this is the simple circuit, and it can be placed very well on the buggy. It has been demonstrated, and you can do in a better fashion what has been explained to you now. Go to next slide. These are the pictorial view of three-wheeler application. How you can just see how it has been fitted. Cylinder is fitted just bottom to the seat, rear seat. From there, high pressure pipeline is going to the regulator bottom, and from regulator it will go to the low pressure pipe to the injector. So fitment is very simple. You can see how ECU has been placed properly with bolt and brackets. So in similar way, you can able to fit it on your buggy application. Objective showing this photo is that you have to see the fitment, especially for the cylinder, how this brackets has been fitted and tightened to the say body of this vehicle. So that it should not have a lateral or longitudinal movement, and it should not be free. So that during running in and during endurance, it should not fall down during running in. So it has to be properly bracketed and fitted on the your buggy application. And you can see the wiring harness couplers also to the ECU. It is a properly well designed wiring harness couplers, and it will be available to you by Advantech or by Atul Auto, is going to support you. Greece is not going to supply you wiring harness because we are the engine manufacturers. We supply engines to OEMs, and OEMs develop their own wiring harness. So whatever the wiring harness three-wheeler application is being used, you can use it for that application. Or if suppose certain modifications are there, you can able to talk to the wiring harness guy. They can able to modify for your requirement. But as far as the three-wheeler wiring harness, it is more suitable for your buggy application. Please move ahead. Next slide. I'm gonna go to next slide. Yeah. So this is general layout. You cannot able to read it. Sorry. Go back. Layout of wiring harness. Go back. Yes. Hold on. Yeah. So this is a wiring harness. This is a general terminal diagram. So this will be provided to you for your study purpose. It is not readable here, but I have to show you. This will give you the recommendation of pins and couplers, what is to be fitted where, and which pin is going to which sensor or actuator, and how it is being linked to the wiring harness. So based on this terminal diagram, wiring harness has been made for the vehicle application. So it will help you for your understanding. And if in case you are getting a wiring harness, and it can be applicable directly fitted on your buggy. So this wiring harness TD diagram will be just for your information. But my recommendation, you please study this. It will be helpful for your understanding how this total circuit works, electronic circuit works from sensor to the wheel of the vehicle. Go next slide, Palmer. Yeah. Now this engine is a bifuel application, bifuel engine, wherein CNG is you have to inject CNG through injection system, and gasoline engine will be a carburation system. Mostly this application is for three-wheeler. So bifuel is being used by three-wheeler, and gasoline application is used only for lymphome application option. Say if suppose CNG filling pumps are not there or not nearby. So driver will fill this 3-liter tank to gasoline and reach to that station, and again continue his journey after filling in CNG in CNG mode. So it's a simple circuit, very simple circuit. Carburetor there is having a nipple. That nipple has to be connected through the pump of through the hose to the feed pump, and that feed pump is connected to the filter, petrol filter. and filter will be connected to the tank. It's a very simple circuit, and you can able to package in a similar way. And in case for the demonstration, if it is not required as per rule book, you can omit this circuit and you can only use engine on CNG mode. Go to next slide. This is a gasoline fuel layout system on a three-wheeler application. You can see the tank is mounted on the long member. From there, it will go to the filter to the feed pump. Then it is going to be connected to the carburetor. So similar fashion, you can have, instead of 3-liter tank, you can have half a liter tank or 1-liter tank. That will help you for easy starting and see the feel of the engine. If suppose in case CNG gas is not available or HCNG is not available at that time. Go to next slide. Now air filter layout, just for your information, air filter will be coming as a loose. It will not be fitted on the engine, and the rubber hose which is connecting to the air filter intake exhaust has to be developed by the team. Or you can able to procure it from the market, or you have to develop it based on your routing. So you can see this air filter is fitted on the long member of the buggy side, and the rubber hose is connected to the carburetor. So their recommendation comes in a similar way what I have shown you to the right side of this slide. It has to be horizontally fitted, and hose should not be having a 90 degree bend, so that no obstruction of airflow to the carburetor. Otherwise, it will hamper the performance of the engine. So please ensure that the orientation of the rubber hose should not have a 90 degree bend. It should have at least 120 to 100 degrees, so that smooth laminar flow can take place to the intake, and the mixation of the carburation, if you are using gasoline, can have a proper way. So this is the main recommendation from our side. It has to be fitted horizontally. Go to next slide. This will be in our scope. Yeah, I think this is a repetitive slide.
Hello.
It is repetitive. Yeah.
Kalimuddin sir, we
Yeah.
can like if any slides are remaining, we can wind it up in 5 minutes or something, and then we can have Q&A. Is that okay?
Yeah, is it okay? Yeah, this is the repetitive slide. Can you go to
Okay.
next? You just go to the buggy slides. I want to show that. Move it. Move on. This is already shown. I think same. It has not been.
I think so. Rhythm, you can go to the second last slide.
Yeah, you can move it. These are packaging photos. Move on.
Yeah.
Very important. I will show you. These are the tools.
Right over here.
Yeah, Ruturaj, I think these are the tools where we can able to show. Then we are going to provide these tools also. I think our SAEINDIA team is having these tools. So whenever the buggy, these photos, just I want to show to the team that how this packaging been done on the buggy. How you can just note how the this radiator has been fitted, how this surge tank has been fitted, how air filter has been packaged. These are the first buggies where what has been demonstrated previous year. So this year you are having a big opportunity to improve the design and having a proper packaging of engine of the buggy. I think Ruturaj, you can move on. I think one more slide is there. That's all.
Rhythm, go back to the second last slide. Yeah. So this slide you want to show, sir?
Yeah, that's okay. That's all okay. This actually just to show that team how their team has been packaging and other things. So thank you. I think this is the only presentation we had from our to show the engine details, how this engine will be there, so that students should know and generate their ideas for the packaging of their buggy and come in competition with a proper robust design. Yeah, thank you, team. Any questions?
Yes. So where we can start with the questions.
So one question is coming: does the engine comes with a cooling system which includes radiator, fan, reservoir? Uh, Greaves will give you engine. This I think Saurav can able to comment on it. Radiator and this the other things we are directly purchasing, or it is coming through Atul Auto. Saurav or anybody from your team, you can able to comment. We are not providing. Greaves is not providing that. We are providing engine, exhaust system, and intake system. Radiator and other the search tank, everything will come from Atul Auto maybe.
Okay. So there was a question, sir. What are the challenges in optimizing air-fuel ratio for HCNG engines? We wanted like this question was redirected to your session.
Yeah. Actually, the challenges will definitely will be there because flame velocities are different, equivalence ratios are different. So we have to retard this engine. We have to play with ignition timing. Then we have to go with the different energy level for ignition coil. We have to go with the cooler spark plug. Then, of course, calibration will be needed, and we have to optimize the lambda within Unity. And exhaust temperature has to be monitored because it is again a leaner fuel. So, what will be the effect on the exhaust temperature of the engine? That also we have to see. But we don't have much worry because it's a water cooled engine. So, and being a cast iron engine for the cylinder head and barrel, so high temperature doesn't matter for cast iron. But of course, challenges will be there to optimize this engine for the linear application point of view, and we will play with ignition timing. Definitely compression ratio will not touch it because compression ratios are already on the higher side for this engine. Then we'll play with the energy level, duration of injection, and then we'll play with the temperature inputs. So these will be the challenge, and we are pretty confident we can able to demonstrate it.
Sir, next up we have one question. This is also a redirected question. What impact does HCNG have on engine's thermal efficiency?
It will be better. It will be better than CNG.
Okay. And with respect to traditional gasoline or diesel engines?
Yeah. CNG will have the go. If you see the point now, CNG will have better thermal efficiency as compared to gasoline and diesel. And HCNG, we are anticipating it should be better than
Okay, CNG.
CNG.
Okay. Then we have Rajesh sir. He's asking, will it be good to develop monofuel HCNG rather than bifuel HCNG and petrol fueled vehicle?
You're talking about buggy, or it is related to application? Because we in the application, just to emphasize you, one of our application is using as a monofuel application. But the disadvantage is there in case if CNG is not available, then you don't have any option. Only thing is that you have to fill or you have to tow this vehicle to the CNG pump and fill it and go. Biofuel is having a advantage out of it. If suppose CNG get empty, you can use gasoline to go to the station, fill it, and then move on.
Okay.
But buggy, I don't know. I think we
Next,
have to go
yes.
as per the rule book. Yeah, for buggy, we have to go. You have to follow the rule books. What has been recommended.
Okay. Next we have sir. As you have mentioned, the modification is needed. So what are those? And does the returning team who have purchased the engine previous year have to send their engines to Greaves facility?
No. As such, hardware modification will not be there as such. We are anticipating change in calibrations and change in maybe the energy of HT coil
Max.
and some recommendation of spark plug, cooler spark plug. That 3 points will be main focus. But as such, there will not be change in any hardware like piston combustion bowl or cylinder head change. There will not be such modification on the engine for this application point of view.
Okay. Then we have, how does the switching between HCNG and gasoline work? Can we implement an automated system?
Yeah, that is the automated system. I think in next session in Atul Auto Piyush will going to explain. There is a changeover switch wherein you can able to easily change over from the gasoline to CNG and CNG to gasoline. So it is already developed and you can able to carry forward that on directly on your buggy.
Okay. Then we have to provide. Okay, we can take this question later. Okay. That was all. Okay. Thank you, Dr. Sayed. Thank
Yeah.
you for your time. It was a truly insightful session on HCNG engines.
Yeah.
Next up, we have
Thank
a
you. Thank
session
you.
on yes, Dr. Sayed.
Okay then.
Yes. Next up, we have a session on HCNG injection kit components and integration, which is led by Mr. Rajiv Gaiki from Advantech Fuel Systems. Rajiv Gaiki is a distinguished expert with 16 years of experience in design, development, and calibration of gasoline engines, with a particular focus on gaseous fuel engines, including NG, LNG, and HCNG. His contributions span automotive, non-automotive, and power generation sectors, notably leading the development of India's first commercial LNG vehicle, which was inaugurated by Mr. Nitin Gadkari. So this session will cover the key components and integration processes for HCNG injection kits. So Mr. Gaiki, I would like you to take the charge now.
Hello. Is it audible to all?
Yes, sir, we can hear you.
Yeah. Good afternoon, all of you. Special thanks to Mr. Ora, Saurabh Suman, the consulate, and all my committee members. And special
Excuse me,
thanks.
sir. Can you switch on your video?
Okay, just a second. Is it visible now?
Yes, sir.
Yes, sir, we can see you.
Okay. So, good afternoon, all of you. Special thanks to Mr. Dr. Ora, Saurabh, and all the participants are those are participating in this presentation, understanding, and introductory part. And before starting this my presentation, I would like to thankful to Kamaluddin sir, who already taken care of my part also. So they already discuss and detailedly discuss with you on engine parts, sensors, actuators, and other peripheral parts. I'm just focusing on most probably the bridge of this hBAJA project. So my part is the bridge. The engine, one side is the engine and another side is your fuel. So I'm contributing in this fuel system with specialized controlled pressure system with for proper combustion. Yeah, for proper combustions. So can we start? This is the presentation already on your screen. Can you go further? Next. Yeah, this part is already shared. Means already explained by Kamaluddin sir. And this engine we are using GL400 water cooled engine. These are the just general criteria and part. All are the parts over there. So this is I don't have to explain more because once you physically seen the engine, it will be self elaborating engine. Next one. These pictures are last yearly taken with once this CNG system is going to introduce in a hBAJA contest. So next. No, next. Next. Yeah, this is a general layout of a system which is already explained by Kamaluddin sir, but I am just giving the simplest explanation. These are the gas cylinder which consist having a 200 pressure of a CNG. Similar to in this application, it will be a similar pressure 2 to 10 bar with HCNG, 18% a blend of hydrogen, and it's after this cylinder there is a valve. It's called on-off valve, and along with the first stage reduction of a pressure reduction. Second is a regulator. Regulator is a part who put intake to 200 means around 20 bar pressure inlet side, and output will be a 2 to 3 bar to the injector. This from regulator to injector will be injector will be a pick and hold type, which is give which is provide the gas to the injection system through the injection system to the combustion chamber according to pulse rate of your ignition coil as well as your exactly position of a piston. Other one is ECM. ECM is a completely program with the all combustion cycle as well as torque, power torque, and emission mappings. Next. Yeah, this is a general layout of a closed loop system. What is meant by closed loop system? The system who is giving a feedback to the system, means it is not openly. The final output comes from the lambda system. Lambda means O2 sensor, and it gives the output to the ECM, and ECM ECM gives the signals to the all sensors according to whatever the air fuel ratio is mapping. So ECM is an electronics control unit. TPS, the sensors are all includes. ECM is the main brain of an engine. The other thing is the TPS, throttle position sensor, which is mounted on a throttle body. TMAP is a temperature pressure sensor of air. It is mounted on a intake system. Fuel rail temperature system, it is giving exactly pressure and temperature of a fuel, and it's within a certain limits. If it is some pressure or temperature is changed, it will give the indication to the ECU, and that ECM gives the indication to the vehicle cluster. It is a engine coolant temperature sensor, which is provide you the exact data of coolant temperature inside the engine, where it is whether it is capable. This cooling system is capable. How much is capable? Whether it is a hotter side or a leaner side, a cooler side. It gives the exact temperature of a coolant side. Now the O2 sensor. O2 sensor is a vital role of a main vein of this system. O2 sensor gives a feedback of from exhaust system, and it's generate or regulate the lambda system. Lambda system in the sense air fuel ratio, which is controlled by ECM. It gives if the engine is going in a richer side, it gives the direction to the ECM. It gives the direction of ECM. It is going further richer side. So ECM gives signal to the other sensors to control the air fuel ratio and make it on a lambda is equal to 1 ratio. CKB sensor is mounted on a flywheel, and it gives the exactly pulse where we need to ignite the system, and it is on it gives most probably in a advanced side, and and gives the signal to the ECM. Vehicle speed sensor and clutch switch are not implemented
for exactly this event because it is not incorporated with that. The actuator or ignition coil, which is gives a spark to the which is generating spark to the spark plug. Gas solenoid is a automatically on off valve, which is it's called a plunger type or ball type, and it's allow a gas to system from the cylinder. CNG injector is a actuator. The main it is injecting according to pulse rate of your injection as well as whatever it is work on the CKP position sensor. PDM wall it's working for the biofuel where the petrol and CNG means biofuel uses when the CNG is there is no CNG or when you want to stop the CNG and run it on a petrol, then this PWM valve will be introduced, and starter solenoid it gives a safety system to the starter. If you are cranking 2 or 3 times, then it will be a take some break to prevent starter get burned. Next one. Yeah. This is a closed loop block diagram, which is the name of brain ECM. The name is A47 Advantage 47 series, and number of pins means number of controlled pins are 48. Electronic control unit or controls a series of actuator sensors on an engine to ensure optimum performance. Does it read by the it having some values some values which is described in software format, and these values gives a appropriate signal to the and synchronize with each other and gives the output to the and to the calibration maps, and it will work properly for the to get a good combustion. This is a if you deaccelerate your pedal, then fuel should not be supplied to the system. So there is a one function deacceleration fuel cutoff. It is work on braking side, deacceleration side, clutch operation, and when you not required the fueling to the engine. So this one will be to the ECM side. Next one. Next slide, please. Yeah, this is a TMAP sensor. TMAP means exactly it is a gives the exactly barometric temperature and pressure, atmospheric pressure, and what is the difference between the barometric and inside the manifold pressure. It gives the deviation between that, and it works on voltage based the 5 volt system. It reads the temperature as well as the pressure, and it allows on a TPS means incorporate with total position sensor. And mostly it is mounted on intake system, and it should be free from the leakage and hazardous. If this sensor get corrupted or get wrong feedback, then your system will be completely collapsed. Maybe it will be not take a power ups and down, or it will be some uncontrollable combustion takes place in the engine. Next one. General engine closed loop system diagram is the next thing. oxygen sensor. Actually, our feedback system for this gasoline or yeah, for the gasoline or NG based engine, the main vital role of this oxygen sensor. Oxygen sensor is gives the exactly combustion parameters or exhaust combustions reads from the percentage of oxygen available in exhaust, and it gives the input to the ECM, and ECM gives the signal to the other sensors to control whether it is a linear side or richer side. In the HCNG, we are completely dependent upon this oxygen sensor to get uh, from lambda 1 to 1.2 lambda, we have where we exactly locate our combustion. So it will be a richer side, linear side. So lambda will be a 1.2, uh, 1.2, around 1.2. So this lambda sensor will be playing a very vital role in the system. Without this lambda system, our system will be completely collapsed. Now next, engine coolant temperature sensor. Coolant, no, sorry, just a minute, same slide. Yeah, engine coolant temperature sensor. It's measure the exactly temperature of a coolant inside the which is running inside the combustion around the combustion chamber, which is run from ambient to runs from ambient to um, hotter side or boiling side. It is a trip on 105 degrees centigrade, and it started blinking and degrade the torque. And once it reaches to 110 degree, engine completely gets shut off. This is a safety point of view, and one of the safety sensor also. Next. Yeah, yeah, it's okay. Yeah, CNG ignition coil. CNG ignition coil is why is a CNG ignition coil? Because CNG fuel is a dry fuel, and it's need uh, it's already having a ignition ignition point. Ignition point is almost 550 degrees centigrade. So it is required high flame. It's required a high flame. So my spark should be a high flammability water type. For this reason, we developed the ignition coil especially for the CNG. It is a hotter type, and it is already works on a 12 volt system, and it gives you a better combustion and a better flame and better combustion. And it's passed through from this ignition coil to spark plug. It's through the ST cable, high tension lead coils cables. Please do not use any other ignition coils which is available in a market like motorcycles or three-wheelers, because these coils are not capable to capable capable to work on the CNG system or HCNG system. Next one. No, this is the ECM, which is I am already told you. This is the brain of our system. It is all sensors and actuator controlled by this particularly program system, and we calibrate this this ECM through the on vehicle as well as on test bed on a running engine condition. So it is already ready to ready to fitment, ready to work, for whether it is CNG, whether it is SCNG. For SCNG things, we need to calibrate some tables like air path controls, little bit lower end torque, as well as ignition timing, whether we need more advanced for this HCNG type, because it's get more linear side. That's why we and control the knocking point. It having indications also for fueling, overheating, and engine malfunctionings, as well as check engine blade for the more to not get a hazardous condition. And safety sites. The technical specification is operating point is very good, from -40 to 110, 100, almost 110 degrees centigrade. For any season, it will be over. Storage temperature also same good, and working temperature, working voltage is from 8 volt, 8 volt to 14 to 16 voltage, and it is a very lightweight, like your mobile, like your smartphone mobile, and it can be communicated through the CAN system as well as K-line systems, which is I give you once in practical. Once we are in a practical mode, I will share you on these are the different CAN and K-line are the different diagnosis software. I can show you what exactly this CAN system will be about. Next one. This is a CNG layout from 200 bar to 2 bar. It is actual pressure reduced from cylinder to injector from 200 bar to 2 bar. It having a cylinder walls, high pressure line. These high pressure lines we have to change. We have to modify it from current mild steel pipeline to the stainless steel line for most robust and leak-proof things. We have to change with the strike lock system. The regulator regulate the pressure from 200 bar to 2 bar, and it is gives to the pass through low pressure hoses from filter. Filter will be nullify the all um, uh, impurities from the gas means CNG or HCNG, LNG. It will then nullify the all, and purest form of a gas supplied to the injector, and injector gives to the combustion chamber. Similar to the LPG system, both system are very common. Only the pressure difference is there. Next. Yeah, it is easy to understand. The main components are first of all, which is already explained in our last slide. The CNG cylinder, tank wall, filling nozzle, pressure gauge, micro switch. Micro switch is a safety device. Once you when you are going to at a time of a filling, once your filling nozzle is open, the micro switch in a micro switch giving a signal to the ECM to do not crank this engine while filling of a cylinder. This is a safety point according to AIS 028, and all participants should take care of this regulatory AS 028, because this is a Bible or any Bible for this CNG and SCNG system. Why SCNG I'm taking about? Because 18% of a CNG cannot harm for our CNG current CNG system. So all regulatory of a CNG system is equal to HCNG system. Now next, high pressure line, high pressure regulator. These are the common parts, which is already I explained with you.
These are the you can consider as a BOM, bill of material, which is you have to purchase from Advantage Fuel System. Next, these are the BOM system, which is how much part is required per vehicle, per engine, and part numbers and its nomenclature are already shared with you. So our committee and alumni committee will provide this BOM to you, to all participants, and you can directly buy from us and connect with me. I will make sure for the supply. Next one. Yeah, see, this is a steel cylinder. It is a steel type 1 type of cylinder, and already in our earlier presentation from the Makaran sir and after Mr. Ashish, I think so. They already shared you the type of a cylinder. So this is a type 1 cylinder. It's a steel cylinder, which is generally used in a general means current automotive sectors like all commercial vehicle, passenger as well as commercial vehicles. So these are it's a range from one sorry 2 liter water capacity to 180 liter water capacity. It is having a very different range. The Rama cylinder, Everest Canto, EKC, these are the main leader, market leader for the supplying of a steel cylinder. Next one. This is the pressure gauge along with the filling wall. It will be just give you the exactly sense tank pressure inside of your gas. It gives the exactly analog condition. It is an analog monitoring system. Same system we are providing the electronic system also, which is indicated through the lamps, and it gives a indication in the through the cluster at a inside of a cabin to the driver. Next one. It is the simplest. What is exactly type wall doing? So in a physical workshop, I will share you. I will give you the exact details of details of these tanks and what is the safety points and how to install and how to install it. I excuse. Hello. I'm just giving. I just want to take a 1 minute. Just my laptop is in a little bit battery is lower. I just put it on a plug. Just to wait for the few moments. Sorry for the interruption. Yeah, we can continue. So CNG cylinder tank wall already explained to you, and more elaboration on the physical workshop, which will use the exactly practical demonstration. Next one. These are the instructions. I really gave it on a practical base rather than reading and explaining. Will be just jump out from your understanding.
So it is the complete slide exactly explaining on how much torque is required, what is standard over there, and how to that, what is the direction of a tightening, and what is the identification codes and dates, what is the where, what is the exactly understand. Next one. Yeah, I already explained what is the use of a micro switch is a safety valve while filling of a gas in a cylinder. While the filling of a gas in a cylinder, my electronic system or engine should not be a crack. For preventing this, this micro switch safety switch is adopted, and it is as per the AS28. Uh, yeah, next one. These are the component locations already uh, explained by Kamil sir on the vehicle, and these are the actual photograph of three-wheeler vehicle. There are the on the for this Baha contest. There are already pictures available with the committee member how it will be on this mounted on a buggy. So once you gone through this buggy from your side, it will be a clear picture here, completely clear picture to all. And most probably the last year participant like Amigo, Orsa Motor, and this from Aurangabad.
Hello, sir.
For year, I think so. They will also
Sorry to intervene, sir, but your audio is not clear.
explanation on that. Next one.
Hello.
Yeah, these are the functions. How pressure is analog system pressure is how it works. The spring based filled with the glycerin and dial gauge use an electronic signal to the system, and it will be reflected on uh, your clustering in your cabin. You know, how it will be detected, whether the full tank, how it will be indicated to the uh, lower fuel side, and it is what sensor. It is a sensor based working from one 1 volt to 5. 1 volt is equal to gas zero pressure, and 5 volt is equal to 200 bar pressure uh, inside the cylinder, and it will be read and will be give the signal to the HCM, and HCM give the signal indication. Next, this is the regulator. This is a what we can say a pumper. Will reduce from it will reduce line pressure and gas pressure from 200 bar to 10 bar, and it is having it's closely to flow with 10 gram per second, and it having a different condition for the corrosive resistance. Vibration is not more than that. Endurance means solenoid endurance. This solenoid wall, how much endurance, how much cycle is there. It's already very well proven, and it is already approved from R110 ISO 15500 as well as AIS 028.
and outlet pressure will be 2 to 2, I may say 2 bar to 5 bar, and it will be adjusted to the Allen screw, which is not allowed to anyone, but it can be adjusted. Next one. These are the child parts, which is the mounting, filter, inlet and outlet positions, as well as shut off solenoid. Next. Which is I already explained you. This is the function of a CNG regulator. Will be a regulator pressure, and except from high pressure line to the lower pressure. It is regulate and it is the transfer from the high pressure to the low pressure at a further injection site. It having a single stage and second stage depend upon the number of stages and number of what is the pressure of what is the tank pressure of tank pressure and line pressure. And if the main stream flow, inline flow, regulate same direction. If it is set on a 2 bar, it will never change from a 2 bar to 5 bar or 1.5 bar. We use the regulator pressure, which is you set once it's set it. Next one. Next. This is a solenoid valve, which is I already told for safety purpose and stop or
Hello,
stop.
excuse me, sir. Your
Yes,
voice, it's breaking again.
already mounted on a
Hello,
CNG regulator.
hello, audible?
It is a self-explanatory. Don't have to give you more explain on that. I will give completely. I will open this. I will come along with a child part of this solenoid and give you a perfect function of this solenoid. Even I will come along with the all parts which I am giving to me, presenting to you, along with the all inside of a structure and as well as child parts. So you will understood that what is the exactly function of this and how it will be working. Next one. This is a low pressure side filter. Generally, what will be happen? The CNG filling station, there are the compressor which is a compress the gas of a lime gas, and it will be stored in a high pressure cylinder. At the time of a compressing gas, there is a compressor having some outlet, some liquid particle, and it will be submerged in a cylinder tank, and it is passed through your vehicle. Once it is passed through vehicle cylinder, Hello. Okay, sorry. Right now it is unclear. Hello. Is it now? It is okay. Hello.
Yes, yes, sir. We can hear you clearly now.
Yeah. Okay. Thank you. Sorry. My voice was a little bit interruptive. So I just a call from your committee member. Now I think it is okay to you. Yeah. should I start from this slide or go back to the other slides?
No, sir. It is okay if you continue.
Okay, okay. Because my slides are very self-explanatory. Just I'm just giving you this low pressure filter removes the dust particle as well as oil particles from the line pressure of your CNG line, and it gives a more durability to the injector because uh, there is no dust or oil pass through this to the injector. Injector life will be more than it will be a generalized. We are warranted our injector system around 5,000 kilometers, 5 to 10,000 kilometers without any reason. So it having already having a pressure sensor also, means pure well pressure sensor also. It gives exactly pressure and pressure as well as temperature of a fuel, means gas fuel. Next one. Yeah, this is the filter assembly with fuel and temperature sensor, which is look like a same, which is in a picture. Hardly it having a see the filter, the cartridge of a filter is a paper type filter, and it's very easy to replace with another cartridge. Not a very big deal with anyone. Anyone means any layman can replace this filter, and it is very easy to mounting and after service very easy to operate. Next one. This is a steel tube, which is I told you high pressure line. Right now we are providing this high pressure hose or high pressure steel tube lines, which is made of mild steel. But for this HCNG application, we are replacing these lines with the stainless steel line, which is zero tolerance leak proof as well as very good what we can say robust packaging. It will be not easy to move or it is easy to bend. That steel tube pipes require the special tools for the bending. So we will, at a time of a physical workshop, I will come along with the steel tube lines, high pressure line. I will give you a demonstration how it will be bent and how it's precisely met with each other, and how it is leak proof. Next one. These are the mounting clamps, which is you are incorporate with your buggy vehicle. So this picture will not be exactly gives you idea how it will be. Only the according to AS 028, we have to mounting like this high pressure lines. We have to mounting like that. Next one. These are the regulatories where you can yes or no and all regulations. What exactly prevention you have to take care. So it is already very. First of all, while you mounting a high pressure line, the area will be a dust free and very clean area, as well as the person who is mounting or mounting these lines, their hand gloves and hands should be a neat and clean, because the single dirt particle, if it is entered in this
high pressure line, it directly passing to your low pressure filter, as well as there is a possibility of it's go pass through injector also. There are the protective cap screws as well as ferrule nut. Ferrule nut is it's like a sealant. If the sealant is the ferrule nut is not properly tightening or properly fitted, then there is a huge chance of a leakage of a gas. Even at the time of installation, if you are cutting off some steel tube for the your certain certain for the certain length and other things, while you cutting, you have to cut with the with special tools like pipe cutters. You don't have to use this hacksaw blade and other things. If you are doing this, there is a possibility of burrs and other particles will be entered in a steel tube, and it will be problematic for your next operation. These are the main conditions which is we have to be prevent and taken care while installation of a high pressure hose and high pressure line. Next one. Here you can see the Swaglax soap solution. This is a different liquid rather than the general soap solution we are using, because we are using HCNG right now. For the CNG, the general soap solution will be capable to understand, but we are using this HCNG system right now. So we have to incorporate with this Spyglock Snoop solution, which is a different liquid, which is provided by this steel tube provider. So everyone has to be taken care of this. Every team has to buy this Snoop solution, which is that we will provide you. It will be almost once you are while you are checking the leak test, it will be gives a better idea. While it is a minor leakage also there, it will be change with the color. That's the solution will be change the color. Next one. These things I will explain you on a physical workshop, because you don't understood what exactly what is this stainless steel type. This is the special tool while we fitment this cylinder wall to the tank. But most probably you guys will be come along with the tank and wall with the fitment in the fitment form. So it will be not that much headache for you. If there the possibility, then we will explain you in a proper way. Don't worry about that. Next one. Yeah, here the main point: compressed natural gas consists methane more than 95%, and here the HCNG, it will having contain methane as well as hydrogen. So this major point is related to CNG. We have to be taken care of this, and next in the next presentation or workshop, I will use what is the exactly trouble course while you are working on an engine, or while you are in a testing. There are the indications, some of the indications, which is you gives the idea what is the exactly trouble code, what is the problem or what is the trouble come generated by engine. So it is very easy to understand with the practical, and I must say the each and every participant or team member or some of the team member has to taken care of only the diagnosis part. Means he will be that person will be a specialized for the diagnosis part. Next one. Yeah, these are the basic practices, basic safety practices, which is really explained, completely explained on AI 028. Please download it from the websites or from the Google, or you just Google it and download it. It will whatever the instruction given to here, it is directly taken from uh, that document only. Next one. Thank you. Yes, please ask me a question if you have any. Uh, Let me clear your doubt.
Am I audible?
Yeah, yeah.
Yes. So we do have questions.
Yeah.
Firstly, in the Baha buggy, the engine and the fuel system both are at the rear end, right? So, how do we take care of our electronics components like ECU and sensors from engine temperature?
See, what last year I seen this Baha buggies. Okay. So you are asking about the temperature and shock probes. So it is already in a the temperature will it is already in a air, open to the atmosphere. So already ECM is a capable, and ECM as well as other system is capable to take care of all Indian Indian culture, temperature, and dust and everything. So you don't have a worry about that.
Okay, then we have how does the fuel switching work exactly? Can we
Sir,
design and implement our own design for switching between fuels?
uh, but why you need this fuel switching of a fuel? I know, I understood that. I understood. Once you get a CNG one, once you get in a HCNG, okay, so you don't have to switch on petrol. But while you're practicing, you just work on you just start on the petrol only, and it having a selector switch with the wiring harness, it is already incorporated with the selection switch. You can easily toggle the switch and you utilize whatever the fuel you want to do, whether it is a petrol, whether it is CNG or HCNG. Don't don't worry about that. It is already calibrated and already it is in the market. So you need not to worry on that in that case.
Okay, thank you, sir. Then we have please explain the pressure regulator working as well as can the outlet flow rate be adjusted? Thank you.
Yeah, yeah, it will be adjusted. It will be adjusted. See, what is the exactly function of a pressure regulator? To regulate the pressure. Regulate the pressure means that it will be a streamline, whatever the pressure you are maintaining over there. Whether it is you are setting on a 2 bar, whether you are setting on a 5 bar, whether you are setting on a 1.5 bar. Whatever the you adjusting the you are exactly top of a pressure, which is the 2 bar, 5 bar, whatever it is. It will be a regulate on a same flow and same pressure in the entire time. Entire means every time. It will not never be varied because your time pressure it is almost from 200 bar to 50 bar. After the 50 bar, you have to refill your tank. Uh, but will be steady once you are settled. You need not to be touch this setting screw also because we will adjust it uh, and share with you or supply to you.
Okay. Thank you. Thank you so much, Rajiv sir. I'm sure teams will be having, sorry, I'm sure teams will be having so many much more doubts, which they will be getting cleared in the physical workshop. When is it?
Yeah,
When it
yeah.
will
And
happen?
mostly the maximum presence of a team or the physical workshop, it will the clear cut clear cut clearance of each and every doubts. Last time, Saurav already know that how the how this team build up activities came and how all the question marks completely disappeared and how they um, independently and confidently they work on this buggy vehicles. Because last time was the first time. This time also the first time for the HCN. We have the one step ahead.
Also, sir, there was one question more. Returning teams have to purchase new ECU or the existing one can be modified.
Existing one can be modified. Don't worry, that I will do. Don't take it. I know that.
Okay.
I expecting this question from last year, guys.
Yes. One more thing, sir. I have one query myself.
Okay.
What is the list exactly? What things are exactly needed add on from the last year?
Till time there is a nothing
Okay.
from our side.
Okay.
Advantage fuel system till date there is a nothing to be to change. But I told you only the high pressure line I need to be changed because earlier was the mild steel tube which is a flexible one. But due to the this introducing this hydrogen fuel in this system, I may I must more care about the hydrogen, so do not leak or anything. So I will just put a steel tube over there, which is made of our swag rope, which is a American best company, and this is one of the best company in the world for the high pressure lines and gas unit system for all natural gas and other gas system.
Okay. Do we guys have any more questions?
These guys having a more question, but they are not asking me.
They will have some questions, but I don't think they are
Don't worry.
like more
Next time,
relating to
next time
this
I will come
format.
along with the question also and answer also.
Yes.
There will be a click on that whatever the things behind running on.
So, anyways, thank you, Rajiv sir. Your presentation, it was a quite in-depth one on injection kits. Also, it was a very detailed one. You tried to
Please
include
write to me
every.
directly if you have any question. Please
Fine.
write to me directly also. Do not wait for the next this participation and other things and workshops and other. Those having any problem, just write to me directly or just put it on my LinkedIn profile also. Just subscribe me and put it on that question on LinkedIn also. I will clear the things. Not an issue.
Yes, sir. Sir,
All
one
doors
more
are
thing.
open from my side.
One more thing. If you have your LinkedIn profile link, if you can share it in the chat box, it would be helpful for the teams so they can easily
Not
find
an
you and
issue.
connect you there.
Just just search with my same name, which is
Okay. Okay.
Rajiv
Okay. Okay.
Galti. It will be all
Sure.
same. More subscribes means more questions, more answers, and more clarity. I'm opening my gates from my side. Now it is completely depend upon the participants. How much participants is already there?
Currently, we have 54. It is fluctuating between 54 to 56.
Okay. And how much completely means how much team is 19?
Yes, 19
19 and
teams.
one team having how much
what is the exactly number of head counts?
It's not a fixed quantity, but they will have somewhere between 25 people, 23,
In
25 people
one team.
per team. Yes.
So it will be toll should be goes more than 400. I think so.
Yeah, it should. It should
It
go.
should be, yes, yes. So per question, per person, at least they have a 4 questions. So it,
Yes.
it will be a
It will
4,000
account to more
question
than
for me.
1500 questions, right?
Yes, yes, yes. So these are, I'm expecting this amount of questions from your side, means from participate. So it will be actively participation. Otherwise, it will just what we can say, it is just a show.
Yes.
Yeah.
Let's do one thing, guys. Let us have a 5 or 10 minutes break, and then we can join again at 5 p.m. Then we will have a session on DFME and DVP of engine. Dr. Vora is going to deliver that session. Please be on time. Yeah, as you all know, he is very punctual and everything. So let us start again at 5 p.m. Okay? You can have your refreshments until then.
Thank you.
Thank you, Rajiv sir. Yes.
Thank you. Thank you very much. Thank you, Ma.
One more thing, guys. Don't leave the session. The session is going to be, the meeting is not going to be ended right now. Vora sir is joining in 5 minutes. Until then, if you have any generalized query on event and everything, you can just put it in the chat box. We can address it after Vora sir's session has been done with.
Boris sir, am I audible? Bharat, can you check?
Yes. Hello, Saurabh sir. I didn't hear.
Just check with Bora sir. He has joined the meeting. I have given him access.
Yes, yes. Yes, he has unmuted himself.
Yeah, I joined.
Yes. Vora sir, are you presenting or we have to present? Or?
No, I'll be presenting.
Okay, sure. Hello everyone. I guess everyone's back from a short break. To wrap up today's sessions, just give me a minute. To wrap up today's sessions, we have Dr. K.C. Vora. As we all know, he has been associated with BAHA since its inception. He will be speaking on DFMEA and DVP for engine and HCNG kit. This session will particularly focus on design failure modes, effects, and its analysis, and the verification plan for the engines, design verification plan for the engines. The crucial elements in ensuring reliability and safety will be discussed in this session. Dr. Vora, the mic is yours. Please proceed.
Thank you. Thank you, Rameshwar. Rameshwar, are you here, able to hear me and see me?
Yes, sir. Sir, this is Varat. I am able to see you and listen to you. Yes.
Fine, fine. So good evening, friends. And we are on the last session of BAHA SAEINDIA workshop on the first day. I am sure you must have heard numerous speakers, and all of them are, are in very good position in automotive industry, and they spoke on relevant subjects, whether it was engine, whether it was fuel, whether it was fuel injection system, or hydrogen as a technology, CNG, HCNG. You heard them a lot, right? When it comes to designing a product, so if you look at BAHA vehicle, here you can see a BAHA vehicle which is moving, and with that, what do you say, a terrain, tough terrain, when the BAHA vehicle moves, its drivability becomes very, very important. That is why many teams convert their vehicle into four-wheel drive, so the drivability is much better. So whenever we design a product like a BAHA vehicle or a passenger car or a two-wheeler or a component of any wheeler, for example, a cylinder or a fuel injection system or a piston or a connecting rod, these are all called products, right? And we need to design this product. And when we design this product, it happens that after we design this product, somebody else manufactures this product, and then we find failures. When we find failure, there is a blame game. Said मैंने तो डिजाइन बराबर किया था, लेकिन बनाने वाले ने बराबर बनाया नहीं, राइट? या कोई बोलेगा हमने तो डिजाइन बराबर किया था, उसका मैन्युफैक्चरिंग भी बराबर है, उसका मटेरियल्स भी बराबर है, लेकिन जो यूजर है उसने मिसयूज किया या ओवर यूज किया, इसलिए वो फेल हो गया, राइट? जब फेल होता है तो नुकसान किसको होता है? किसको होता है नुकसान? कैन समबडी unmute and tell me? Are you allowed to unmute and tell? When a product fails, who is at loss? The user, the producer, or a dealer? Bharat? Am I audible?
Yes, sir.
I want somebody to answer, but do you have to unmute them, or they can unmute themselves?
No, they cannot unmute themselves. I will do that.
Yeah. So I would like to have an interactive session. Maybe they can raise their hand, and you can.
Bharat, they have written in chat. Can you read it?
Yes, yes. Aniruddha H is trying to say end user.
Yeah. So I would say all are at loss. The end user is at loss because he has paid money for it and he is not able to use it now, and he will be the most painful person. But the dealer also will be unhappy because people will not go to dealer next time and say, "ये dealer अच्छा नहीं है, ये service अच्छा नहीं देता." Or they will not buy the vehicle from that company. No, this company produce useless products and we must not buy from them. So it is loss to everyone, and then it's loss to the nation. So we need to find out what goes wrong, how can we avoid this failure, and what are the causes and consequences of this failure. माने ये failure का mode क्या है, इसका cause क्या है, इसका effect क्या है, all these things you must know, and that is what we call it as design failure mode and effect analysis. There is also another failure mode called process failure mode and effect analysis. Like I said, I have done a perfect design, but you have used the wrong material or you have used the wrong process. If the process is wrong, for example, the welding method is wrong, or the machining method is wrong, or the assembly method is wrong, then it is called process failure mode and effect analysis. So in short, we have DFMEA and PFMEA. And as a BAHA SA India student, you are supposed to understand what is DFMEA and PFMEA. Then comes DVPNR. When I say DVPNR, it is Design Verification Plan and Report. So once you do design a product and say you have decided the vehicle, the maximum speed of this vehicle would be 55 kilometers per hour. When your vehicle is ready, how do you ensure that it is still running at 55? The maximum speed is 55 kilometers per hour. So obviously you have to run it on the road, or you have to run it within the four walls of your college boundary, and check whether it is running at 55 kilometers per hour. So you can check it from your speedometer, or you can find out various devices which will tell you what, or the speed. We can find out the speed by the distance traveled, by the time taken, right? So run it for 100 meters, find out what is the time with the stopwatch, and that 100 meters divided by the time taken will give you time in meters per second, and then you can convert into kilometer per hour. So that is called design validation. So in design validation, when you talk about the performance of a BAHA vehicle, you talk about what is the maximum speed, what is the maximum acceleration of the vehicle, what is the minimum turning circle radius, what is the braking distance. All these are performance related design validation plan, right? So when you plan it in the beginning of the year, it is called plan. And when you test it and report it, it is called DVPNR, that is design validation plan and report. So with this background of what is design failure mode and effect analysis, what is process failure mode and effect analysis, and what is design validation plan and report, I would start my presentation. Okay, so we talk about product development. When we design any product, we call this process of designing as a new product development. It is not possible to just design a product in a fraction of time. It has to follow a process. When you say it has to follow a process, you need to write down what are you going to design. So in the first or second slide of your preliminary BAHA, you write down that this is my vehicle, its weight would be this much, and like what we discussed, the maximum speed of the vehicle would be this much, the width of the vehicle would be this much, the length of the vehicle would be this much, the height of the vehicle would be this much, right? What is the front vehicle weight, what is the rear vehicle weight, what is the overall weight, what type of steering system would you use, what type of brake system would be used, what type of suspension system would be used. All this, if you write it down in the form of a slide or in the form of a form, then that is called product concept form. Now, when you fill up your product concept form, then you have to convert that product concept form into a design. आपने जो लिखा है उसको एक रूप देना है. You have to give a shape and size to that product. So you can make 3-4 different types of vehicles. In a BAHA, the basic concept is surrounded by a roll cage, right? When you see an auto rickshaw, when you sit inside the auto rickshaw, you will see a lot of pipes around you, and that is similar to a roll cage. But in a passenger car, there is no roll cage. It is a monocoque body, right? In some vehicle like a truck, you will see there is a chassis and a body. But in a car, there is no chassis, there is no body. Everything is combined into one monocoque body. But in BAHA, we have a roll cage, and around that roll cage, the entire vehicle is designed. So hence, we need to do various concepts of the roll cage. So you can say that, okay, I will have a higher nose, or I will have a lower nose, or I will have no nose. My height would be this much. Now, how do you decide what should be your shape and size of the vehicle? That 3-4 concepts you decide, you need a logic, right? So your logic starts with the driver. Who is the driver will be my first question. And once the driver sits in the center, you build up the roll cage around him. So his comfort, his convenience, and his ergonomics is very, very important. And this art of ergonomics, for example, if you use an ANSYS tool or an Altair tool, you can find out the vision, the field of vision, whether he's able to see in all the direction and every direction in the front, and whether his hands are able to reach the steering wheel, his feet is able to reach the brake pedal, whether there is a sufficient gap between the top portion of his helmet and the upper part of the roll cage, whereas there is a sufficient clearance between his elbow and the side part of the roll cage, and so on. So you make 3-4 concepts and then you try them out. How do you try them out? You do a C analysis to find out what are the stresses on those various parts of the roll cage with different input conditions: front impact, rear impact, side impact, rollover, static, dynamic. You do all those C analysis, and after doing C analysis, find out the maximum stress in that roll cage in a particular condition, and then find out what is the factor of safety. This factor of safety obviously has to be more than 1, but if the misuse is more, for example, you are designing a 6-seater vehicle where you find 18 people, that is 3 times the people sitting on the outskirts of your city, then the factor of safety should be 3, because 3 times the people are sitting inside it. So then I will use a factor of safety 3. If you are running that vehicle on a very tough, rough terrain and a tough terrain like that of Baha at Pithampur, Natrax, then you will decide that I must have a factor of safety of 2, right? So generally a Baha vehicle will have a factor of safety between 1.5 and 2. If you do a factor of safety more than 2, then we say that it is over design. Your weight will be higher, cost will be higher. If it is less than 1, then it is unsafe because it has met the stress level and it may fail, it may yield, right? So then you also find out deflection and so on. So conceptual design is design based on the customer requirements and the driver's comfort. So based on those various design, you do the design review. Sorry. So here you can see DR1, DR2, DR3, DR4, and DR5. So these are design review 1, 2, 3, 4, 5. So you first do the design review of the concept, then you make the entire design, you make the design such that it can be productionized, then start working on the production preparation, get all those things what is required for production of those components. And also some of the components are purchased from outside, like you will purchase tires from outside, the pipes from outside, and sometimes even the suspension, steering, and brake system from outside. Then who are your supplier? What is the quality of that supplier? Probably you go to that supplier and talk to him, understand, find out what is the cost and come back. So if you produce yourself, it is make. And if you buy it from someone, it is called buy. So you have to make a make or buy decision. Make a bill of material that these are the various parts of my vehicle. So for example, there are 200 parts. Then write down those 200 parts, and against it, write down whether I will make it or buy it. If I make it, what is the cost? If I buy it, what is the manufacturing cost? Then you do a detailed design, then again do a design review, then you make a prototype, then you make a design review, then you do a trial run. So it's equivalent to a validation, and then do a design review, and then you do an initial production, produce some one vehicle. In factories, they produce 100 vehicles, give it to the known customer, get their feedback. So the customer feedback is design review 5, and then start your mass production. In your case, you are not doing any mass production. Yes, you are assuming that you are going to produce 4,000 ATVs per year, but actually you produce only 1 vehicle. At the most, you can produce a rough prototype and then the final product, right? I will be moving faster, but at initial stage, I want you to understand the new product development step, and this is what industry do. And what we want you to do is what industry do, so that when you are selected in the HR meet and you join that industry, you are a ready-made engineer. So the job of BAHA is to make you knowledgeable, not only in terms of technical knowledge, but also in terms of skills, so that you become industry ready when you join the industry. Or you can become a startup and you can do something of your own. So this is called the house of quality. Here you can see that the green portion is the voice of customer. So whether it is the driver himself becomes your customer for whom you are designing the vehicle, or the judges can become your customer, or the people from technical automotive industry where you are going to work will become your customer, right? Or the vehicle, or the people to whom you are going to sell your vehicle will become your customer, or the investors who are going to invest in you, or the shareholders will also be your customer. So you will have to capture the voice of the customer. One way for you to capture the voice of customer is to read the rule book. The rule book itself is the voice of customer. So read the rule book, talk to the driver, talk to technical people, talk to judges, talk to the organizers if you have a chance, and then understand what is the requirement, and those customer requirement needs to be converted into technical requirements, and that is what is called as QFD, that is quality function deployment table, or capturing the voice of customer, VOC. So once you capture the voice of customer and convert the customer voice into a technical requirement, plus you can do benchmarking. That means you go to some of the winning team like DY Patil, AISSMS, COEP, right? Or in case of hBAJA, we have the college from Cochin, QSET, and also this you can go to Aurangabad, Samskara, or you can go to Bhimavaram. So these are the three teams. So you can go to their college, write to them saying that we are coming to see your vehicle, go and see their vehicle. I'm sure they would share what they have done. They will not say no to you. And you can benchmark. इन्होंने गाड़ी ऐसे बनाई है, इन्होंने सस्पेंशन ऐसा डिजाइन किया है, इन्होंने ब्रेक ऐसा डिजाइन किया है. तो ये सब आप सीखोगे तो that what we call it as benchmarking. And based on that benchmarking, based on voice of customer, you design your vehicle. Your vehicle may be better than them, equivalent to them, or you थोड़ा हट के भी आप design कर सकते हो. So that people will say this vehicle is much better than last year vehicle, right? So like that you can see a lot of words here. I'm not going to explain you everything, but the customer requirement, the quality, the product planning, your design targets, and then dividing these parts into A, B, and C component, depending on its importance, depending on its cost, depending on its design FMEA. And then you do that design FMEA to find out what can be the probable failures. And if that failure is very severe, which can take the life of a person, or which can increase the emission tremendously, or which can increase the noise tremendously, or the vehicle will fail after doing one lap of endurance, then that is very severe, and then you have to concentrate more on that. Make an action plan that what do you do, how can your design must be so perfect so that those failures do not happen at all. That is what is failure mode and effect analysis. We'll see that in the subsequent slide. Now I will divide the entire process into three parts: the yellow, the orange, and the blue, right? And when I say yellow, it is a design review from business point of view. When you say orange, it is the design from the review from the design point of view. And when I say blue, it is a review from process or the manufacturing point of view. So from business point of view, what is correct, what is not correct, where will we fail, how can we ensure that we do not fail in business, will we make business, will we be able to sell this product, will we be able to make profit. All those things are discussed in business in the form of a business case. Then comes design, that I will do the design, I will do the design concept, I will get it reviewed, and I will also do a risk assessment, which we call it as FMEA, failure mode and effect analysis. And those FMEA can happen at system level, subsystem level, vehicle level, and so on. And then I will do design validation or product validation, and ensure that my drawings, 2D, 3D drawing, digital drawing, physical drawings are perfect, and everything is mentioned in what is the manufacturing process, what is the design process, what is the material to be used, what heat treatment is required to be done, what is the strength of that material. Everything will be mentioned in that drawing, so that when it goes to the manufacturer can understand it, right? So if you design something and somebody else is going to manufacture, your work does not stop at design. You have to continue looking into what the manufacturer is doing so that your design is made as per the design. The product is made as per design. So in process, you have to ensure that what is the manufacturing process. Suppose you decide that I will make a piston and it has to be casted, and I will make a connecting rod which has to be made by a powder metallurgy method, and I will make a crankshaft which has to be forged. So you can see there are three manufacturing processes: casting, forging, and powder metallurgy. And once they are ready, I will do a machining. I can do machining on lathe. I can use milling machine. I can use CNC machine. I can use shaping machine, and so on. So which machine I am going to use? What will be the feed? 1 mm करके मैं कट करूँ या 2 mm करके कट करूँ, all these things, and what should be the surface finish, everything needs to be decided. So material, manufacturing, heat treatment, surface treatment, surface finish, tolerances, limits and fits, everything has to be decided in process, and there also we can do a process FMEA. We'll see some examples of design FMEA and process FMEA in the subsequent slides. So all this, when we do, we need to document, we need to make project records, we need to make documents, we need to do review, design reviews and project review, technical review, and document them, file them properly, right? It can be soft copy, it can be hard copy. Then comes the, once we are ready with this yellow, orange and blue lines, you can see, to make it more simplified, we need to make a product concept. And this product concept has to be approved by the business case. That means it is there in yellow. So the product concept can be made by the design engineer or the businessman, but it has to be verified. So it has to be verified during the design. It has to be validated during the design. We'll see what is verification and validation in the subsequent slide. And then we need to verify it with respect to the process, and then the product would be perfect. So now let us go to design FMEA, and let me explain you what is this FMEA and how did it start. So if I want to define FMEA, then I would say that failure mode and effect analysis, whether it is design FMEA or process FMEA, is a paper and pencil analysis method used in engineering to document and explore ways that a product design might fail in real world usage and find solution to reduce. So he's saying that take a paper, take a pencil, make a table. I'll show you this table, and all of you sit down together, the design engineer, the manufacturing engineer, the test engineer, the inspector, the technical inspector, the cost guy, the sales presentation guy, everyone, all 25 you sit together and do this design FMEA. In that design FMEA, find out various ways by which the product may fail in terms of design, and what do you do if it fails, what are the causes and consequences of those failure, and what design modification will you do so that it doesn't fail at all, is FMEA. So this FMEA is an advanced quality improvement tool. It's a technique used to identify, prioritize, and eliminate potential failure from the system, design, or process before they reach the customer. It provides a discipline for documenting this analysis for future use and continuous improvement. So once you do the design FMEA of a particular product, and tomorrow there is a customer complaint, you modify that. When you modify that time, you have to rerun the design FMEA, maybe that part. Suppose your crankshaft are frequently failing, then you have to redesign the crankshaft and go through the FMEA of the crankshaft at the component level. Okay. So FMEA, I'm not able to change. Yeah. So there is certain inputs and there are certain outputs in FMEA. So in FMEA, inputs are lesson learned, brainstorming, process map, process history, procedures, knowledge, and experience. So what are all these inputs? So whatever is your experience, so you ask the old team, or suppose you are a new team, then you go to an old team and ask, what were your failure last year? So they would say, okay, there was a puncture in the tire, or on the endurance, my suspension gave in or it failed. We were not able to apply brake, or we failed at the brake test. We were not able to ensure that all four wheels brake simultaneously, or the wheels stop simultaneously, or we were not able to steer properly, my steering rod failed, and so on, right? So try to find out from others that what failure happened. And so one such method is called warranty claim in factories. So in real life, what companies do is they give a warranty. Say, for example, they design a vehicle and say, my vehicle will give a warranty of 2 years. You buy a new vehicle, and if it fails, you go back to the dealer and tell them that this part has failed. Please change it. It is under warranty. So the dealer, without asking you question, if he's convinced that it has failed without any misuse or overuse, then he will change that part and you move ahead, right? You are happy that they have changed your part. Now this part, what will the dealer do? Dealer has changed the component, but he has paid certain service for changing that component, and he has used an additional component, and he has now got a failed component. So usko to nuksan hua, he has to get this money back. So he will send the failed component to the original company from where this product has come. We call it as OEM, original equipment manufacturer, or the vehicle manufacturer. And he will say, okay, these are the failed part. In this month, 10 crankshafts have failed, 5 air filter has failed, 5 fuel filter has failed, and so on. And he will send all those failed components to the company, and the company will reimburse him equivalent amount. And maybe if there is any service cost, company will pay him the service cost. So that's called warranty claim. Now, once all those failed parts come to the factory, which comes through the service department, the service engineer will call the design engineer and say, okay, these are the failed parts. So they will see all those parts which are failed. They will take photographs. They will see what is the cross section of the failure, what is the grain size, all those things. And then they will try to find out what is the effect of that failure. So when they've tried to find out the effect of failure, that's what we say, failure mode and effect. How it has failed, what is the failure mode, and what is the cause of this failure, and what is the effect of this failure. So what is important? The cause is important or the effect is important? Let's see. Please write down in the chat box and let me see what is important. The cause is important or the effect is important? Let me read. I am not able to see the chat box.
Sir, okay, I'll let
Yes,
you know.
yes. Yeah, tell me.
Sir, Govardhan replies with cause.
Yeah. What is more important, the effect or the cause?
The effect, 3 people with effect.
And how many are saying cause?
One of them is cause and 3 of them are effect.
Okay. So it is the story of a chicken and egg. If there is a cause, then the effect will happen, right? If there is no cause, the effect will not happen. But cost is more, the effect is more important because effects will show the failure. It can take somebody's life also. So effect is more important. I do agree. But again, it's a story of chicken and egg. So both are equally important. Cause is the initiation of the failure and effect is the output of the failure. If you don't want the output of the failure to happen, then if you understand in the beginning only what are the various effects, and based on the detrimentality of those effects, if you can control the cause and ensure the failure doesn't happen at all, then cost becomes very important. So for a designer, cost is important. For the user, the effect is important, and hence both are equally important. As I told you, it's a chicken and egg story, and hence it is very important that you guys must look at cause and effect together. So in a wishbone diagram we draw or a cause and effect diagram, both are equally important. अगर कॉस्ट नहीं होगा तो इफेक्ट नहीं होगा, और अगर इफेक्ट होगा तो हम उसको कैसे एलिमिनेट करें वो भी हमें सोचना है. So when you do a design, then it is called design FMEA. And when you look at the process, when I say process, it is manufacturing process, it is material, it is assembly, it is welding, machining, everything becomes a part of process. So then we do a process FMEA. Obviously, design FMEA is done first and process FMEA is done later on. Okay. So here it is. Let us look at the sequence. If you look at the sequence and if you look at the arrows, we start with the yellow ellipse. which says how can the system design process service fail. So it is not that FMEA is done only for a product, it can be also done for a process, it can be also done for a service. अगर चाय वाला चाय बेचता है तो उसमें भी क्या गलती हो सकती है, उसमें भी क्या फेलियर मोड हो सकता है. फॉर एग्जांपल दूध फट गया है, या we have put less sugar or we have put more sugar, it is more sweet or it is less sweet, right? Or we have used the wrong tea, या टी बहुत पुराना है उसमें थोड़े जीव है. So there are so many ways by which you can analyze the service of supplying tea or offering tea to a customer. So here we are talking more related to the BAHA vehicle. So how can the design system fail? How can your BAHA vehicle fail? What is the effect and how serious is the effect, right? So what is the effect? That suppose, let's say that the vehicle has, your BAHA vehicle has to meet the emission norm, and it has to meet the BS6 emission norm. If it has not met the BS6 emission norm, then your type approval certificate is withdrawn. So institute like ARI will say, no, this vehicle is not meeting BS6 norm. Please pull out all your vehicle from the market, right? And we don't give you type approval certificate. You cannot sell this vehicle in the market. The RTO will say, show me the type approval certificate. And if you don't have a type approval certificate, your dealer cannot sell. He will not get the registration number of the vehicle. So this effect is very serious because you are not able to sell the vehicle at all. So this effect is equivalent, the severity of the effect is 9 out of 10 or 10 out of 10. So it is serious, the effect is serious. Then what are the causes of the failure? So आपका emission क्यों बढ़ गया? Why it is not meeting BS6 norm? It is not meeting BS6 norm because the engine is not correct, or the fuel use is improper, or the combustion process is not correct, or the after treatment device is not correct. So you already heard the lecture about the fuel, that is CNG, HCNG and hydrogen. And then you heard about the engine from Dr. Kalimuddin. He has to design the perfect engine. If he designs the wrong engine, then also it will not meet the emission norm. But you heard Makarand Lad saying that engine is not the culprit. It is the fuel which you are using can be the culprit. So if you use the wrong fuel, for example, if you are using gasoline or a petrol, and if the sulfur content in the petrol is high, or there is a lead content, lead is abolished now, but if there is a lead content in
I think Dr. Vora lost his internet connection.
Can you ring him up, Bharat? Or can you ask Rameshwar to do? Bharat, can you hear me? Bharat?
Yes, Saurabh sir, I can hear you. I was
Just ask
having
someone to
problem
ring him
with
up,
Windows.
please.
Yes, sir, but
Yeah.
Rameshwar is calling. Hello. Hello, Vora
Yes,
sir.
yes,
Can you
yes,
present?
yes. Yeah, I'm back, and I'm sorry
Yes.
my laptop got discharged, so I have not done the failure mode while giving the presentation, right? So let me start the presentation again from where I stopped. So I share screen, share. Okay. So are you able to see the slides, Rameshwar? Bharat, are you able to see the slides?
Yes, sir. We can see it.
Okay, fine. So we
Sir,
continue.
just one thing. Make it full screen.
Yeah, sure. So we were halfway through this circle. First, you have to find out your system. When will your system fail or a component of that system will fail? Find out what is the effect and how serious that effect is. Find out what is the cause and what is the likelihood of that cause of the occurrence of failure. How many times this failure will occur? And can we prevent this cause of failure? And how easy it is to detect the cause through the design? And how can we minimize the risk of failure? All these things you have to do during design FMEA. These are all done through numbers. There are 3 set of numbers, and I'll explain you those 3 set of numbers. So before you do this design FMEA, you have to make a block diagram and you have to decide your boundary conditions. So here you can see that, okay, I have put, in this case, I'm doing design FMEA of a Greaves engine. And when we talk about this Greaves CNG or HCNG engine, there are various ways. There is an intake system through which the air is coming. There is a fuel system through which fuel is coming. There is an exhaust system through which the exhaust is going out. There is a cooling system. There is a lubricating system. There is an ignition system. There is a crankcase ventilation system, right? And then there is a combustion system. There is a battery through which you start the engine, right? And then there are engine mounts, which you mount the engine on the vehicle, and you have to ensure that the vibration of the engine is low and it doesn't pass on to the driver and so on. So you will see that once you make a boundary diagram, you will find out what are the interfaces and whether those interfaces are in terms of physical interface or an energy interface or a data interface or a material or an indirect interface. So this is called the boundary diagram or a block diagram. You have to first draw the block diagram and decide your boundary condition. That my design FMEA is lying into that big rectangular box related to engine. I am not going to talk about the peripherals, but I will understand the effect of that peripherals to the engine. Okay, so that is one part. Then we go to the next slide. And then this is the famous table. Let me minimize this. Yeah. So you can see this table, failure mode and effect analysis. And this table is available on the website of BAHA as FMEA. So there are 2 documents or 2 sheets, Excel sheets available on the website of BAHA. One is called Design FMEA, another is called DVPNR. So today, right now, we are talking about Design FMEA. You will see there are various columns, but there are 3 columns, 3 thin columns. They are called Severity, Occurrence, and Detection. And there is one more column called RPN. So when I say severity, how severe the potential effect of failure is, that is called severity, which you have to rate between 1 and 10. There is no 0. Similarly, if there is a potential cause, how frequently this failure is occurring because of this cause, again between 1 and 10, that is occurrence. And third is detection. How good is your design to detect a failure is called detection. So that is also between 1 and 10. So severity between 1 and 10, occurrence between 1 and 10, and detection between 1 and 10. If I multiply all these 3, and if all 3 numbers are 1, 1, and 1, then the minimum number of multiplication is 1. And if all are 10, 10, and 10, then the maximum number is 1000. So RPN, which is the product of severity, occurrence, and detection, is called risk priority number. And the risk priority number varies from 1 to 1000. And if it is 1000, that means the risk is very, very high. And if it is 1, the risk is very, very low. You don't have to worry. Generally, we say if the risk is more than 200, then there is a heavy risk, and you have to solve all the risks which are between 200 and 1000. Higher the risk priority number, higher is the priority to do its risk analysis and try to find out a solution. So the solution which you try to find out to reduce the RPM number is called recommended action. We will see what type of recommended action could be. And the next column is response and target completion date. So who will do it? Whether Snehal will do it, whether Rameshwaran will do it, or whether Varad will do it, in your team will decide the responsibility and what is the target, by what date you will finish this. You will try to finish it within a month or 2 months or so on, but obviously it cannot be after the event is over. So what I want to tell you, in preliminary BAHA, which is going to happen next month, you have to fill up this failure mode and effect analysis sheet, download it from the website and start filling when you sit with the team, except the last 5 column. You must not fill up the last 5 column until you make the vehicle and test them. So other than last 5 column, please fill up this and decide what are the recommended action. So I will give you one example, very simple example. For example, I would say that my roll cage must not fail. If the roll cage fails, right, then the effect is 10. It can affect the driver. It can affect the life of the driver. So if it affects the life of the driver, or if it affects 9 or 10. If it gives a warning, then it is 9. If it does not give a warning, it is 10. So if you are designing a roll cage, like we make a pack of cards, we make a pack of cards and make a house of the pack of cards, और एक फूक मारा तो वो pack of cards टूट जाता है. That means it is not very strong. And if you make a roll cage is equivalent to a pack of cards which can break very easily, then if एक रोल हुआ या एक इम्पैक्ट हुआ तो तुम्हारा आपका पूरा रोल केज टूट जाएगा. So then the driver is unsafe. Then it is its severity is 10 because you are not getting any warning. Then comes the occurrence. So you try to find out what is the cause of this. The cause of this is factor of safety is less than 1 and you use the wrong material. This can be the 2 causes. That you use the wrong material, your design is correct, but you use the wrong material, but wrong material will come in process FMEA, not in design FMEA. So you can say in design FMEA, your design calculations are wrong, your factor of safety is less than 1. So what is the what is the recommended action? Recommended action is that I will ensure that my factor of safety is between 1 and between 1.5 and 2. That is my recommended action, right? And how will you detect it? It is very easy. You do a analysis using NC, Altair, or any software, CAE software, and then try to find out the maximum stress. And then from that, you try to find out the factor of safety. Now, if your factor of safety is more than 1.5 and less than 2, then I'll say my design is 100% safe. And my recommended action is I write down in the drawing that the factor of safety for the roll cage in front impact, rear impact, side impact, rollover is between 1.5 and 2. Not more than 2, otherwise it is over design and over cost and overweight. If it is less, then it will fail. So that is a recommended action. Who will do it? XYZ will do it, and they will do it by say 5th of September. So you stop here. And then you also do design FMEA of suspension, steering, brake, also do design FMEA related to performance and all those things, and close this and present it in phase 1. After you present it in phase 1, then in phase 2 and phase 3, when you make the vehicle, after making the vehicle, you do an analysis to find out, you run it for say 10 kilometers and find out whether the roll cage is breaking or not. That is one way to prove yourself, to validate. Second is, you have already done a C analysis. You must have made 3 concepts and then find out by which concept the factor of safety is between 1.5 and 2. Then that is you have completed your recommended action. When you complete your recommended action, your severity will not change. Severity is what if it fails and what is the severity. That never changes. Occurrence will change if you have run it for 10 kilometers and there is no failure, then the occurrence has come down. Initial state, the occurrence was an assumption that okay, let us put an occurrence number of 6 or 5. You can jointly decide that. But after running it for 10 kilometer or maybe running it for 100 kilometer, if it doesn't fail, then your occurrence will come down. It may become 2 or 3. Detection will further come down because you have come up with the design criteria that my factor of safety should be between 1.5 and 2. And that's how, if you multiply again severity, occurrence and detection, where severity is same, occurrence and detection is come down, then your RPM will come down. And that's how you can say that using design FMEA, I have been able to reduce the failure. Now, this last 5 column, you have to fill up in phase 2 or phase 3, but not in phase 1, because you have still not made the vehicle. You cannot do that. You have still not taken the action. Clear? Like that, you can write down all failures and fill up this table. How do you give the numbers of severity, occurrence and detection? I'll show you in the subsequent slide. Let me go there. So first I'll go there and then come back. So here is the occurrence table. If the failure happens again and again and again, then its rating is 10. And if the failure happens, say 0.10 per 1,000 vehicle, then the rating is 1. So for example, let us take, you make 1,000 vehicles and out of that one vehicle will fail. Then the occurrence is, here you can see 1 per 1,000 vehicle or item, then it is 4. So if you make 1,000 vehicle, if Mahindra makes 1,000 SUV Thar Rocks, and they sell this 1,000 vehicle, and out of that 1,000 vehicle, one vehicle fail, then the occurrence is 4. But Mahindra is not just going to sell 1,000 vehicle. They may say they may sell 100,000 vehicles, right? If they are going to sell 100,000 vehicles, and there if one vehicle has failed out of that, then you don't have to worry. It is the occurrence is only 1, right? So it depends on how many vehicles you have sold, right? Okay, somebody has come in. Okay. It depends on how many vehicles you have sold or how many vehicles you have made, and in that how many vehicles have failed, component wise or system wise. Accordingly, the ranking is given. So everyone is clear how the occurrence table. If the failure is occurring again and again, then the rating is higher. If the failure is occurring very rarely or not at all, then the failure is 1. Okay, that is about the occurrence table, and you can all sit down and jointly decide what is the number. Next is severity table. So I told you that if it is taking somebody's life, if it affects the safe vehicle operation, the vehicle stops moving at all, or the vehicle meets an accident, or the causes are such that suppose your brake fails, then it will meet an accident, there may be an head-on collision, then the severity is 10. Or if it is not meeting BS6 norm, it is not meeting emission norm, it is not meeting any crash test norm, then you can say the ranking is 10. But if you get a warning, then it is 9. Suppose your lubricating oil pressure is going down, and you can see it on the dashboard of a car that my lubricating oil pressure is not getting built and it starts blinking. That means if there is a warning. So when the engine lubricating oil pressure goes down, the severity is 9 and not 10 because you get a warning. Or your battery is getting dead, it will come on your screen, then again it is 9. So if there is any warning, then it is 9, and if there is no warning, it is 10. And in case if a performance is partially, so you are running at 55 km per hour, you designed for 55, but you got 50 km per hour. So there is partial reduction of performance, then your severity is 7, 8, 6, like that. And if there is a squeak or rattle or there is a scratch, आपकी गाड़ी में scratch लग गया, तो it is the severity is only 2. And अगर उसमें squeak and rattle है, थोड़ा आवाज आ रहा है, टक 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 गर गर गर, then उसका 3 या 4 है severity. But if your function is not there, the component for which the function for which it is designed, if it is not happening, then severity is 7 or 8. And if it is a very unsafe mode, then it is 9 and 10. So that's how the severity number is decided. And third is detection. How good is your design? If your design is good and it is almost certainly detect a potential cause of a failure, then it is 1. And if your design is very, very poor and it is not able to detect the potential cause and it leads to a subsequent failure, then the rating is 10. So 10 means very bad, 1 means very good, and your number will be between 1 and 10. And your aim is to reduce the number as much possible through proper design and redesign. And that's how your RPN number, the product of these three numbers, will go down. Okay, let's go back. So you can saw the table, and then there are certain guidelines. For example, we will tell you that only you look after the battery or the battery manufacturing system, so battery management system if it is an electric vehicle, or we'll say, okay, you look only after the cylinder or CNG or HCNG cylinder, or look after the engine, right? Or look after your suspension, steering and brake. Then you have to do design FMEA only of those components, whether you do it combined or whether you do it separately. Okay. So everyone has understood. List out all the function. Consider what are the effects. These effects are not real effects. These are the assumed effect or probable effect. Then find out how severe it is, how often what is the cause and how often it appears. What is the possibility of its detection? How good your design is that it will detect the failure, and the multiplication of these three numbers, that is a risk priority number. Then putting that risk priority number in the descending order and taking higher risk, finding out solutions for higher risk number first and lower risk later on, and then finding out what is the risk priority number, and those numbers have reduced or not, and whether everything is within 200 or not, is what is the FMEA. Okay, so the same thing is explained in a different way. Find out what is the potential failure mode, find out the severity, find out what are the causes of those failure. So one failure mode may have 3 potential effect, and each of this effect may have 2 or 3 causes, right? And so this will multiply, and this can run in 10 pages also. But you have to just do 1 page and just show it to us, that minimum 1 page, but you can do 10 page also. Then you find out what is the occurrence of those causes, what are the detection number, what is the risk priority number, and what action you are taking to reduce the risk. So this is what is the sequence. We already saw the 3 table. So severity plus occurrence plus detection will give you risk priority number. You can take all the failure about 200, or you can take top 20% of the failure by RPM and try to find solution for this. So here there is some examples. For example, you have done, I told you about the roll cage, that the roll cage must be strong. It may fail in bending, and because the impact load causes stress concentration and there was a fracture, right? So how do you reduce the stress? How do you improve the factor of safety, and so on? And similarly, you can see steering, brake, transmission. This is all design FMEA. Similarly, you can do process FMEA in the bottom 25%, saying welding or machining, and what is the failure mode. Welding is not, welding में ज़्यादा weld कर दिया तो that part has melted and broken, right? And so on. And then you find out the risk priority number and then recommended action. As I told you in preliminary BAHA, you have to just stop at recommended action. The last 5 columns has to be filled up in phase 2 or phase 3. Okay, fine. So some more examples. So these are not done by me. These are done by your teams. I've just taken some of the examples. So you can take one and go into deep, or you can take brake separately, transmission separately, vehicle dynamics point of view, that is suspension, steering, and so on. Okay. So that was all about design FMEA. Now, am I audible, Bharat?
Hello. Yes, sir. You are audible.
Yeah. So we are done halfway, and then I will talk about the remaining half. That is the design validation plan. You do the entire design FMEA, but if you don't do the validation, it's of no use. Your design FMEA will be fruitful only if you are able to validate and find out what happened to those last 5 columns, right? To fill up those 5 columns, you have to do the validation. So it is said that the last 6th column, that is 6th last column, which is the recommended action, the recommended action has to come in DVPNR, and I'll show you the DVPNR form here. Here is the DVPNR form. So what are the recommended action? For example, we said your recommended action is to ensure that factor of safety is between 1.5 and 2. Then here you must say serial number 1, level vehicle aggregate or part. Your part is roll cage. So here you write down roll cage. and then here you write the performance target. So for example, okay, I can minimize this and see if I can write. No, I won't be able to write because this is a slide. But if it's an Excel sheet, I would have written. So you write a roll cage. In the performance target, you write what the factor of safety. You have to check you have to do a C analysis and find out the factor of safety. In the acceptance criteria, which is a quantifiable target, you say that factor of safety should be between 1.5 and 2. Validation test method, then you can say I will do C analysis using Altair or ANSYS and so on. And then the test resource and equipment. So the license of ANSYS or Altair, which is available to you free of charge, you must have got an email saying that how do you get a free license, whether it is license related to IPG car maker or license related to MATLAB, ANSYS, Altair, all those are given free to BAHA team members. And how many times we'll do. So for example, you're going to do a brake test, then you will say, I will do brake test 3 times. Then you write the number of tests there. When will you start that? When will you end that? And what are the remarks? Remarks means whether it is passed or failed after the test. And in case you are reporting in a very systematic way, then you're going to make a 2-page report. Then you make a 2-page report because you just can't write in remarks in 1 word. Right? For example, I have said C analysis, it has to be the factor of safety is between 1.5 and 2. Then you will say that, okay, in front impact, it is 1.7. In rear impact, it is 1.8. In rollover, it is 1.9. So it is either 4 number. In those small block of remarks, you cannot write like this. So you make a report, write down all those factor of safety there, write down what is the average factor of safety, and then say, give that report number 1. And then you write more details are given in report number 1, but the work is done, right? So like that, you have to write all this validation. After you write all this thing, and first you do a DVP, when you make a design validation plan, then you do it only till last 2 columns. Except the last 2 columns, you fill up everything in phase 1. That is called design validation plan. But you have not done the testing, you have not written the report. So that R stands for report, design validation plan and report. Since you just made a plan, but the report is yet to come, you are yet to make the vehicle and yet to test it and yet to report. So last 2 columns you must not fill up and be ready in your phase 1. After phase 1, when you make a vehicle, you do all those tests and then put the remarks. So for example, I say my maximum speed of the vehicle, performance target, maximum speed, acceptance criteria 55, not more than 55 kilometer or more than 55 kilometer per hour, or you can say it has to be between 55 and 57 kilometer per hour. Then you fill up all this thing. And when you do the actual test, you run the vehicle on the track near your college and say, okay, the maximum speed I found is 56. Then you write here in remarks that, okay, it is 56. And then you make a separate report for that. So that is called DVP. So now you will see the output of design FMEA is the input to DVP, and the output of DVP and R becomes the input to revised design FMEA. So once you fill up the last 2 columns of the DVP, it becomes DVP and R. And this, based on this last 2 columns, you go back to design FMEA and find out whether your risk priority number is reduced or not by filling up the last 4 columns. So that is how input of design FMEA is your experience and failure mode and lesson learned, and the output of design FMEA becomes the input to DVP. Output of DVP and R becomes the input to revised design FMEA, and the revised design FMEA with lower risk priority number becomes your confident that your vehicle will never fail, right? Okay, so that's about DVP. We slightly go through into the DVP part and then come back. So DVP is a process by which you find out that whatever you design is correct or not, right? Are we building it right or not? So the documented act of providing any procedure, process, equipment, material, activity or system actually leads to the expected result, then it's called validation. So design validation means establishing by objective evidence that the device specification or the product specification conforms to your user needs and intent. So as I told you, maximum speed, acceleration, turning circle radius, braking distance, these are all performance related. whether it has met those performance requirement or not, right? So that's design validation. And there can be a design plan, a validation plan, validation review, validation methods, and validation report. So here you can see that once you make your product, you review them at various stage, right? So user need means capture the voice of customer, then find out what are the design input, do a design process, design output, and do verification. For example, if you do a C analysis, that means your design input are the loads, and then you design process is the CA analysis, and your output is the factor of safety. Then, and if that factor of safety is between 1.5 and 2, then you can say, I have verified the design. So that is verification. And when you make your car and run it for 100 kilometers on a track near your college, then that is called validation, right? So everyone has understood the difference between verification and validation. Okay, let's go ahead. So design FM. So here it says design verification. Next step to design FMEA. Depending upon RPN in design FMEA, the components are arranged in DVP. So wherever there is a higher risk priority number, please ensure that those recommended action are added in DVP, and it contains all information regarding the acceptance criteria, responsible person or team, type of test, start. So if there is in the acceptance criteria or in the, I'll go to the table again. If there is a particular standard, then you can write. So here it says acceptance criteria and the performance target. So in the performance target, you can write down AIS number so and so. So today somebody must have talked to you about hydrogen, HCNG or CNG, automotive industry standard. So if you are going to test as per that standard, then your performance target is AIS number XYZ. And whatever is mentioned in AIS, that acceptance criteria becomes your acceptance criteria and target, right? Okay, fine. We go back here. So there are various methods of validation, whether you test it, whether you do a CA analysis, or whether you physically inspect it, or compile it and compare it with the relevant specific literature, and so on. And examples of validation method are worst case analysis of an assembly, fault tree analysis, failure mode and effect analysis, package integrity test, testing of material. So if you buy a roll cage, then you must have a test report also of the roll cage. What is its chemical analysis? What is its strength? What is its yield strength? What is its tensile strength? So on, right? So it is not just way. FMEA is just one way of doing it. There are 6 ways. Okay. So product design, we need to verify the product design, whether it is related to its functional performance, operational environment, reliability, usage, safety, interface, maintainability. All this has to be validated directly, indirectly. Okay. So steps for the product design validation, early stage validation, you can do some C analysis, conduct design review and design requirements, build one prototype, right? So in phase 1, you can make small prototype. You can use rapid prototyping, you can use straw, you can use plastic pipes to make a roll cage, and so, or you can use thermocol to make your vehicle body, how it looks like, and all those things. So that is called a beta prototype. And then you fill up, that is called an alpha prototype. Then you build up full size prototype, then it's a beta prototype. Perform design verification, testing on prototype, evaluate and verify prototype performance, resolve performance concern, and build more prototypes for testing, and then sign off the design. This is done at the factory when you have to make hundreds and thousands and lakhs of cars. But here, if you're going to make one BAHA vehicle, then couple of small size prototypes are fine, and then but you make only one vehicle. Yes, you can make vehicle every year. If you're participating every year, then maybe in 10 years you will have 10 vehicles lying in your workshop. You can convert that into a museum. So whenever you do any design analysis, you must understand what are the design requirements. You must understand what are the testing requirements, test them, and then based on you update your knowledge and update whether your design is good or not. So that's a design validation flow diagram. So in terms of electronics, especially for the hBAJA team, they have a V diagram called design verification flow diagram, where you capture the voice of the customer, you decide the vehicle target, you drill down those target into subsystem and components, then you design those components, make or buy decision, then you check those components whether you have purchased them or whether you made your own. Especially if you made your own, you need to do the validation. and then you do a virtual validation, a physical validation, and find out whether the customer is satisfied or not, and it has met all the regulations or not, and so on. So you go downward in the V shape and design the vehicle, and then you make the vehicle and go upward, test them, and see that whatever you decided in the beginning of the design, it is meeting those requirements or not. We already saw the DVP and R table, which you can download. So this is one typical design FMEA. You can say that roll cage. Here you can see the factor of safety is more than 1.5, but it cannot be 3, it cannot be 4. So you have to write the limit. It has to be between 1.5 and 2, or it has to be between 1.5 and 2.5 or whatever. Gradability has to be 65%. My weight must not, here you can write more than, less than, equal to also. My weight must not be more than 170 kg. Maximum speed must not be more than 60 km/h. My acceleration should be around 6 meters per second. All this performance related you can write, and whatever is the output of design FMEA, that also you can add into this. Okay, so related to performance, related to suspension, steering, brakes, related to your fuel injection system, related to your HCNG cylinder, everything you can write. From safety point of view also, you have to do design FMEA and DVP. Okay, fine. So with this, I've come to the last slide. As I told you, this is a guru mantra. This last slide, I always say, output of compilation of failure, things gone wrong, means what went wrong in your last competition. If you were an old team, like we have 3 old team, or we call them as a returning team, they will do lesson learned. You don't have to do lesson learned, but you can find out from them what went wrong with them, and you can add that as lesson learned. Then output of lesson learned becomes the input to design FMEA. The output of design FMEA is input to DVP. Output of DVP is input to revised design FMEA, and output of revised design FMEA is the input to confidence to clear the technical inspection and win the dynamic event. So if your design FMEA and DVP and the revised design FMEA with lower RPM number is perfect, then you have confidence that you will easily clear the technical inspection. I would tell you that every year, out of the 100% of the team who register, 5% of the team are not able to pay the registration fee, so they are removed in first stage itself. Remaining 5 to 10% of the team are not able to build the vehicle because they don't have that experience, or they are not able to form a good team. Remaining 5 to 10% will not come at the site because of some reason. Halfway through, they have left in between, the vehicle is not complete. Then when they come to the site, by that time 20% is eliminated, and then they do a technical inspection, and around 10% of the team will get rejected in the technical inspection. The design is not proper, the vehicle is not safe, and it is not braking. All 4 wheels are not simultaneously braking. Then also they are rejected. They can only go to the static event like design, sales, and sales presentation and cost, but they cannot do the dynamic and endurance event. I have seen many teams crying because you spend so much of money, you spend so much of year, energy, and so much of time of 1 year, and then the technical inspection says, no, you failed in brake test, you cannot participate in any dynamic and endurance event. You feel like crying. So that's why design FME and DVP are very important tool to improve your confidence and ensure your vehicle do not fail and you don't fail in the technical inspection. So with this background, I thank you for your patience hearing and wish you all the best for the preliminary BAHA SA India 2025. Thank you very much. I'll be very happy if there are any questions.
Just a minute, sir.
You can write down the question and Varad will tell me what are those questions.
Sir, there is a question. Could you please recommend some sources for learning about HCNG system?
Okay, there are good technical papers. These papers are called SAE paper. So you all know that you are an SAE member. So you can go to website www.sae.org. That is an SAE international website. And if you are an SAE member, then you can go to, if you are from Chennai or from South, then you can go to SAE India office in Chennai, where you can there is a facility where you can browse free of charge all this SAE paper, download and take printout of those SAE paper, which talks about CNG as a fuel, which talks about SCNG as a fuel, or hydrogen as a fuel, right? In my opinion, CNG and HCNG are one and same. It is just 18% hydrogen is added in CNG, so it's called HCNG. And there have been cases where Indian Oil Corporation have made such fuel, sold it at the petrol pump. Today, just for your information, any gasoline or petrol you buy from the petrol pump, it may have ethanol or methanol up to 15%. So it is not added, it is just added, you have not been informed. Similarly, you will not be surprised when you are buying CNG, there may be 2%, 5% hydrogen in it. But since hydrogen is costly, no one will just add to make you full. So they may add 10%, 20% or 18% hydrogen in CNG. And there are many standards available. You can go to ARI website and just type HCNG or hydrogen mixed CNG. You will get various AIS standard, automotive industry standards. You can download them. We will be showing you all, we'll be writing down all those standards, AI standards and BI standard, Bureau of Indian Standards, in the design handbook, which we will be releasing very soon. I hope that answers your question.
Yes.
Yeah.
I suppose there's no more questions. Before we sign off the day one, I would like all the members of organizing committee of this workshop switch on their cameras. We'll click a picture together. Gora sir, can you stop sharing? Yes, thank you. Thank you so much.
I don't see anybody else with their video open. All of them are tired.
But you can ask the teams also. Maybe you can.
Yeah, teams
Okay,
also.
okay,
You
yeah. You all can switch on your cameras.
Ask them to unmute everyone. Yeah, unmute and uncover their videos.
So, can we unmute them?
Yeah,
you can unmute them. Yeah.
We can have a small feedback also.
Yeah,
if
we can
required.
have we can listen to their feedback and prepare ourselves for day 2.
Okay, they can unmute themselves now. If anyone wants to speak, the forum is open.
Yeah, you can introduce yourself. You're from which team, which city, college, and then you can ask a question or you can give your feedback.
Yes, guys, if you cannot unmute yourself, just get it into chat. I'll unmute you myself.
There may be a command which says unmute all.
No, I have done it. If suppose there is any glitch or something, we can do it that way.
Yeah, you can put it in chat. If not, let's call it a day.
Yes, absolutely. So let us people who are with their camera on, let us click a picture together.
Yes.
Just a minute. Anyone else from us? Yes, Rameshwar is there.
Rhythm,
Pranjal, yes.
come on. Yeah.
Pranjal, where is she?
Okay. Thank you very much.
Yes, thank you everyone. That brings us to the end of day one. I hope all of the sessions were interesting and equally knowledgeable. We also have another day of learning and exploration tomorrow. So make sure to join us and tune in tomorrow. We will be starting at 10 a.m. tomorrow, and we will be covering we will be covering 5 sessions tomorrow. First one being storage system, cylinder specifications for natural gas, vehicle overall packaging system and system integration. Then we have regulatory framework and safety requirements for natural gas vehicle. Then regulatory framework and safety requirements for hydrogen and HCNG storage. And lastly, we will be ending our workshop by hydrogen production session by Rahul Garg. So that is all we have for tomorrow.
Thank you. Thank you very much. I'll take your leave.
Thank you.
Thank
Thank
you.
you, everyone.
Thank you, everyone. Just wait for it before ending the meeting.
Yes. Saurabh sir, should I give the host role to you?
Just a minute.